Hello, wonderful people of the internet. Welcome back to another episode of Simuleo Zabada. Hey, anyone who might be lurking in chat, hey, thanks for being here. I know it's been like a week, maybe even longer since my last stream, and I do definitely apologize for that. Gonna very briefly explain where I've been, and kind of talk about where we're at and what we're gonna work on today. And yeah, go from there. There's going to be a slight change for today's stream when compared to my normal stream, in that I might not be doing the workout bit, and that's just because honestly I can barely walk right now, so I'm having trouble. Like, I'll explain that in just a second. Emrys, thank you so much for the 13 months. Let me go ahead and put 13 Simule cows in the chat. Simule cow, 13 of them. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Thank you so much for the support, and everyone who's supporting the channel, thank you guys so much. Let me go ahead and open up Zernal PP, and let's just jump into it, shall we? Zernal PP. Okay, right, so, I don't know where to start. There's actually a lot of stuff that happened. So, I mentioned this actually on Discord, and yes, I'm using the light theme for Discord. If you need sunglasses, get sunglasses. I don't care. The point is, I mentioned, I'm really sorry, but it's something kind of that completely exhausted me last week. This was actually last Monday, and that was, I did not stream since then. The thing that happened is still, I'm not going to explain it because it's deeply personal. It was a good thing. It was just something that really exhausted me, and I wasn't really able to, I don't know, just the rest of that day I was just focused working on Grant stuff instead of my own stuff. And that ended up being the theme for the entirety of last week. I actually got my vaccination shot on Tuesday. I didn't have any real negative issues because of it, but I was quite tired, I think, not super tired. I think the second dose is worse than the first dose. But yeah, I just ended up just super busy working on stuff for Grant. So I guess let's start there. With the thing that I was working on mainly last week, which is the summer of mathematical exposition, someone. So basically we have a server now called someone. Let me go ahead and create an invite there. Edit invite link, expire after, I don't know, like 6 hours. No limit, generate new link, copy. Oh, okay. 1 second, I'm gonna have to find a way to paste that somewhere. Maybe there. There we go. Nope, that's not gonna work. Let's do. Okay, let me open up an internet browser and let's paste it in here. There we go. That'll do. Okay. So basically, yeah, so we made the server for the Summer of Mathematical Exposition, me and Grant did. This is basically a way for people to. Here's the full story, okay? Essentially what happened was, we had 2,500 applications, more than 2,500 plus applications. And it was just a lot of things, a lot of people. And we went through every single one of those applications last week. Now, a lot of them we were also sorting as they were coming in, just doing some pre-sort and stuff like that. But yeah, we essentially went through 2,500 applications last week, which was a lot to go through. And we got through all of it basically by Thursday or Friday, and then we sent out everything, set up the server, all that kind of stuff. We only took in, I think, like 3 or 4 interns, depending, I'm not really sure. So, it's like 0.01% chance that you're going to get the internship. But there were a lot of like really, really cool projects. And so we thought, well, what can we do with this? And then we thought, well, actually, why don't we just like, highlight a lot of these really cool projects and give people an opportunity to create a project that they are passionate about, talk about it, and then we'll also judge those, and those that win or are selected or whatever will be highlighted on the 3 Blue and Brown channel, and maybe some other prize that we're not really sure about yet. But this is kind of the whole idea. So if you're interested in talking to people about mathematics, feel free to join the Someone server. It's so far quite good, but honestly, it's been kind of a pain to moderate for a number of different reasons. Like, there's this one guy who keeps appearing for some reason talking about DNA ordinals, and we're like, dude, what the heck is this? This makes no sense. He apparently just like trolls. I actually don't know their gender. They apparently just troll a bunch of like mathematical discords, and they just talk about how, they're trying to spread the word of their religion, which is the DNA ordinal thingamahoosit. I don't know. As long as you're satisfied with what you did, that's enough for me. Yeah, so, again, next week, it's not going to be something that I can, the thing that happened last Monday, I can't talk to anyone about right now. In fact, it's actually, yeah, it's one of those things that I don't really want to bring up too much on stream. But it is related to just a bunch of things that are going to be happening in the next month or so. which also led to me maybe not streaming as much as I should have. So the first thing was the following. I am now fairly confident that I will not be streaming sometime in like from June. I'm going to say June 5th to the 15th-ish, maybe more, maybe less. Let's say to the 20th. And this is because presumably I will be quarantining in Tokyo during that time. And then I also won't be streaming from September, I don't know, like maybe 1st to 15th, something like this. I'm not really sure, because then I'll be quarantining in Barcelona. And yeah, this is just times that I wanted everyone to be aware of. Obviously, June 5th to 20th, that's like in a month from now. And so I was kind of like, man, do I really want to like, start streaming a whole bunch? I like streaming, but I don't want people to get the wrong idea when I'm going to be taking these long breaks. And then I end up taking a week break anyway. So, there's that. As far as videos are concerned, I spent a significant amount of time working on a new video that is just apparently never going to be released because I just don't like it. I tried it again and again, and I just failed at it. And that was, I got vaccinated for COVID on Tuesday. And I'm going to be getting the next vaccine on May 11th. So if I don't stream on May 11th or 12th, it's because apparently it just takes it out of you when you do the second dose. Okay, two other things to update you guys on. The first one is the new video. I really tried my best to make a video on how to read a research paper. I mean, like, I'm going to be honest, I tried so hard on this one because you know me, I love reading papers and I wanted to like convey that enthusiasm to everybody, but at the same time, like I wanted it to be like genuinely useful for people. And it's really hard to walk the line between genuine enthusiasm and pedagogy, in that like it's really hard to like, I don't know, it's hard to walk that line. And when I was describing the video, I just couldn't do it in such a way that I didn't seem either manic or depressive. You know what I mean? And also, like, I just feel like the advice that I was giving was not particularly worthwhile. So I split it up into two sections. The first one was how to actually do the reading, where I talk about what the paper is made up of. It has an abstract, intro, methods, results, conclusion, all this kind of stuff. I talked about the different types of papers, how there's review articles, how there's, standard publications, there's conference proceedings, all this kind of stuff. And so, like, basically the how to read was, step one. But step two, which was equally important, was how to tell if good, right? And this was a bit that I also spent a lot of time on. Like, how do you know if a paper is good? Is it well edited? Are the figures appropriate? Like, all this kind of stuff. And I think even now I have a stream up on my channel that you could look at from a few weeks back when we were going through all this. And these were the questions that I was trying to answer. And, I then started looking up other people who have done something similar, and they were all proposing this method where, like, in order to read a research paper, you first scan through it, and then after scanning through it once, you're like, okay, now you dedicate time to reading it. So basically, they had this method where you read through a paper like 3 times in order to tell if you actually like reading the paper or not. And I was like, I don't understand that. Why not just read the paper once and be done with it? Like, and so I also introduced a bunch of different reading methods that I knew researchers used, but I don't know, I wasn't feeling it. And so in the end, this video on how to read a research paper, I'm going to have to table. I spent like half of last week trying to figure out how to make it, like, it just didn't feel right. And, and one of the big things about my channel is I just, I can look back on past videos and I can say, hey, I don't like that video anymore. But that's the thing. I don't like the video anymore. At the time of creation, I've never uploaded a video that I didn't like. And I'm willing to take down videos that I don't like. And this would be one of those videos that after I put it up, I just don't like it. And I'm just not willing to do that right now. So essentially what I'm trying to say is I don't know when this video is coming out, if ever. So yeah, just letting you guys know that right now. It's something I'm very passionate about, but I have no idea how to tell people about it. So we'll see. So another thing I wanted to update you guys on, the workouts that we do at the top of every hour, I might not be doing them today. Again, I said that just a second ago. I'm not really able to walk right now. If I'm being totally and completely honest, I broke my toe, or I did something, like stubbed it really hard in such a way that I think I broke it like 2 months ago. And like, it's been on and off and on and off. And like this past week, basically after I got the vaccine, I was like, oh, my toe's great. Yeah, I feel great. I can like do everything fine. And yesterday was perfect. I could walk like normally for the first time in months. And I was like, great. It's getting better. And then today I woke up and like, yeah, it's just awful. So I might be skipping the workouts today specifically because I just can't put any pressure on it. right now without like hobbling around. So that's going to be probably an issue for me. And the last thing I'm going to mention is I'm actually going to be doing a little bit of gaming on stream probably today, just to see what you guys think about it. So I don't know how to put this, but I don't usually play too many games. You guys know me. I actually am against most games. And I don't classify myself as a gamer. And when I say that, I always throw in the caveat that I used to spend a lot of time playing one particular game. And that one particular game was Guild Wars. And I'm miserably addicted to it again. And I knew it was going to happen because I started playing it again last week. Essentially after I did that super stressful thing on Monday, I was like, look, I just need to relax for a second. And I started playing Guild Wars again. Now I'm miserably addicted, and I hate it so much. But anyway, the point is, I was going to play it a bit on stream, see if people actually enjoy it, and maybe we can make it a routine thing, not very long every day, but just like a little bit, you know, just to kind of scratch the itch and move on to something else. So, with all that said, that was 15 minutes of rambling to catch everybody up on where I'm at. I hope you guys are all having a wonderful day, and let's go ahead and get started with the question for today, which is how to tell if you're attracted to the Sierpinski triangle. Sierpinski triangle. Oh, perfect. That's how you spell triangle. I was so focused on getting... I still misspelled it. I was so focused on getting Sierpinski right, I just couldn't spell triangle correctly. Okay, so that's our question for today. Now, for those of you guys who were following, maybe last week when we were talking about this in a bit more detail, this is rooted in a very kind of deep question that I think maybe we do need to cover in a bit more detail. So, first of all, what do we mean? Okay, well, first of all, what is the Sierpinski triangle? Well, the Sierpinski triangle is essentially a set of triangles within triangles. So let me go here, CD videos, iterative function system. Algorithm archive, iterative function systems, LS here. And let me just do MPV Sierpinski chaos.mp4. Okay, so this is the Sierpinski triangle. I'm going to just go ahead and get a quick screenshot of this, maybe around here. And I'm going to drop that into Zernal. That should work. You guys might hear like a little like camera shutter noise in just a second. Sorry. I don't remember if I removed that or not. Okay, so let me go ahead and paste that in here. Should be right there. Close that. Move this down a little bit, move it up here. Okay. Sure, that's not the best screenshot, but that's okay. Don't really care. No. Try that again. Okay. Move it down there and move it up here. Okay. So, we talked about this a lot, but one way in order to generate the Sierpinski triangle is through something called an iterated function system. Iterated function system. Here we have a number of different functions. Function 1, I guess we'll say f of 1, of any given point p, will basically return back the point p plus a over 2. Function 2 of point p will return the function p plus b over 2, and function 3 of the point p will return p plus c over 2. So what essentially you're doing is you're creating a set of functions, and you iterate through the functions. So you'll take some random point, here, and then you'll pick one of these functions at random, or not really at random. You technically can go through all possible paths, but the most common way of implementing the iterated function system is with something known as a chaos game, where essentially you start with a random point and pick one of these functions at random and move through. Okay, so essentially, we pick one function at random, so we'll say we move halfway towards A, which puts us, I don't know, something like this. Then we move halfway towards C, which, again, maybe brings us something like this. Then we move halfway towards B, which I think will bring us like maybe here-ish or something like that. And the point is with every iteration of this function system, you become closer and closer to that Sierpinski triangle. And this is because the triangle itself is called an attractor. It is basically something that is attracting your point to that particular location, right? Now, I have a general question, which is to say, if you're given a function system and a random point in space, how do you know, what is the fastest way to know, what is the fastest way to draw out the attractor? So the two questions I have are, one, how do you know how far away this point is from the Sierpinski triangle? That in and of itself is non-trivial, because this isn't like a line, right? This isn't like drawn out in space or anything like that. It's a collection of points, right? So we can sort all of the points and figure out which one's the closest and all that kind of stuff. But there's probably a faster way to do that, and I don't really know that. So that's one question I have, which is, how to tell how far away you are from the Sierpinski triangle. But the other more like difficult question is how to tell that this function system will draw out a particular attractor, right? So if you were given a different function system, how do you know that that other function system will give you, whatever attractor it gives you, right? And is there a way to tell that without delving into, without iterating through the system and without actually doing a chaos game? That's my question. Now, this, of course, led us to a lot of discussions about fractal compression, which we'll talk about hopefully next week. But the idea here is that we can take basically any image and we can turn it into an attractor, so that, we have basically a set of function systems that spans the image, and we give like some sort of analytical form for that two-dimensional image, so that if we read in somewhat of a compressed version of the image or something like that, we're able to essentially recreate the image by using this iterated function system or chaos game method. So this is kind of, in the realm of what we're talking about today. So I think the first thing I'm going to do is I'm just going to implement the simple function to say, how far away are we from the Sierpinski triangle? So that's going to be the number one thing that we're going to work on today. And then we're going to try to answer this other question of, how to tell, if your point is actually attracted to the Sierpinski triangle, maybe tomorrow and the next day. And that's kind of what we're shooting for. So at this stage, if you guys have any comments, questions, concerns, ideas, anything like that, feel free to let me know, and I will totally address it as soon as I see it in chat. 1 second, I have to get my water. Okay, I got it. And I think we just go ahead and hop right into it. Okay, yep, I think this is good. Okay, yeah, let's go. I'm going to go ahead and have a video playing in the upper left-hand corner of the screen. It's probably easiest to implement the function recursively. That is definitely not true. 100% incorrect. We actually did both implementations before. Okay, well, it depends on what you mean, right? So what you're basically saying is the following, right? Like, you're saying that if you have if you have a point, it can select from one of three functions, right? And then each of those points can then again select from all three of those, right? And then, essentially what you're doing is you're creating this tree, right? So when you say do it recursively, essentially you're saying, okay, well, we're essentially doing a depth first search of this tree, right? The issue with that is that now this whole tree needs to stay somehow in memory to some extent. And so one way in which you could do that is actually keeping, instead of the whole tree in memory, is keep like maybe the path. So you go from here to there, to there, to there. And you could read this as like maybe, you pick function 1 first and then function 2 first. Okay, then I have no idea what you mean. Because honestly, yeah. Anyway, and then function 3 first. And if you keep this trit string in memory, then this is an efficient way in which you can do it. But yeah. There isn't really a right. So the question is, actually, I guess the question is like, if we did implement it in this way, which is of course the only way I could imagine doing it recursively at this stage, then in principle you're saving less data. Right. So then the question becomes, if we just took a snapshot of like this particular part of the Sierpinski triangle, for example, how do you know like what each of these points represent in the tree notation? Depending on which of the 4 triangles the point is in, you can call the function recursively, 3 of them, and then return some value for the center triangle. Okay. I don't know what you mean. I'm so sorry. Because we don't have the triangle, right? So for example, we don't have this image, right? This image doesn't exist. We only have the function system, right? We're trying to figure out what the function system draws. So depending on which of the 4 triangles the point is in, you can call the function recursively for 3 of them, or return some value for the central triangle. So like in general, we don't, right. So to generalize the problem, we have no idea what this, like it could be any, tractor. Like it could look like this, for example, or it could look like, you know, this or something. Like we don't know the shape of the attractor in general. It's just right. The Sierpinski triangle is the most common one. So that's what we were doing. But what I will say is the idea of doing it recursively, though much harder to implement in practice, like doing it this way recursively, though much harder to implement in practice, does give a whole bunch of benefits. And actually, we did make a video exactly on that before. So, you know, feel free to check YouTube if you want. It was another one of those videos that kind of underperformed, and I was like, man, that one was like really good, honestly, but whatever. Anyway, so this idea of having some sort of trit string that you iterate through the tree with is relatively straightforward and easy to implement. It just kind of, it just means representing your tree in a slightly different fashion. Okay, in fact, that's the visual that I'm going to show right now. So cd videos, algorithm archive, iterative function systems, ls here, cd into, mpv, Sierpinski, Hutchinson. Okay, so this is the visualization that you'll get. Let me loop it. Loop 0. So this is the visualization you get if you do it that way, where you just span all possible paths of the tree. You just start with 3 points D, E, and F, and they all create children, and those children create children, and those children create children, and they create children again and again and again. And that's kind of how you would create the Sierpinski triangle in this fashion. We did this quite a long time ago, but I just never really made a video on it. Or, well, I did make a video on it. It's just, I don't know. It's been a while. Actually, I should not have done that. I should have left that down there. Okay. And then I think I want to move that up. Perfect. Okay, so that's where we're at. And I think we can just go ahead and just start making things and start talking about things. So journal, new page before, right. Okay, I don't know what happened, but let's try that again. New page before. Okay, so, right, so the core issue here is that, again, even though we see a set of triangles, right? So we see this, you know, and then this triangle is inside here. I'm sorry that my triangles are very poorly drawn. I just, you know, I'm just drawing something. You guys are just going to have to deal with the fact that, like, none of these are perfect triangles. So even though we see a set of triangles, you know, if we just zoom in on, like, you know, a little section, that's actually not what the Sierpinski triangle is. It's not actually lines at all. You know, what we're seeing here is actually a collection of points. So if we were to zoom in on this, let's draw it in blue here, and let's move this in here. Instead of seeing like, you know, a line that looks like this, we're actually just seeing, you know, maybe a bunch of points that look something like this, you know? So if we were to connect the dots, you know, it'd look right, you know, somehow. I guess maybe it has to go directly out here and then down here or something. But, you know, if we actually look at the representation is just a bunch of points in space. So essentially, it's just we've drawn so many points that it draws a line for us, right? So the question is then the following, right? So if we have a single point in space, right? So let's draw this point here, and we call it point P. How do we know how far away it is from this triangle, right? And that, what is this distance d? That's the question. And that's actually very difficult to do, right? Because, you know, we could, for example, say that we have a collection of points, right? And that's totally, yeah, we have a collection of points. So how far away is point P from any number, from any point on the Sierpinski triangle, right? So instead, what we could do is we could say we have a point here. You know, there's a point. We're trying to find the distance d here. And so we just search through all of the different points on the Sierpinski triangle, right? And we say, okay, well, which one of those is the closest to the Sierpinski triangle to tell how far away we are? Great. Okay, that seems reasonable in practice, except for the fact that in general, these triangle animations have like 10 million points or something like that. So if you're doing this sort a lot, I mean, you're going to have to sort 10 million points every iteration, which isn't particularly good. So what we're actually looking for is a way in which we can, like, grab essentially just this little square region in here. And we can ask ourselves, okay, if we are only looking at this square region within the Sierpinski triangle, how do we know how far off we are, right? And that's my question there. How do I know what points are in this square? That's my question. Can't you first compute the convex hull of the big triangle? I mean, you could, but then the question is, what if your point's here, right? How do you know how far away you are from this interior surface, right? And then you could say, okay, well, maybe we want, yeah. Are there functions always in the form a plus p times constant? Not really, not in general, no. That's just specifically for the Sierpinski triangle, but let's just go to, for example, iterated function systems on YouTube, Wikipedia. I'm pretty sure it'll have other examples in here. Well, okay. What you can say, though, is that pretty much all of them will be affine. So if you assume that they're all affine transformations, then you know that there are, in principle, like 6 different knobs that you can twiddle. So that could be, you know, a hint as to what we can do. So let's see. It's not really giving us another function or another Hutchinson operator, but you know, another one that is very common is the Barnsley-Fern. Fern, there we go. Which looks like this, for example. Again, it's just a bunch of affine transformations, which are close to a plus b over 2, but it's a bit more, it could be a bit more complicated than that, right? It could just be a full matrix multiplication with some sort of linear offset. So again, if you're asking about what an affine transformation is, I just put a video on that as well on my YouTube channel. In fact, if I just do this, you'll find basically all the videos that I've been talking about. Cool. Okay. So, right. The thing is, I didn't realize that our question was, when I entered today's stream, I was completely unaware that this was a question that we would be asking. Somehow, I just didn't realize that this was, I thought we would just like, I thought we'd do the naive thing first, which was, if we have a given point in space, you know, what is the closest point on the triangle? And that's just a simple sort. We could do that. But I think the more interesting question is, here is, how do you know what points are within this square, in the Sierpinski triangle? I think that's a way more interesting question, because it's definitely not trivial, right? If we only have a function system here, right? We're essentially trying to ask ourselves the following question. So journal, new page before. Let me go down here and grab our function system. I guess I'll just grab this, and then we're just going to do Control C, Control V, and we're just going to move that up top. Okay, so given this function system, which I'll put over here, and I think I'm going to color in system as black. That's not quite working, is it? Okay, well, just, I don't know. I can't erase it, can I? It works. Perfect. Okay. Given this function system, and given 3 points, which will be, I guess I'll color them as green. Over here, A. Red. Over here is blue. B. Probably should, whatever, doesn't matter. And C is blue. Probably should have made B blue, but that doesn't matter. And given some sort of point P. This is the information we're given. We're given a point P, A, B, and C, and the function system itself, also called the Hutchinson operator. So the question is, how do we know if point P is on the, yeah, let me just write this out. How do we know, let me type it out so you guys don't have to deal with my crappy handwriting. How do we know how far P is from the tractor? So that's our question. That's what we need to figure out. Essentially asking the question, you know, how do we know? How do we know if we're attracted to the Sierpinski triangle or some other attractor? Like, that's the question we're trying to ask. So the way I just posed it a second ago is I asked myself the question of, well, if we search in the vicinity of P, right? You how can we tell if we've grabbed any point within the Sierpinski triangle? Like, how do we do a local search instead of a global search, right? That's kind of my question. We can globally search over the entire triangle. That's totally fine. But I don't think that's the best way to do that. Instead, what we're going to try to do, I think, is try to figure out, like, for example, if we look in this area right here, we would find the dots in the triangle that correspond to, one second, that correspond to something that looks maybe like this, So the question is, how do we find those points? And I guess also there would be, how does the Sierpinski triangle look again? I think it's just drawing in here, maybe. Something like this, and then of course there's a triangle in there, but you see my point, right? So how do we know? How do we know that these points are in that pink square? That's what I'm trying to figure out. And I have no idea. So we're just gonna try to figure this out and see where we go. Again, if you guys have ideas, please shoot them in chat. I sometimes might sound dismissive, but I don't mean, I'm genuinely reading and trying to understand this with you guys. So if I say something or do something that makes me sound like either condescending or dismissive or anything like that, please just, I'm not intending to do that. That's just how I sound sometimes. And I know it's a problem that I need to deal with, but I do genuinely ask that you guys, if you have suggestions, let me know. Okay. So when thinking about this problem, where does my mind go? The first thing I think about is the number of ways in which we can represent this point, right? So one thing that we could do is we could do a naive search, and we could just say, if we have our triangle here, whatever, here's our triangle, and we have all the points that are related to this person. I would think of applying the inverse of the function to the box. I'm not sure if that's allowed or useful. Okay, so you could apply the inverse. Okay, I think I see what you're saying. Wait. Hear me out. I think I understand what you're saying. You're saying we have a set of functions in here. The set of functions are basically called a Hutchinson operator, which is going to be a... Wait, I think you're onto something. I just can't quite formulate it, right? So if we have some box, some area, here. Essentially, this box is composed of 4 points anyway, so point 1, 2, 3, 4. I'm not saying this is the best way to do it, but, you could imagine that. So we're trying to figure out what points in the Sierpinski triangle are in this box. And so what you're saying is if we somehow apply the inverse of this set of functions, we could potentially figure out which of these, what part of the triangle fits in there. I feel like you're onto something, but I'm not quite smart enough to kind of piece that together. What I was imagining, and again, just hear me out, I'm not sure if this is the best idea or not, is that each of these points... Okay, so how do we get to this region of space, right? The question is, what set of functions will bring us to any of these points in here? I don't really know, right? It would be... Oh gosh. The main thing I don't want to do is I don't want to store the whole triangle in memory, right? I don't want to store all the points in memory because storing all the points in memory kind of sucks. So what I'd like to do is store some representation of all the points in memory. And if it's some representation of all the points in memory, then it could essentially be an image. And if it's an image, then all we have to do is we could just do a flood fill. We could literally just do a flood fill from this guy, or some sort of search, and we just search out the entirety of space, in some sort of pattern. I'm not sure which way, until eventually, boom, we hit the Sierpinski triangle. I think presumably we don't want to do it in that spiral pattern. Presumably we want to do it probably spiral pattern is right, and the assumption is if they're in really, really small circles, then we should hit it at essentially this point here. Does that make sense? So we could just do some sort of naive search in this two-dimensional space and just keep feeling our way out until we eventually hit something. That would work. I think this is a simple scanning method or something that we could do. The question is, how do you find the edge? of something that has no edge, right? That's the question that we're trying to ask. And I think in general this would work. Like we could do some sort of search. So like for example, if instead of looking at this corner, we were looking at maybe the center of the triangle in here or something, and then we were doing that same search outward, we'd probably find. Yeah, we could basically do a breadth first search, like again a flood fill type thing on the image. That's I think one way to do it. So I think one possible method is flood fill on image. But the downside to this is that this requires generation of image, right? So that's not the worst thing in the world, but it just means you have to pre-compute the Sierpinski triangle. Maybe it's dumb, but can't you draw a circle with center P and then test if there's a point of the triangle inside of it? Right, so the question is, how do you test if there's a point of the triangle inside of it, right? Because again, we're not given the triangle, we're given the set of function systems. So if we're just drawing like a random circle in space, like we know that this should in principle have, maybe part of a triangle inside of it. I don't really know what part, so I'm just going to draw like maybe this part of a triangle inside of it, right? Like we know that should be there, but how do I know that this point is there? That's my question. If I haven't drawn the triangle already, right? That'd only give you an upper or lower bound of the distance. Right. So essentially, Tam, what you were saying is exactly kind of what I was proposing as well. It's just that instead of doing like one big circle, we just kind of like take a circle and we just progressively make the circle bigger and bigger and bigger and bigger until eventually we find a point inside of it, which I think is fine. And I think that is kind of what we need to do. And this is why we were saying flood fill, because that idea of just kind of filling the image in this way is essentially a flood fill. But now I'm left with the other question of, how do we represent that point? And so again, if it's represented as an image, you're 100% correct in that this will work. But I'm really hoping there's a way to do this without generating the image first. And for that, I'm not entirely sure how to do it. Right? So maybe for today, we don't deal with that problem. We deal with that problem tomorrow. What did I say we were going to deal with tomorrow? Because I keep pushing more things onto dealing with it tomorrow. And if I push everything onto tomorrow, then we're going to have a lot to do tomorrow. But maybe this is already enough to do today. Like the circle problem is already enough for today. So maybe we do that. And we just try to get a basic thing implemented. So we do a chaos game to get our Sierpinski triangle, and we just search to see, how far away our point is from any given point on the Sierpinski triangle. And we do that. So we already have everything generated. Let's do that now. Okay? And now the next thing we're going to try to do is figure out a way in order to ask the same problem without drawing the triangle first. And that's, in my opinion, a really difficult problem that we're going to have to solve, but I don't really know how to solve it. I suppose we could have some compressed form of the triangle available. Like we could have a, we could have, jeez, I need to think about this. Okay, let me think about it for a bit longer, just kind of rambling a bit on stream before we get into the coding. So what we do know is that this point is some set of functions. Function A, function B, function C, function D, function F, so on and so forth, right? So each one of these points can be represented not necessarily as a point in space, but as a set of functions applied to another point in space, right? I'm trying to solve this question for just a triangle, or do you want to... it needs to be... Well, I'm hoping to have it general for all attractors, right? We're starting with the Sierpinski triangle because it's particularly easy. But the question would be for any attractor. Right. So that's why the question is, how do you know if you're attracted to the Sierpinski triangle specifically? Because you could be attracted to something else, right? And so that's kind of my question. How do I know if any given point in space, or rather any given set of points, is, like on a given attractor, if the attractor is a Sierpinski triangle, or if it's a Barnsley fern, or if it's something else, So yeah, what I'm trying to think of here is that, we do know that each of these points, again, is some set of functions applied to some other point P, which you could call, let's not call it P, let's call it Q, which will be like some sort of like node point that you're starting with or something. So if we know that, does that help us in any way? Like, can we just search through a particular space can we just search through a particular space because we know this information? And I don't think this helps us in any way right now. I think we're still kind of a bit it might be distracting. It might be distracting from the point a little bit. I just remember when we were going through the whole the whole discussion of when we were going through the entire discussion of how to count through the Sierpinski triangle with trit strings, we had this very same question up here, and I remember thinking that there was a solution to it at the time. I just don't remember what that was. So we know that every point on the triangle can be composed of some trit string, right? So every point on the triangle, each one of these points is some combination of functions. A, function B, function C, so on and so forth, ... wait. And then within all these guys, there's like a applied to point Q in here. Sorry that was so messy. So we know that all of these are applied to some point Q. And if we know that, we know what? How does this actually help us in any way? And I don't think it does. This gives us a representation of the Sierpinski triangle that's not drawn, but instead stored in memory. And, our question is, essentially what we're doing here is we have some tree in space, where we have some initial point Q, and then Q can have 3 functions applied to it, and then each of these guys can have 3 functions applied to it, and 3 functions applied to it, and 3 functions applied to it, and it just keeps going on, right? And so the question is, how do we know which of these nodes is in our space, right? Because, for example, it could be that this particular node is not in our space, but one of its children is, right? Like, you could imagine a case where, like, we'll call this Q. Q could be in the box, and then R might not be in the box, but S could also be in the box, right? Like, it could be a situation where, like, as you get significantly far or like further along this tree, you end up moving in and out of that box. So I don't think this trit string approach would help us in any way. It just makes it more computationally, like, I don't know. It makes it a little bit better, in some ways. One second. One second. Oh, I screwed something up. Okay. So, yeah, I think let's just implement the simple approach, which is just a circle approach, a flood fill, whatever you want to call it. I will say I did initially, think that this would be breadth first search for flood fill, but the more I think about it, breadth first search actually does an L1 space traversal, right? Like what will happen with breadth first search is you start with a single point, and then you move out in this way. One second. So, you kind of draw this triangle in space, but we specifically want to draw a circle in space. So, I'm not sure how to do that yet. So, we're going to start step 1. Here's what we're going to do today, just to kind of get some code on paper. The first thing we're going to do is just draw the Sierpinski. Draw a tractor. Right. Perfect. Let's do that. The next thing is we're going to try to create some sort of fill approach. Approach. Oh gosh, just give me a second. To find closest attractor point. Attractor point. Now, I'm gonna be honest, there's probably a more efficient way to do this that I don't know. Like, there's some algorithm I don't know to do this. But let's just do it. And let's just go ahead and just get some code written and go from there. Okay. So I'm going to keep letting that play in the corner. And we're going to cd into projects, Simuleos. Ls here. What am I working on right now? I'm working on, I already have a directory for fractals. What I might want to do is cd into, what do I want to call this? I mean, we have fractal flame. Let's just cd back into fractal. Why not? Ls here. And now we're going to just make a new directory, which is going to be called, oh, I don't know. Actually, screw it. Let's go back a directory and let's just make a new directory called research. cd into research. Ls here. Make directory fractal. Sure. Okay, cd into fractal. Perfect. All right. I realize my directory structure kind of sucks right now, but that's, you know, it is what it is, you know? Okay. So, one second. Okay. Okay. So let's go. We're going to do the same thing over here. cd project, Simuleos, research, fractal. Okay. And now we're going to do ls here. And let's just start writing some code. Vi, what are we going to call this? I'm going to call it Sierpinski search is what, no, let's call it, let's just call it attractor search. .jl, we'll be using Julia for this. For those of you guys who might be new, Julia, should be Julia 1.6. Perfect. And let's just go. We already have iterative function systems on the algorithm archive. So let's just go to the algorithm archive here, go into iterative function systems, open up the Julia version, which it's already open. Perfect. And we should just be able to, oh, come on, 1 second. Scroll down, grab the, my browser is not, I just don't like, the browser is nice, but like, sometimes. Okay. And I think we can just grab this guy directly, move it over here, and just, we're going to generalize it. So what this is going to do is it's going to create a chaos game, and it should just create a whole bunch of different points. And yeah, that's what it should do. So let's just go ahead and write this, go over here, and we're just going to run include whatever it's called, attractor search.jl. And this should give us a number of points. So if I run GNU plot and we do plot, it should be out.dat. There we go. We should get a bunch of points, which represents the Sierpinski triangle. No, again, just to reiterate the fact that we're not dealing with lines here. If we redraw this with lines, it looks really bad. Oh no. Let me use fewer points really quick. So how many points did I say here? I said 10,000 points. Let's drop that down to 1,000 points. Control D, back, and now we're going to include it one more time. Run GNU plot out.dat. Okay, let's do it without lines. And let me do point type 7. Okay, great. So now we see a bunch of dots. Let me just move this, make it bigger, and let's talk about what we're seeing here. Okay, that, right. I forgot that new plot is, give it a second. It's kind of, it's struggling. 1 second. I don't know what it's doing. I'm so sorry. I was not expecting, is it okay? There we go. Okay, so essentially we started with like maybe this point over here. And then, oh, maybe, actually, we must have started with this point. And then we must have moved, I don't know where we went from there. I guess somehow down here. Oh, I see. So we started at this point. We moved halfway towards C, which is down here in the corner. Then we moved halfway towards A. Then we moved halfway towards C again. And then I'm not sure where we went from there. I would guess halfway towards B, which would put us very close to the Sierpinski triangle. And from there, you really can't tell like what point we went on, because at that point we're on the attractor. And so the question is, Is this point on the attractor? No. Is that point on the attractor? No. Is that point on the attractor? No. Is that one on the attractor? No. The next one, though, probably. I mean, like, I don't know where it went. So let's go ahead and try drawing this again with lines, and let's just see what happens. Oh, you know what? Let's draw it first without lines. Point type 7. And then we're going to do this again, and then draw it with lines. And then we're going to do replot. Okay, so there we go. So this is our connectivity graph here. So again, I had it right. We go here, there, there. There's no way to tell at this point. But yeah, this is what I was saying. Like, if we were just going to, in fact, let me go ahead and save this to file. So, or let me just do this a dumb way. And let me just grab a snapshot of this. So we're gonna print screen, and I'm just gonna do it this way. Perfect. Hey Cropweb, how are you? Oh, I could have just exported a PDF. Export image. Wonderful. Learn new things every day. So we're just gonna call this whatever, something .png. It looks like vanishing points. What do you mean it looks like vanishing points? Oh, I kind of see what you're saying. Yeah. Okay, so now I'm gonna drop that over here. There. Projects. Where are we? Projects. Simuleo should be down here somewhere. There we go. Research should be in here. Fractal something.png. Wonderful name. I'm so sorry, guys. Yeah, this'll probably, that'll do. It's fine. So my point was that if we just grabbed like a random square in here, it's really, I mean, like, yeah, we see a bunch of points, obviously, because, like, you know, we know what we're looking for. But you know, sometimes you know, people say I'm a genius. My naming conventions are 10 out of 10. Like, anyway, the point is, like, if we just grab a random square in here, like, it's hard to tell, first of all, that any of the points in that square are on the Sierpinski triangle at all. And second of all, it's hard to tell, like, what functions, like, what line of functions we needed to take to get there. Again, yeah, it's just kind of difficult to do. There is definitely a solution that I don't know, but it's fine. We can talk about that later. Okay, so where was I? So we already have the ability to generate the Sierpinski triangle. What I want to do is, I kind of want to generalize the chaos game to be a more like, because right now it's not super general. Like, it's kind of made specifically for Sierpinski-like shapes. When in principle, it could be any function system. So what I think I want to do is kind of extend it to be, to read in a set of functions, right? So I think I can do that fairly easily in Julia. But just before that, I do that, guys, I'm going to be right back. So give me just a minute, and then we'll hop onto that. So the next thing we're going to do is kind of extend this to be an arbitrary function system. And then we're going to start asking the question of, you know, how do we know how close we are to the Sierpinski triangle at any given point? So again, guys, I'll be right back. Sorry about that. Yeah, so 1 second. Okay, I'm back. Give me just a second. And yeah, okay. I'm not well versed in attractors. Can something be on the triangle, or is it just gets continuously closer? It basically just gets genuinely closer, or like continuously closer. It never is like officially on the triangle. Well, okay, if you start with a point that's definitely on the triangle, it will always be on the triangle. But unless your point was just magically there to begin with, or somehow close enough, like in like at a point such that when you apply one of the functions, it suddenly becomes on the triangle, you're just going to get closer and closer, So there's always going to be some precision error, which is why the question isn't really like, are we on the attractor? The question is, how do we know if we're attracted to this one and not another one? Okay. So I think the easiest way to do this is just to go ahead and think about how we're going to... So an affine transformation is just going to be literally a 3x3 matrix multiplication. So maybe we just... I think we can just do it, right? How do we define every point? So the point is going to be defined as zeros of n to 2, and it's just a random initial point. So in principle, we should be able to create a function in here. I guess we want struct... No. One second. I have it. What we're going to want to do is we're going to want to have a... wait 1 second. My stream is kind of... Okay, just making sure. It looked like my stream went offline on my side screen. So what we want here is just a set of functions. So I'm just going to say... In fact, not even a set of functions. We want a set of arrays. So here we want... create a list of... a set of arrays of affine transforms for function system. All right, I'm gonna ask myself, I'm gonna make a stupid question. Journal, new page before. If we have function 1 is going to be equal to p plus a over 2, how does that correspond to an affine transformation? Good question. I need to do some quick math here. So if you guys don't remember, the way an affine transformation works is essentially we take the point's xy location in 1 in the z-axis, and then we basically multiply it by a function where we have a11, a12, a13, a21, a22, a23, a31, a32, a33. I think I did that right. I always get my column and row majorness mixed up, but I think that's fine. And essentially we just multiply by this, and that's the affine transformation. So how is p plus a over 2, basically, how is that, how do we turn that into an affine transformation? And I think we just have to do the matrix multiplication here. And this is where you're going to see that I completely and totally forgot how to do matrix multiplication. So it'll be x. It'll be x times a11, y times a22, and then 1 times a13. And so it should be, if we want this to be the point location plus a, and a is also a two-dimensional location, then it looks like we just want to fill in... Why do we need 1 if we're only working in 2D? So essentially, so I made a video on this. If you just check the YouTube channel, it's one of my most recent videos. Sorry, I don't have a link to this one exactly. But that's actually a good question. Should the matrix be on the other side? Maybe. I don't remember. You're right. It should be on the other side. I really suck at this. I get this confused every time. But you're right. It should be on the other side. And so let me move this over here, move that over there. Every time I get mixed up. So it's A11, A21, A13, and then it should be A21, A22, A23. And essentially what we want here is I want to figure out where do we put... So obviously what we're going to want to do is multiply this whole thing by 0.5, right? Totally fine. That gives us the over 2. So the question is, where do I put the AX location and AY location? And so what I'm wanting to do is I'm wanting to add them together. This has to be doable, right? I'm not dumb. Well, I mean, I am dumb, but so is this doable? It must be. I'm not. P plus A over 2. So How do you... Chalkboard, thank you so much for following. Really appreciate it. Maybe I'm wrong. I always thought... Okay. Good. I did this the other day, I thought, and maybe I was wrong the other day. The problem is this is obviously a matrix multiply, right? So can you turn a matrix multiply into an addition in this way? Maybe. Oh, wait. That's what these are for. Oh, I think I'm stupid. I think I'm so stupid. I think it's just... I think we just use A13 and A23 because that gives us a linear... What is this? It's going to be... Okay, let's put it in another form then. We are literally adding A and then dividing by 2, right? That's all we're doing. So... how do you do that in one fell swoop? So I know that these guys give a linear offset, right? So we want a linear offset and a scale. And I know that these guys do the scale. So is it 0.5, 0.5, 0, 0, AX, AY? 0, 0, 1? Is that the matrix? Or am I stupid? No, what this is going to do is that this will make it so it is... okay. So, no, I got it. This is going to be over 2 over 2. So what this will do is it's going to be px times 0.5 plus py times 0.5 plus ax. Yep. Px plus 0.5 plus ax over 2. And then py times 0.5 plus ay over 2. That's what it would be. Perfect. And then 1, because affine. Okay, I'm not stupid. I'm so sorry. Like, every time I do one of these things, I just feel so stupid. But wonderful. Okay, so that means it is possible. I'm not... I wasn't thinking, like... I wasn't completely off my rocker when I said that. The main point there is that any function system should just be a set of affine transformations. So I'm fairly certain that, I'm fairly certain that this, it should be fine. So what am I going to do next? I'm going to create a function in here. Function create Sierpinski set. All right. And here we're going to read in 3 points, which will be A, B, and C. I guess I just set these as vectors. So I guess I'm just going to read in the point A, B, and C, and I'm not going to specify their type. I do generally like specifying types, but in principle this could be a tuple or a vector or a number of different things. So yeah, let's just leave it unspecified for now. Okay, so in the end, all we're going to want to return is return, and I think I can just do the following. So I think if I do... I need to think about this. It needs to be a 3x3 matrix, so it should be what I just wrote down. So 0.5, 0, A of 1 times 0.5, semicolon, and then 0, 0.5, A of 2, times 0.5, and then the last one should be 0, 0, 1, and that should be right, I believe. So now onto the next line, which is going to be the same thing but for B, because it's the next thing. So it should be this one, and then change these to B and C. Give me a second. All right. So this will be B, and this should hopefully create what we want. Change this to B, change this to C. No. Screwed it. Okay, so for those of you guys who are in Vim or VI and you want to like learn how to capitalize something, the way to do that is just press the tilde button. It is tilde, isn't it? There it is. Yeah, tilde. So if you press tilde, it just automatically capitalizes it, or like lowercases it. So I can capitalize this entire line just by holding tilde, if I want. So if you want to sound really angry and you're on Vim, just hold down the tilde key and it will it'll like automatically capitalize like every character. Okay, so this would be B, and now we want to do C as well. There, and there as well. Okay, so now this should be the set of functions that we want to apply. So now what I'm going to do is, yeah, I don't actually know how to differentiate this chaos game from the chaos game function that we're going to create. So maybe what I actually need to do is just modify this chaos game. So the first thing I'm going to do is test to make sure that the create Sierpinski set actually works. Control C, back here. Okay, 1 second. Okay, Control D. There we go, perfect. Include. Let's make sure create Sierpinski set works. And so we're going to give it a set of points. So we're going to say create Sierpinski set. And we're just going to read in, why not? These points over here should work just fine. There. Well, if I can type correctly. Perfect. Next one should be this one. And then the last one should be this one. Okay. That did not work because I'm stupid. There. That didn't work because I'm still stupid. I think it's because I need to remove this. That worked. Okay. Did it create the right set? So we're going to say the function set. I guess we're going to call it Hutchinson because that's what the function set's called. And let me just do Hutchinson of 1. And this should be, yep. So this is not the matrix we wanted. Oh, no, that is the matrix we wanted because A is 0, 0. Okay, but if we do Hutchinson 2, that should be the matrix we wanted. Perfect. Okay, so let's keep going from there. We do have our set of functions. So here I'm going to modify this so it is now going to read in the Hutchinson operator, and we're just going to call it Hutchinson. And then essentially all I'm going to do is say point is going to be equal to, it's going to be point is equal to 1, 1. Okay, 1 second. And then point is going to be equal to, and it should just be, how did we select? Random of shape points. So if I do random of Hutchinson, it should give me back one of them at random. Perfect. So we're going to go in here and modify this to Hutchinson. Okay. And it should just be random of Hutchinson, I believe, times our point. Just to make sure I'm doing this correctly, let me just do it in the REPL. So in here we should give a point. So A is going to be equal to, it doesn't matter what it is. So let's just do rand 1. Okay, let me put commas in there to make sure it's of the right size. Okay, so now we should do Hutchinson of 1 times A. Wonderful. And if we do 2, should also work. Yeah, all of them work just fine. Okay, so rand of Hutchinson times, what do we want here? The point that we just created, point. And then we've reset the point. Everything should be fine. And we have set output points is going to be dot equal to point. So I think I specifically want to grab 1 to 2. And I think this should work. If we try including this, we should also... No method matching multiply for vector float 64. Okay. I think we're on the right track. We just... Give me a second. 35. Output points. So the next one is going to be line... Oh. Oh, no. It just goes right into the Julia... 19. Okay. How did they make error messages worse? Error messages in Julia were already, like, impossible to read. And now I haven't been using Julia 1.6, like, nearly at all. But really? You're going to gray it out? Like, my eyes already are not reading this because it's red. Like, I'm just not going to read that. I'm not reading this because of the colors here. And now you're also putting it in, like, a grayscale to make it even harder for me to read? Like, okay, that's fine, I guess. Whatever. So it doesn't like rand of Hutchinson, and I think the reason is because when we're doing this, we're reading in output points when we should be reading in chaos game or Hutchinson in here. Okay, and we've defined output points, which is totally fine. Output points is equal to chaos game. Oh no, I screwed this up. No, I'm stupid. This still needs to be output points. Perfect. And what we need to do is actually read in Hutchinson here. Oh, And then we need to define the Hutchinson operator, which would be Hutchinson is going to be equal to create Sierpinski set. Now, here's where I might have done things maybe a little dumb. I already have shape points. No, let's just do this is fine. I'm just thinking about it too much. Let's just do that. This guy. And then this guy in here. Perfect. Okay. Don't overthink it. Just do it, you know? Okay, so let's move back over here really quick. Delete these 3 lines. And I think that should work. It did not. All right, what's the issue now? 0, 0. Oh, I forgot a comma. 1 second. There, right that. Try it again. Okay, we were able to include it. So let me go ahead and remove out.dat and include it one more time. And now if I run into GNU plot and we try plotting out.dat, I guess that's right? I mean, it looks right. I'm gonna guess it's correct. So what I'm gonna do now is I'm gonna create a new set for the Barnsley fern, just so we have the function available and just to make sure everything's working. So function create Barnsley set, and it's does it need an A, B, and C? I don't think it needs an A, B, and C. Let's see what it actually needs. So let's go over here to the Barnsley fern. What does it actually need? So it needs A, B, C, D, E, and F. Does it? What does it actually need? I think we can just specify these numbers directly, and I think it'll work. So let me go ahead and yank this guy, and open up a new internet browser over here. And I'm just going to have it available on the side for me so that I can do both at the same time. Okay, so now I'm going to open, paste it in here. And again, guys, if you have any questions, comments, concerns, ideas, anything like that, feel free to let me know, and I'll totally address it as soon as I see it in chat. So I'm just going to copy down this function system as a set of affine transformations. And yeah, so return. It just needs to be a 3x3 matrix, so it should be able to do the same thing we just did before. Which will be 0, 0. Oh, is that it? 0, 0, 0. Let me do 0, 0.0, 0, 0.0, 0, 0.0. 1 second, guys. Get that there. The next one is going to be 0, 0.0, 0, 0.16, 0, 0.0. And the last one should be 0, 0.0, 0, 0.0. And 1.0. Okay. And there should be 4 sets of functions here. So let's move on to the next set, which is going to be slightly more interesting. 0.85, 0.04, and then 0.00. The next line is going to be negative 0.4, 0.4, 0.85, and then 1.60. And then the last line is again going to be 0, 0, 1. And actually, let's just kind of yank and paste this line twice over. Move this over here. Change that there. And let's just modify the lines here. Because this is also going to be 0.6. There's like some copied stuff is what I'm trying to say. So it's going to change to 0. The next one's going to change to negative 2.6. Negative 0.26. The next one is going to be still 0. So then it's going to be 2.3. 2.2. And then 1.6 again, and then 0.0.1. And then finally it's going to be negative 0.5. Let's see, 0.28. 0.0.0 again, 2.6. Let's see, 2.4. And then 0.44. Okay, in principle, this should create our Barnsley set. So I'm going to go ahead and yank paste this line, comment it out, and then modify this to be create Barnsley set. He's about Barnsley. Okay, that'll work. Go ahead and D there. One more time. Okay, and this should create the appropriate Hutchinson operator. So I should be able to, I'm gonna move this over to that desktop just in case. Let me do Control D, Control D. Oh, shouldn't have done that. Reset. Julia. Include. New plot. Perfect. Plot out point type 7. It's crappy fern. Let's do it again. Increase the number of points here to be 100 times as many. Control D. Back. Include. GNU plot. Plot. Slightly better fern. Still not perfect, but you can clearly tell what we're going for here. I'm going to try it one more time. Well, maybe it's fine. Actually, in fact, I think maybe this is fine. So we're going to, the next thing we're going to do is actually turn this fern into an image, and I'll put the image instead, of plotting it in new plot. This, oh no, stop it. Stop it. That's fine. This is fine, right? The point was, I just wanted to draw another attractor that wasn't the Sierpinski triangle to make sure it was appropriately generalized. So new plot does this thing when you have too many points where it's just really slow, right? So what I'm going to do next is I'm just going to create a simple function that's going to take anything that we have in this form, which is a set of points, and turn it into an image. So it essentially outputs an image instead of outputting a set of points. That's what I'm going to do next. And this also helps us with the search and everything like that. So let's keep going. And in fact, before I go any further, I'm going to make it so we only use 1,000 points for now, just because we don't want to make it too crazy. Let me just add a tractor search.jl get commit-m, adding simple function to create arbitrary tractor via chaos game. Perfect. Okay. Git push origin master. Okay, 1 second. All those people saying I couldn't type. Well, look at me now. Still can't type. Okay, so what are we going to do next? So we have something that's kind of working in a way that it's doing something. So the next function I want to do is a simple function, function to output a set of points as an image. I don't know what to call it. At least for the stuff that I used to do, this was called the act of binning, the act of putting all the dots into a bin. So I kind of naively want to call it binning, but I know that's actually not right. Let me see what we did for the flamify package. So over here, the Barnsley ferns seem to be correct. No, you kidding me? Okay, 1 second. Huge, I accidentally deleted a terminal that I needed. That's okay. Move this back over here. Okay, so we're gonna cd into projects, something. Flamify, ls here, cd into source, ls. I didn't cd into anything. Source, ls here. And I should have image tools, and let me see what we did here. So create Gaussian kernel, normalize, surely there was like a right image or something in here, right? Right image, perfect. I'm nothing if not, like, my naming convention is, obnoxious but consistent, you know? Like, and I think that's fine. I did steal that phrase from Jazza. If anybody like watches a lot of YouTube, there's this one YouTuber, his name is Jazza. He used to go by Jazza Studios or something. I don't know. He's just an artist. And I don't know why. I just really like his stuff. And he's got millions of subscribers or something like that. It's not like he's unpopular or anything. It's just, he's a weird guy. Like, and his catchphrase for the longest time was obnoxious but consistent, and it's genuinely my favorite catchphrase. Like, of any YouTuber catchphrase I've ever heard of, like, obnoxious but consistent is just like, it's so good. He published a video the other day that is by far, like, it was just amazing. YouTube.com. Let me just go to Jazza. Jazza. Let me go here. There was a video that he published that was just amazing. It was so good. Where is it? I don't know. I'm sorry that I'm just like randomly talking about this guy. Let me see if I can find it. Chair. Ah, here it is. I customized YouTubers as chairs. Brilliant. Just absolutely brilliant. I'm gonna paste it here. It was so stupid. Like, it was the dumbest video I've ever seen, and yet at the same time, I just loved it so much. It was that exact type of cringe humor. Like, I don't know, I just loved it so much. Like, before I started streaming on Twitch, I wasn't really super into like the whole cringe humor type of thing. But then somehow, like, I started watching Zeldathon one year, and I just found it amazing. It was just something about the way that people acted when they, like, you know, I don't know, it was just really funny. Like, something about, like, being poor in front of a camera and just, like, failing miserably, but, like, still trying to make people laugh, even though you know it's not actually funny. Like, somehow, like, the meta commentary on it makes it funny. I don't know, like, I find it really just every time. Okay, so let's go ahead and create our function to create an image. That's what we're gonna do. What was this doing? Twitch altered your brain, poor Leos. I'm gonna, look, if you knew what my brain was like before Twitch, I don't know if it was better or worse, honestly. Okay, this right image function is doing more than it needs to do. So let's just create our own right image function, and let's just not worry about it. So journal, new page before, I'm gonna draw a giant square. Okay, this square is what we're gonna call an image. Wow, I'm sorry, I'm stupid. Just forgive me. Okay, so obviously this is going to be composed of a bunch of pixels. I'm just drawing the really big pixels right now just because I feel like they should be really big pixels. I don't know. So obviously we need to read in an image resolution, but my main question is the following. So let's say we have a bunch of points, and I'm just going to, let's draw the points in blue. Here we have all the points in here. It doesn't matter. I'm just going to draw them at random. So what I need to know is that, like, you know, how do I know what point? So for example, this square has 2 points, this square has 1 point, this square again has 2 points and 1 point. So how do I know how many points have landed in a particular square? That's my question. Should be relatively easy. I've done this like multiple times on stream. Like, I've solved this exact same problem at least 20 times, and every single time I always just redo it because, you know, I don't have any good code. Surely it's here, right? Point offset. When was the last time I did this? This must have been for Quiltify, not too long ago. Okay. So, yeah, how do we know which point falls into which bin? I'm going to say that we can probably do some sort of modulus operation, right? We have to be able to, right? So, what do we have? We know the length here, and whatever. I really suck at drawing squirrely brackets. That looks like an eagle. 1 second. Okay. Perfect. Okay. So we know the number of pixels. Y, X. Okay, so we know the number of pixels in Y and X. We also know the range of X and Y. So, like, for example, this could go from -1 to 1, -1 to 1. This graph is just the dumbest thing I've ever drawn in my life, but just ignore it for now. Well, I mean, don't like completely ignore it, but just pretend I'm drawing something that actually looks good. Okay. So that means if we know the length in X, then we know that each of these bins, it's going to go, like, for example, there's 5 here. So we know it's going to go from like -1 to -0.6, -0.2, positive 0.2, positive 0.6, something like that is right? So we know that this bin, each bin size is going to be like 0.4 in size. So my question is, how do I know that this point, let's give it a random point, which is going to be 0.1, 0.7, which bin is that going to fall in? Okay, so we know it's going to be in this bin here, right? Maybe it's actually this bin here. Okay, so we know it's in that bin there. But how do I remember? How do I do this again? So, I could just search through every bin and I could just ask, hey, is this point in that bin? But I know that's a slow way to do it. I know there's a faster way to do it with some sort of modulus operation or something like that. Let me check Quiltify really quick. I feel like I solved this with Quiltify in a more elegant way. CD projects, Quiltify, ls here, CD source, and then there should be ls pixelate, Quixelate, and then there should be pixel, yeah, pixelate, great. Okay, so what is this doing? It is saying, well, okay, we're basically converting from floating point to, why am I so stupid? Okay, we have offset X, offset Y. This particular code was doing something different. This particular code was taking an image and basically making the pixels bigger. Like it was... Okay, here's what this one was doing. Ls here, mirage dot... I don't know, like... cat2 dot png. It was taking an image of a cat and it was basically turning it into a bunch of pixels. Like that's what this one was doing. Oh, I forgot I made that. Oh, that's an ugly cat if I've ever seen one. Oh, I tried really hard on this one, didn't I? But yeah, so we took an image that looked like this, for example. See, Amaris, have a wonderful evening. And then we turned it into like this, you know. So what this was doing is it was going through all the different pixels. It was asking, you know, if your pixel is at this location, how do you know, like, which bin that goes into, right? I really like this image, actually. That's pretty good. Like, it's better than I thought it was. Anyway, oh, this is a picture of me. I was trying something different with my my image thumbnails recently, and I was just, I don't know. We'll see. Anyway, back in the good old days. Okay, doesn't matter. So I think maybe this particular problem is like, maybe it's not good to look at this. Pixelate here. But let's just see. So it's going through each. It's going through each. Why don't we just do this in the dumb way? Like, is anyone gonna be mad if we do this in the dumb way? What was it? Okay, let me see what we did for right image over here. So we've been the pixels. We say Y value is gonna be the floor. The floor of ranges 1. So what are ranges? Ranges are gonna be reverse ranges. Oh my gosh. So again, I've done this before and I just want to, I'm gonna use what I have. So here's what I did before. For I in point offset to the length of points. So basically we're going through all of the points in the image. The question then is, points are in X and Y, while visualization is in YX. Oh, okay, so that's why we had to do the reverse. Negative Y value needs to be flipped because drawing should be from lower left. Oh, thanks for letting me know that. It was actually a useful comment. Okay, so the Y value here is going to be the floor of integer, and then it's going to be ranges of 1 times 0.5 minus points of I dot Y. So it's the Y location here, and then it's going to be divided by ranges over resolution of 1. I think that's still accurate. So let me just grab this. And let's create a new function over here. Create image. Probably right image is what I called it. Right image. I'll fill that in a second. And here, over here, we're gonna paste that in there. Okay, so this is our function to bin the pixels. I'm sorry, guys. I'm just copying a lot of code in this stream that a lot of you guys have never seen before, and I apologize for that. It just happens sometimes. So we have this thing called the point offset, which, did we read that in? What was actually read in here? So we said point offset. This is perfect. Let's just do that. Screw it. We're just gonna grab this exact function call and move it over here, and people are gonna complain. Like, I can already hear you guys complaining in chat about how I just copy code and I don't actually know what I'm doing. And you're right. So let's go here. My code is meant to be reused. Don't apologize. code is meant to be reused. Oh man, I don't think you. Hello, my name is James Schloss. My personality is apologetic. It's just in general who I am, and it's not going to change anytime soon. So let's go here. Okay, so we have the file name, the ranges, the resolution here. So we say for I is equal to point offset to length of points. Again, the point offset here is simply because when you start with a random point in space, that point will probably not be on your attractor, so it'll take a few points to get arbitrarily close, and then after that, you can then start using the points that you've generated. So that's why we gave it a point offset of 10, just saying ignore the first 10 points. Then we say the Y value is going to be the floor of the ranges of 1. Why did I... What? Let me do something really quick here because it's kind of bothering me. I'm going to move this ranges times 0.5 to the top, to the front here, and I'm going to move this there. So it kind of looks the same. Now, what was I doing here? Oh, no. Okay. 1 second. Points of I dot X. Okay, now here's the thing. Our vector here is actually going to be, instead of a vector, what actually is it returning? It is returning, something. I don't know what that is. It is returning the output points. The output points are going to be zeros of 2n. So this is actually a 2-dimensional array. So I'm just going to call this as points for now, and we'll worry about typing in just a second. And in fact, I'm just going to put this all in one line. Well, we'll leave it on 2 lines. I'll make it all in 1 line. Yeah, okay, screw it. Okay, so we're going to say for point offset length of points. This should be length, size of points of points 1, which will make it so we grab the appropriate length column. The Y value here should be points of I think it's 2, and then this should be I, comma 1. And actually, I'm going to DD here and paste up here. So that's xval first. Why was I defining Y first? Okay. Ranges 2 of a resolution of 2. Ranges 1, resolution of 1. 2 and 2. I think for some reason the other code, I was like really mixing around the X and Y coordinates. Okay, so it's saying if the Y value is less than resolution of 1, this should be resolution of 2. Wait a minute, 1920, that's the X resolution. So resolution of 2, and then the 1080 here. X value is less than, no, if Y value is less than resolution of 2, correct. X value is less than resolution of 1. And X value is greater than 0, perfect. Okay, so then we're going to say the mix, okay, so this is where I created the color of each pixel. But what I actually want to do here is I just want to create a 2D array, and then I'm going to turn that into an image. Right. So maybe instead of saying write image, I should call this like create array or something. Create image array. Sure. And then in here, this should be, if Y val is less than resolution over 2 and X val is less than resolution over 1, this is literally just making sure that we're on the map somehow. Then in principle, we have an X val and a Y val, so we should just be able to do the following. We should just be able to say array, output array of X val, Y val, plus equals 1. Okay, give me a second. And then in here, we're gonna, let's make it sure it's floating point as well. Point O. And then I think we can just do the following. So we're gonna say output array is gonna be equal to, what am I doing with my life? Output array is gonna be equal to resolution. Zeros of resolution, I believe, should work okay, assuming we did that correctly. And then the ranges should all be fine. Yep, this all looks okay, I guess, in some ways. And then I think the last thing I want to do is return normalize of the output array. I think I can just do normalize of output array. Okay, in principle, this should do something. Do I know what it's going to do? Not really, but it's going to do something. So let's go over here. Let's do Control D, backspace, and now we're going to include it again. And I'm going to create image. Well, okay, first let's go to new plot really quick. And now let's plot it one more time. So the range here is from -2 to +2, and the scale is up to 8, from 0 to 8. So how am I actually... Okay, let's just see what happens. So we're going to Control D here, backspace, and now we're going to do create image array. This is going to read in the points, which should just be the output points, which I don't think I returned, but maybe if I just type output points, perfect. Okay, so we're going to create image array, and this is going to read in output points. Then it's going to have to read in the ranges, the resolution, and the file name, which we're actually not using, so we can remove file name. Okay, wonderful. Over here, let's try this one more time. It's include... okay. So we want create image array of the output points. Now let's see, what data structure do we need here? So it's going to be output points, and then it's going to be ranges and the resolution. I'm fairly certain the resolution is just going to be 1920 by 1080. In principle, yeah, this might scale a little bit. I don't really care that much. We're just going to try something for now. And then the next thing I want to do is modify this. So the ranges should be ranges of 1 times 0.5, and then points, ranges of 2. Okay, so how did I use this before? What type does range need to be is the question, because I think I need a start and end range, right? So let's go over here and let me see how I used this before. Right image, right image there, of course. grep-r, right image, RL. Oh, it told me where it was. Yeah, fractal flame, right image. What do we have here? Ranges. Okay, up here, ranges 1, 2. Okay, where do I define ranges? Chaos game of ranges. Okay, maybe if I go back a directory here, ls, cd source ls, vi fflamify.jl. grep-rl ranges. Oh. So apparently I didn't really remind myself of how to actually run this code. Did I put in the README? This is some really old code, by the way. It was never really published. Nope. I did not give myself any proper documentation, which is totally fine. It happens. So let's keep going. Do I have an example run? I don't think I do, because I think I just did it all in the Julia REPL. That is one thing Okay. So, vi fractalflame.jl. It has n is an integer. Ranges. Did I just do... Okay, well, let's see. Actually, I have to read a PDF for tomorrow, so I'll leave you now. See ya. Have a wonderful afternoon or evening, whatever time it happens to be your time. And yeah, I'll see you around. Have fun reading your paper. Sorry. Okay, so what are we going to do? It says... resolution, create image array, chaos game. Right, so it's ranges of 1 times 0.5 plus points of I1. So it's going to be the X location of points. So how does that make sense, actually? Divided by ranges of 1 of a resolution of 1. So let's just think about what we're doing here. So it's going to be the floor. So we have ranges of 1 times 0.5. I see. So I centered it all around the origin. And so ranges must be like 4, 4 or something. So let's just see what happens if I do 10, 10. And in principle, that should run? No, it doesn't, because normalize is not defined. How is normalize not defined? Using linear algebra? Okay, there's a bunch of zeros, which is probably what we expected. So let me go here using linear algebra. Okay, over here, let's go ahead and do using plots. Give it a second. It always takes just a second to load plots. Should be faster with Julia 1.6, but you know, still might be a little bit slow. Okay. And let's just do heat map of, what am I looking for here? What did I call it? Did I give it a name? I did not, because I'm stupid. 1 second. Create image array is equal to that. And now we're just going to heat map image array. Give it a second. Again, the first plot always takes a little bit of time, but hopefully this is an okay image, you know? Let's increase the number of points. So I'm going to do Control G. I'm going to increase the number of points here to be quite a lot more. Okay, let's go here and let's just run include one more time. And now we're going to run image array is going to be equal to that. Now we're going to heat map that. See, I still can't tell if it's good or not. Like, if you look at it, you can kind of see the outline. Okay, let's try this again. Oh, it's 1920 by 1080. Let's decrease the number of pixels here to be maybe 100. Heat map that. Okay, there you go. Look at our wonderful tree. Oh, jeez. That's not great, is it? Let's do it with the triangle. All right, we're gonna do it with the triangle Hutchinson operator. Go over here. We're gonna include again. Now we're gonna run image array heat map. Okay. Let's change the image array to be a little bit maybe 2.2. Heat map. Ha. We have something. You know, I don't understand it. Like, I don't... Oh, hello. 1 second. Wait. 1 second. Here's our triangle. Now, do I fully understand why it's tilted? Ah, yes, actually. I think I do. Okay, I understand. So this is why I flipped the X and Y component, I think, of the code that we were looking at initially, because apparently, yeah, apparently it does this. That's just, Julia will naturally flip your X and Y axes if you don't tell it not to. So let's go ahead and flip the triangle back to where it's supposed to be. And let's see if we can draw like a really pretty leaf. That's what I'm going to try to do. We're going to make the Sierpinski for the Barnsley fern, and we're going to make it look really pretty. That's my goal. Julia is not tilted, but the y-axis comes first. That's actually true for a lot of drawing programs, like Cairo, for example, is the same way. The y-axis is 1, and then the x-axis is 2. So I'm going to modify our output image so it's consistent with that notation. So all I'm going to do for that is I'm going to change this to be y value and that to be x value. And then down here, we're just going to say x and y. Yep. We don't have to, we don't have to write good code. We just have to write, code that's good enough. No, you should write good code. But this is fine. I think this will make our triangle at least tilted the appropriate way. Then I want to modify how we actually input the ranges. So if you look here, how we have image array defined, it's just 2, but what I actually want to do is I want to read in I want to read this in differently is what I want to do. Like, I'd like to read it in like so. It goes from like -2 to +2, and then it goes from, well, -2, +2, and then it goes like maybe -2, +2 or something like this. And what this will allow me to do is create an image that's like, scaled a bit. Like, it's not just centered about the origin. Okay, so how am I going to do that in code? So first of all, just running this should work. So we're going to do ranges of 1. Let me just mess around with Julia a bit. And let's see what we have here. So points of I1. What exactly are we doing here? So we are saying that our ranges of 1. So I'm gonna do the following. I think what I want. Actually, I really do need to think about how we're going to do this. So the y value here is going to be the floor. We're going to take ranges of 1 times 0.5. So before, ranges of 1 was like a value 2 or something like that. And so that would mean it's 1 plus points of I 1. And essentially what we were doing here was we were saying that why do we have to do ranges of 1 times 1.5? I think what that's doing is it's centering it around the origin or something. So points of I1 will be like, let's just mess around with this a bit. So points of I, comma 1 is going to be some random like 0.5, 0.5. I suppose this can be negative, right? What are our points defined as down here? G. I suppose in principle it could be negative or positive, so that's fine. So let's go ahead and remove the ranges for now, and just see what it's going to draw. And then we're going to make sure it actually fits the appropriate range. So what is this doing? Wait a minute. How the y value is going to be the ranges of 1 times 0.5. I don't understand why I'm doing that, actually. Plus points of I1 divided by ranges of 1 and resolution of 1. So, if the range is if the range is 4, that means it's going to go from -2 to +2. So what I'm looking for here is going to be ranges. I guess I'm just going to move this down to the next line, and I'm going to do the following. I'm going to say ranges of 1, comma 1, minus ranges of 1, comma, actually I want to do it this way. 1, comma 2. And I believe that's correct. Okay, so divide by the resolution in the first direction. Yep, that's fine. And then we're going to do the same thing down here. The only thing I'm confused about is why ranges of 2, 2. Why I did ranges of 0.5, ranges like times 0.5. I don't remember why I did that. 1 second. This here should be okay. Okay, so now my question is, why did I have ranges of 2 times 0.5? What's that going to do? So ranges of 2 times 0.5, well, ranges of 2 was going to be like 10, right? So that's 5. I'm giving like 5 points off. I don't know why I did that. Let me just remove it, and we'll figure out why it's there after I remove it. I'm pretty sure. So here we're going to do negative. Okay, so we're going to include it again. We're going to create a new image array. That is because -2, it goes from -2 to 2. So, okay, I need to flip these. I had it right to begin with. So this should be 1 here and there, and then over here it should be 2 and 2 in there as well. Write this, go over here, include it one more time, create a new image. Yes, no. Okay, well, let's define our ranges here. So our ranges are going to be equal to this guy in here. Okay. So ranges of 1, 1, yep, 1, 2. Okay, so this should be -2, that should be fine then. It should be, it was right, okay, so it should be, yeah, this should be correct. Because it should be ranges of 1, 2, so 2 minus -2. Yeah, that's fine. Okay, so maybe we did need the 0.5 times the ranges in there. I just don't remember why we needed that. Oh, wait. I think I understand now. Yeah. If all of our points are within these ranges, and that's centering it around the origin. Okay, so let's go ahead and do, I'm going to create something in here called range. I just hate this so much. Difference. Whatever is going to be equal to the following, and just deal with it. I'm sorry. Is equal to this. Comma this. Okay. There. And in here we're going to say 0.5 times range diff of 1 plus. And then down here it's going to be 0.5 times range diffs of 2 minus that. And then in here it's going to be range diffs of 1. And 1 second. Yep, that should be okay. And then down here it's going to be range diffs of 2. And I think this will work this time. If not, I just broke it, and that's totally okay. You know, breaking code is normal. Okay, over here, write that. Go over here, include missing separator and array expression. Where? On line 8. It does say here, but I don't see how. I see how. This needs to be that. Okay, so now we should be able to do image. 1 second. We should be able to do image array. Range diffs not defined. I misspelled diff somewhere. There. Okay, write this. Go over here. Try that one more time. Oh, include one more time. There we go. Image array. Okay, that seemed to work. Now we're going to run the last heat map of image array. Okay, well, our triangle is like, you know, Try that again. Image array, heat map. There we go. Okay, that's the appropriate triangle. So now I want to make it so our ranges are appropriate. So I personally put in the ranges, so I know that the ranges should go from 0 to 1, and then again from 0 to 1. Okay, let's try that. Okay, never mind. I apparently had it wrong because we offset it a bit. Do I want to offset it? I actually don't know if I want to offset it. Let me go here. Let me... how many iterations do you do for plotting? Right now we didn't do too many. I think we only did 100,000, but we'll do more in just a second. It's just this particular one we didn't do too many with. Okay, so what I'm actually gonna do here is I'm gonna yank and paste this guy and comment that out, and then yank and paste this guy and comment this out. And I'm gonna see what happens if I remove this here, and I remove this here. And I'm just gonna check to see what happens. So we're gonna do include image, image array, and now we're gonna do heat map. There we go. Yeah, this is actually what I wanted. So I think not doing the include actually makes sense here, or not doing the shift is okay here. What I was doing there was I was kind of shifting it towards the origin. But I think it's actually fine not to shift it towards the origin in this case, just because I don't want to shift it towards the origin in this case, so who cares? Okay, so next up we're going to do the Barnsley Fern, and this time we're going to need way more points. So I'm actually going to create like kind of a main function and wrap everything together, because I feel like doing that, and you're just, yeah, who cares? Just, you know. Okay, so here we're going to say function, main, and in here, 1, 2, 3, 4. Okay, so I should no longer have to output out.dat, so I can comment that out. That'll save some time. We're going to create the Barnsley set, comment that out, and we're going to increase the number of output points to be 100,000. It was 100,000 before, so 1 million, 10 million. That's a lot of points, but we'll see what happens. And let me just return output points. Okay, this will work. So let's go over here, include, and now we're going to run main, and we're going to say out. Gosh darn it. We're going to say output points are going to be equal to that. Okay, great. And now what I want to do is image array. Now what was it before? I think it's from -2 to +2 in the x direction and 0 to 8 in the y direction. And so if we plot that heat map of image array, maybe it's -4 to +4? 4 to +4? Heat map that? Why is our, like, okay, here's the thing. There's the fern. It's right over there. Like, but It's -4 to 0? Our ranges are not working. Probably because I'm not offsetting it. Yeah, that's... Why did they offset? What? Okay, well, let's heat map that. Yeah, okay, so that might be why I needed to offset it before. Okay, let's do it. We're gonna offset it. Let's see what happens. Up here, and let's go ahead and add that offset again, even though I just removed it because I just thought we didn't need it, but apparently we do. Range diffs of 1 times 0.5. You just said that the first entry is y, not x. Yes, I did. Yes, you're correct. Let's try it one more time before making this change. So this should be 0, 8, and the next one should be -2, +2. No! Oh, I thought it would... Wait, I need to think about this really quick. Let's just make the whole thing from -10 to +10. -5, +5, -5, +5. We're still only seeing it in the corner over here. Why though? Okay, let's just add the offset because again, maybe I'm dumb here. Ranges of 1 times 0.5 plus. Then we want to do ranges of I'm stupid. Range diffs. Perfect. And then here we're going to do range diffs of 2 times 0.5 plus. Okay, let's include this guy again. And now we're going to do output points is equal to that. And now we should be able to do image array. And let's heat map that. Okay, so we see it in the center of the screen now, which is good. We're getting somewhere. Okay, so now we're going to do, give it what I think we need to give it, which is going to be 0 to 8. And then I think from -4 to +4. Well, maybe it's, let's try -2 to +2. And let's give it a heat map now. I just can't tell if that's actually different or not. Like, we see part of the fern, which is fine. It's just not being offset appropriately. Like, okay. I'm gonna be right back. We're gonna figure this out in just a second. So, yeah, give me just a second. Sorry about that. All right, be right back. Okay, back. Give me just 1 second, and then I'll turn the camera back on. Okay, so let's see. It's almost 5 already. That's totally fine. 1 second. Okay, so what are we working on? What we're trying to do right now is we're basically trying to create a very simple way to take our iterated function system, which is just going to be a collection of points, and turn it into an image. Right now, the collection of points that we're working on specifically is the Barnsley Fern, although we can also use the Sierpinski triangle. Both work just fine. For some reason, when we did things with the Sierpinski triangle, everything looked good, but when we do it with the Barnsley Fern, things don't look as good anymore. So let's go back to the Sierpinski triangle case, actually, for now, and see what happens. Right. So range diffs to, yeah, okay, let's just see what happens if we go back to the Sierpinski triangle case, which is going to be this guy, and we go there. Okay, write this, go over here, include, and now we're going to say output points are equal to this. So this is our set of output points that we have. Like, it's all the points in the Sierpinski triangle. And we could plot those, but I kind of don't want to. With A is 0, 0, B 1, 0, C, and P is 0, the distance is, I don't understand what you mean. I just made a function find the distance specifically for the Sierpinski triangle. With A is 0, 0, B 1, 0, and C. With A 0, 0, B 1, 0. Yeah, I don't understand how you did that for the Sierpinski triangle even. Like, did you just do it like the same way that we said before by like creating like a search outward from the point? Or yeah, how did you do that exactly? Okay. So anyway, what we're going to do now is, yeah, let's just go ahead and turn it into an image. Oh, we don't really need to turn it into an image, actually, now that I think. Yeah, no, we do, actually. Yeah, no, we do. But you got super high precision. How did you get so high precision? Anyway, let's go ahead and turn it into an image for now. It's specifically for the Sierpinski triangle, not using iterative functions. How did you generate the Sierpinski triangle without using iterative functions? Like, that's how it's defined. I mean, unless I'm doing something stupid, I don't think there's an analytical expression specifically for the Sierpinski triangle. I think the only analytical expression is known in the iterative function system. Right? I mean, unless I'm missing something. And if I am, please let me know, because I really need to, like, that's what I was trying to figure out for, like, the past 3 days. Okay, so this should work if we run, what? Image array is equal to that, and then we run heat map there. So here's our triangle. Perfect. Okay, so let's give this the points that we know it's going to be, which is going to be from 0 to 1, 0 to 1. Now let's try that again, heat map there. Yeah, so now our triangle is offset, and it, of course, is offset because we offset it. Okay, so, so let me try negative 0.5 to positive 0.5, and then negative 0.5 to positive 0.5. Heat map. It's still offset. Why is it still offset? Distance P to the triangle with vertices 0. Wait, you can do it for the triangle, but distance from P to the triangle with vertices 0. Okay, right. But here, I'm still not understanding what you're doing. I'm so sorry. So, how do you define the Sierpinski triangle? Like, that's my question. Like, did you just draw a triangle in space and you said, hey, how far away am I from this triangle? Or, like, I'm confused. Like I don't know how you could have done that, right? Because the Sierpinski triangle is not a triangle, right? Like, it's a collection of points that looks like a triangle, right? And so, like, I don't understand how you had an analytical form is to divide the triangle into 4. I don't know what you mean. How do you divide a triangle into 4? Okay, right. So that I thought you typoed earlier when you said you could divide the triangle into 4. So now I don't understand what you're even doing. Like, it's a triangle, right? So how do you divide that into 4? So you divide it into 4 like this. So you divide it here and here, I guess. It doesn't, I mean, are you doing like an octree or a quad tree approach? Divide into 3. I mean, okay. So if we take the triangle down here, and 1 second. So we can divide this into, divide it into 3 Sierpinski triangles. If it ends up in the middle, you get the answer. I don't know what you mean. Divide it into 3 Sierpinski triangles. If it ends up in the middle, you get the answer. So, okay, here's a triangle. We divide it into 3. So 1, 2, 3, right? And then what are you doing? Like, I have no idea what you're saying. So, I guess Steve understands, so maybe he's gonna help out. If P is between the 3, you get the answer. I still don't understand. If P is between the 3, but how do you tell if it's... I don't understand. I really don't. Okay, let's try this again. I'm going to journal new page before. I'm just going to drop the triangle image that we had here. Put that in there. All right. So here's our triangle, right? We have some arbitrary point P here. Well, I mean, it doesn't, let's put it here. Okay, so it's not in the center. It's just some arbitrary point. So you divide the triangle into 3, which means you split it up here. Here's triangle 1. Well, let's draw this with lines. Here's triangle 1. You know, triangle 2. And triangle 3, right? Okay, and then what you're doing is you're saying, I see what you're saying. So you're saying 1, 2, 3, 4, right? And then you're saying, okay, well, you know the edges of these triangles, right? So then you're asking, are you within one of these triangles? So you say, am I in here, right? So you find that you're in here. So then you just have to find the closest distance to the edge of one of these 3 lines here, you know, and then you ask which of these 3. Okay, I get it now. Yeah, that's clever. I like that. But this works specifically well for similar attractors, right? It's clever. Like I really do like it for specifically for this Sierpinski triangle. It works really well. Yeah, maybe we could work on that. Work with that for something. But in general, the attractor might not be self-similar. Again, like the Barnsley Fern, for example. I mean, it is self-similar, but like... I don't think you can just split it up into constituent leaves, for example, and do the same thing. Anyway, let me go ahead and figure out my image problem, and then we'll come back to this. This is quite clever. Okay, I understand it now. Sorry. I didn't understand what the 4th triangle was doing. But actually, this triangle 4 is the most important part. Like, you're actually trying to see if it's in this inner region here. And then, you know, from there, you basically created, like, the inverse of a convex hole. Like, not a concave hole, but, like, the inside of the triangle. And then you search from there. Yeah, it's quite clever. I like that. Okay. So, I think I realized what I was doing wrong with the image as well. So, range diffs of 1. Plus points. So, what we actually want is just ranges of 1, 1, plus the point location, and then ranges of 2, 1, 1, plus points of I2. 1 second. That's totally fine. I understand exactly what you're saying. So let's go here. But yeah, good. That was actually quite cool. Good job. Okay, so we're going to do ranges of 1, 1 plus points of I, 1. Is that correct? So, okay, so what do we have here? Every single point is a location in space. And what we're trying to do is we're trying to turn that location in space into an integer location, right? So what we're going to do is we're going to find that location in space, and then we're going to divide it by... Oh, well, there's an issue right there. How did that happen? This should be range diffs of 1 divided by resolution 1. I think this should actually work if I just do this. So we have some sort of floating point precision, and then, you know, we have the floating point values for each individual point. It's like, you know, we have a point at like 1, 1 or 2, 2 or something like this. And then we want to divide that by divide that by 4 over 1080. Yeah, that makes sense. Yeah, okay, let's just see what happens if we do this. If we include here, and then we run image array and heat map, that gives us our triangle where it's supposed to be. Oh no, it's not supposed to be there. Ah, crap. So this goes from, because this only takes into account the, okay, I'm sorry, I'm like speaking in a bunch of half sentences here. So what this is doing is it only takes into account, how do I put this? So like, we're gonna have a point that's at like, I don't know, like 1, 2 or something like that, right? And the question is, well, actually, let's put that in floating space. So it's 0.5, 0.5. And we want to turn that into an array location where it's going to be like 10, 10 or something like that. It's some sort of array location, right? So what we're going to do is we're going to say, okay, well, we're at 0.5 in X, right? And so if we divide 0.5 by basically 4, by the, like, let's say the range is from -2 to 2 or something, then it's going to be 2 minus -2. And then divided by the resolution, which we'll say is like 100 or something like that, right? So this is saying that each bin is going to be basically 4 over 100, or like, what is that, 0.025? So the question is, you know, how far along are we on this range from 0.5? Like how far along are we on this range from -2 to +2? And so we're just dividing that by 0.025. So 0.5 divided by 0.025 will give us kind of that location. Then the issue is that we need to. So the issue here is that if I modify the ranges to be like 0. If I modify the ranges to be like 0, 1, 0, 1, for example, we're going to get the same image as if I were to modify this guy to be from, let's say, -1 to 0 and 0, 1. So this is going to be the same image, right? And that's because this only really depends on, yeah, you're right, 0.04. Sorry, I'm just really dumb with math. I'm sorry. I thought it was like 1 over 4. Yeah, my bad. It's 0. It doesn't matter. 0.04. 4. And then it's going to be 0.5. It doesn't really matter. The point is, like, we're binning these guys based on that. So the question then is, how do I have this also take into account the location of the triangle along that range? And I don't know right now how to do that. So let me think. So essentially what I need to do is I need to say that this triangle has been offset by some sort of initial location. We know what that location is because we're reading it in. And I think that's what the ranges times 0.5 was doing before, which is great. Like, that's totally fine. Or was it? So if we have some random... It's okay. Let's try to figure this out. Journal, new page before. So we have some sort of point in space. This point in space is 0.50. Okay, so here's our image that we're trying to draw, right? We know that this is going to go, it's 1,000 by 1,000, 1,000 by 1,000, and we know it's from ranges of -2 to +2, and again, -2 to +2. So we know those are the ranges, we know where it's going, and everything's fine. So we have a point in space, that's here. And this point in space is going to be like 0.1, 0.1 or something. I guess it's not quite that. Let's do 0.25, 0.25, something like that. So that's our point in space. Okay. So what we need to do then is I think we just need to offset all the points. Yeah, okay, that's what we need to do. We need to offset all the points so that this -2 becomes 0, right? And so the ranges that we're reading in go from -5, let's say, if it goes from -2 to 2, then we just need to add -2 to it. So let's go in here, and we're going to do ranges of, it should be 1... 2, 1? Yeah, 2, 1, plus that, and then ranges of 2, 1. 1, 1, and plus that. And so that should give us their offset. So if we start drawing the negatives, that should bring everything back up to where it's supposed to be. So now if we go here and we do include, we should be able to draw an image right here, and that should, yeah, I don't think it should be all nans. Let's do 0, 1. And if we do heat map of that, that works. So now I want to try to like draw something that's not on there. So let's do 1, 2. It's all nans. Heat map. Of course it's all nans. Okay. Well, let's try 0.5, 1.5. Did that work? I'm not really sure what's happening. Oh, that's in Y. Let's go from 0 to 1 again. Heat map that. Perfect. Okay, so now I want to do 0.5 and see what this does. Oh, that gives us all nans. Why is it all nans? How are we getting nans? Okay. Why are we getting nans? The only time we could get nans there is if we're somehow dividing by 0, which would mean that the range differences are... Yeah, where are we getting the nans? Okay, that's fine. We'll figure it out. It just takes time. So this is basically saying that the resolution should be fine. How are we getting nans? I don't understand. So that gives us, that's fine. So what if we do to 2? That's also fine. Yep, squishes it just fine. Okay, so if we do, is it assuming that they need to be integers? 2, that should also squish it. There we go, a little triangle there in the corner. Okay, let's try 2.0. Works just fine. Okay, so now we're going to try -1. That's nans. Why? Okay. 0 to 2, just fine. Okay, the range differences, if we have... I think also if we change this to 0.5 to 2, it will also break. No, that was fine. Heat map. But why was the triangle lifted up? Shouldn't have been... Why was the triangle lifted up? we added 0.5 to it because... Okay, let's try something different then. Let's go here and let's do minus ranges of 1, 1 instead of adding it to it. So we're going to do minus ranges of 1, 1. We're slowly fixing it. It's just taking some time. Minus ranges of 2, 1. Okay, let's see what that does. Ah, for Pete's sake. Press the wrong button. Write that. Include again. Run main. Output points. Oh, I think we already had output points. I think the only thing that we modified was the image. Image array. And now we're going to do heat map. Okay, so now the triangle's lower. Perfect. Try this one more time. So we're going to do 0.5 to 1.5. Okay. Heat map. Works fine. Okay, so now let's try some different ranges. So we're going to try -1 to 2. Okay, there's just something weird. Fine. Okay, seems to work okay. So now let's finally go back to the Barnsley Fern. Hopefully it'll work this time. I'm going to remove these notes because they're no longer valid. And let's go in here and work on the Barnsley Fern. Okay, so now we're going to do include one more time. And output points is equal to that. Create the image. Well, that didn't work. 1 second. Create the image array. Okay. Nope. Nope. That's not what I wanted. One of these is right, but I don't know which one. There we go. Yep. See what this does. Now we're gonna do heat map. We are looking at a single branch of the fern, which is fine. So now what am I gonna do? I think the X ranges should go from -4 to 4, and the Y ranges should go from 0 to 8. I think that's right. Heat map. God, it's still in the corner. Okay, that's fine. Maybe I had the X's and Y's confused again. Let's change this to be... Let's see what happens if I just change that to be 0. Heat map. So that did change the Y coordinate, which means I want this to be 0 to 8. And we'll have to try to fix the X's and Y's in just a second. -4 to 4. Heat map. Okay, great. We've got our little flame in the center of the screen. It's ugly. It's not what we wanted to see, but it's something. Okay, let's... Oh, God, that was way harder than it was supposed to be. Okay, so why are our ranges... Our ranges are from X and Y, but everything else I think is in YX. Let's try this again. So let's increase this to be like, I don't know, like, let's make it 10, 100. Attempt axis 10 by 100 at indices 23, 5. Okay, well, that's good to know. Let's go ahead and fix that. We'll get there one step at a time. On line 6, output array 0s is the resolution. Okay, seems fine. What's your issue? On line 6, attempt to access create image array. Oh no, it says line 19. Okay, the image off the X val and the Y val. Oh, these must be flipped somehow. That's totally fine. Yeah, so these must be flipped somehow. But they were drawing the right way. So that must mean that the resolution here of 2... let me just do something really quick. So if I do zeros of 2 by 10, what does this do? This creates... It's 2 along X and then 10 along. So the X dimension here is 10. And the Y dimension here is 2. That's what it's going to draw, I think. So in that case, the X dimension is going to be... One second. The X dimension is 10. The Y dimension is 2. And clearly we're drawing it incorrectly here. Like, if I make this 100 by 100, it'll be fine again. Yeah, of course it's fine. It's, and this is going to break. Yep. at index 250. Why is it trying to access 250? Anyway, it's fine, but it's kind of a weird thing to randomly want to access. Okay. Oh, I see. I see what's happening. Yeah, the output array value, rather the x val and y val for each point, could be anywhere on the output array. Yep, so that's fine. Okay, so x val, y val, plus equals 1. So clearly we're not catching it appropriately. So if x val is less than resolution of 2, okay, but the resolution of 2 should be the x component. If y val is less than the resolution of 1, that should also be fine, right? Because, I mean, maybe, let's see what happens if we change this. 1, 2. Okay, so let's do include image array. We got all nans again. Dag nabbit. Okay, that's fine. Let's keep going. Why do we have all nans this time? So we change it to 100 by 100. Let's just make sure it still works. It does. Perfect. Okay, so now if we change the image resolution, it gives us nans. Because range diffs of 1. The thing is, with 100 by 100, we have an image that is like it is oriented correctly. You know, like it can scale. We can even translate it. All that's fine. Now we just have to figure out why the image resolutions are all crap. And there was one other thing we had to figure out. We had to figure out, oh, right, why the Y's and X's are flipped. See you, Steve. Thank you so much for coming in. Have a wonderful evening. And yeah, I'll talk to you later. Okay, so we are doing points of I2 minus ranges of 2, 1. 1 second. Oh, there we go. Range diffs of 2 divided by resolution of 2. So x val is less than resolution of 1, and y val is less than resolution of 2. I mean, it ran, right? That's the thing. This one ran. We just got all nans, which I don't understand. Were any of them not nans? Let's do a 10 by 1. They're all nans. 2 by 10. 3 by 10. 4 by 10. Well, it seems to be fine. What's the problem? 5. Why was 1 by 10 nans? I don't understand. All the other ones are fine. And is this actually doing what we want it to do? Yeah, it's 10 in the... Okay, let's just try plotting this one. So heat map of image array. And yes, it is 5 in this direction, 10 in that dimension. So the x dimension is definitely 10, and the y dimension is definitely 5. So it is plotting how I suspected it would plot. Perfect. Right. Wonderful. Why is 1 by 10 all nans? And 10 by 100 is also... What if it's 150 by 100? That one works. But 10 by 100 will not? No, that one works. Why is it working now? Which one wasn't? What? Okay, so the range differences... it's going to be... The range differences... are going to be... from like whatever -2 to +2 or something like that, and then the resolution is going to be 1. I'm not seeing a problem, unless no, everything started as zeros. Let me. How do we get nans anyway with this code? Like, yeah, how are we even getting nans? We're only plusing equal to 1. Let me just output x val and y val. Sure. Okay, let's include again. So we know that this one gives us nans. Okay. Did I include it? Okay, so we're not even getting to that part of the code. Okay, DD here, paste here. Okay, include image array again. Okay, right, so we're getting a bunch of zeros for some reason. Do I just need to add one? Okay, might just be off by one somehow. Control C. +1. Okay. Write that. Include. Image array. Nope. Dang it. Okay. This one works though. Yeah. Why would 1 by 10 not work? Why does that image resolution just fail? The output array of x, y plus... Right, so... How many... So we're creating the image array, and... Oh, we're going through every single point. Right, we're going through every single point, and then we're asking ourselves... Okay, let's try just drawing fewer points for now. See you, River. Have a wonderful evening. And yeah, see you around. Let's go here to write that. Go over here, and let's try it again. Include image array. It's still nans, which is great. So let's drop the number of points again to be 1,000. Try it again. Image array. Oh, I needed to include it again. Image array. Still nans. Perfect. 10. Include image array. Still nans. Perfect. Okay, so this means that we can actually mess around with it a bit because we're only generating 10 points. So let's do print line. Here, print line of y val, well, x val, new tab, y val. Sure. With that, go over here, include, and try that again. Image array. Why is it generating so many points? We shouldn't have that many points. Because... Yeah, where are all these points coming from? Control C. Over here, G. The output points is a chaos game for 10. Let me just print line output points. 1 second. Output points. All right. And let's remove the print line from above. Yep. So let's just comment this out. Include image array. Oh, am I this stupid? Yes, I am this stupid. Ah. Okay, now I have a new set of output points. If we do image array now, perfect. Okay, yeah, I was just... Now we can actually do some debugging. I was using the old set of output points, so it was like... Yeah, it was just... I was using like way too many points for that one. Okay, perfect. So now if we put the print lines in here, we can just kind of debug line by line, and we can see how this is going to go. So we're going to write this, go over here, and we're going to run output points of main. And now we're going to run, probably we want to include it again. Include, and now let's try image array. This gives us all nans, and notably, yeah, so let's also change the point offset to be 0. Okay, so we have 2, 1, 3, 1. Yeah, these are all in the array. That should be fine. I think, right? So let's just do, let's just try printing line. 1 second. Print line of output array of x val, y val. Okay, see what that does. Oh, I need to do that. That include image array. Oh, okay. So they were. Okay, DD paste up here. Okay, include image array. Attempt to access 1 by 10 at 2, 1. Okay, so this would definitely be an issue then. We've got the x val and y val definitely flipped, but I don't understand how. Yeah, I don't understand how. Okay, let's keep thinking about this a bit more. And then we can go from there. So the range, what are we doing here? So I'm saying it's going from -4 to +4 in X, and then 0 to 8 in Y. But in principle, Y should come first. So let's just go from 0 to 8 in Y, and -4 to +4 in X. And then the same thing over here. We're going to say it's very long in Y, so it's 10 and 2. And then we were having attempt to access 10 by 2 matrix at index 2, 0. I don't know how we got a 0 there because we're adding 1. Oh, right. This is just a point that's off the plane. Paste here. Go over here, include image array. That one works okay. So let's see what happens if we change this to 10, 1. Okay, so that gave us all nans, which is great. That's what I wanted to see. Let's try. Is this somehow just an issue if we just have like an array size of 1? Like if we're just doing a one-dimensional image? I mean, we did generate a bunch of nans before. 1,500. That's a bunch of... I don't know if I can regenerate this issue, honestly. Except for in the case that the array size is 1. So maybe let's just hone in on that for a second. So we know that that's a bunch of nans. Why is that a bunch of nans? It apparently never goes into this this if statement, which should still be fine because, oh, maybe it's an issue with normalize. Maybe normalize is what's doing it. Let's just return the output array. So in the case that everything is all zeros, I'm betting in the case that everything is all zeros, normalize returns nans. That's exactly the issue. I see now. Okay, so if we didn't find... jeez. Okay, so we're going to do if maximum of zeros of 5 should be, yep, of output array is greater than 0. Yep. Then we're just going to return this guy. And then we're going to say else if, just else probably, return zeros of output, size of output array. All right, that was a pain to catch, that one right there. Okay, so let's go here. Let's remove this because I don't think those offsets were actually necessary. Go over here, include it one more time, and now we should do image. Perfect. This seems to work okay. Yeah, seems to work just fine. So I can remove this guy, DD, remove that guy there. And I think we're good to go. So let's increase the number of points again to be like just a high number of points. Something like this. Include one more time. Run output points is equal to that. So now we should have the output points. And now let's try to draw it one more time. And see what happens if we do an image of 1,000. Let's do 100 by 100. And now let's do heat map of image array. Right. This is because we didn't fix the X and Y's. Let's see if we can fix that really quick. Okay, so the Y value here. So we have the appropriate points. That's fine. So now the question is, how do we make sure it's in the image appropriately? You know what? Maybe... So... Maybe we're fine. Maybe let's just do it this way. If it's -4, +4, 0, 8, this is gonna, this should be a semicolon. This is gonna give us, you know, that's our fern. It's right there in the center. It looks kind of ugly, but that's okay. So I changed this to 10, 100, heat map. What did that do? That made it so it's, why did it do that? And 10? I'm just making this really bad, aren't I? So 110 heat map. This means it's it's just completely different than what I wanted it to be. Okay, that's fine. So let's do 200 by 200. Okay, heat map. Our fern's kind of there. So now we're going to do 200 by 100. And this should make it so, heat map? It is, it's now 100 in X, but 200 in Y. Okay, my problem is that I'm inputting the ranges, like -2 to +2, X, Y. But then I'm inputting the resolution in a different way. For some reason, the resolution is being input as YX for some reason. So I thought both of them should be YX, but now I think maybe we'll just make it so both of them are XY, because I don't know how to do it the other way. So if we change these range differences, so the range differences are going to be the difference in X and the difference in Y. So then the Y value here should be, okay, it's going to be points of 1. Let's see, ranges of 2, 1. Ranges of 1, 2. And then the diffs here are going to be 2, 1. Let's see what this does. And then here we're going to have to do X values less than resolution of 2, Y values less than resolution of 1. Okay, let's try this again. Include heat map. Oh, I forgot to regenerate the image. Image array, heat map. I just can't figure it out. I'm doing something really dumb. Let's go back to the Sierpinski triangle because it's a bit cleaner to look at. Here, comment that out, comment that back in, write this, go into include, output points here. Now we're gonna do image. Oh, well, screwed that one up, didn't I? Sure. Image there. Yep, definitely. So let's go output. Let's go heat map there. Okay, so here's our triangle. Let's try messing around with it a bit. So here we're gonna do, so we know the triangle's from 0, 1, 0, 1. So let's go ahead and draw that. 0, 1, 0, 1. Okay, let's just make it 100 by 100. And let's just mess around with it a bit. So if we do heat map, that's perfect. Exactly what we wanted to see. So let's mess around with this a bit. If we change this to 99, okay, if we change this to 50, that one breaks. I don't know why 99 didn't break. Oh, I know why 99 didn't break. There was just nothing being drawn on that column to begin with. Okay, I see what's happening. Right. So that would be why I couldn't catch as many things with the Barnsley fern. Perfect. Okay, so we're getting there one step at a time. Okay, so now we know that we have our Y's and X's mixed up. We know that the Y values are correct. So the range differences are going to go in XY. The ranges are going to go in XY, which means here we're going to say points of I1. So let's just take a look at output points here. So output points, it's just going to be whatever, a 100,000 by 2 matrix. So it should be X. It's actually Y comma X is the issue here. So we're going to do, this has to be 1. Okay, and this has to be 2. Okay, in here we're going to include, run image array. Now let's try output points again. Heat map there. Okay, this seems to work okay. So let's draw this again. So it is, oh no, that doesn't make any sense. Okay, range diffs of 1, resolution of 1, and resolution of 2. Try this again. Include image heat map. Okay, so now if we keep changing the X resolution, it should scale. So if we change this to 10, it should still work. Heat map. Wonderful. Okay, and if we change this to 1,000, it should still work. Heat map. Great. Okay, seems to be working okay. Let's modify this so that the Y range is actually going from -0.1 to 1. Heat map. That didn't really help at all, did it? Maybe it's -0.5. Heat map. Oh, that's shifting along X. No. Okay, why is it shifting along X? It's shifting along X because Okay, first of all, heat map. 1 second. Did I just get these backwards all of a sudden? So the 10 resolution is in Y. So it's YX, YX. Okay, that's fine. If it's YX, that's fine. Okay, so let's change this to negative. Let's change this back to 0, 1, and we're going to change this to negative 0.5. Heat map. Okay, right. So I think it's working now. I said that before, but I don't know. Okay, so let's go back to the Barnsley Fern. Okay, so where are we? Let's grab that guy, grab this guy, write that, go over here, include image array, heat map. I think I forgot to run output points. It's going to be equal to main. Now we're in heat map. And now we're in image. Now we're in heat map. Okay, like we have something. Okay, so now what I want to do is modify the ranges and just make sure it works okay. So let's do 100 by 100. And again, the ranges here will be from... Just every time I do this, it... Wait a minute. Maybe the fern itself... Maybe this create Barnsley set is like... It's just... Okay, well, let's just see what happens. So it should be YX, so it should be 0, 8. And then negative 4, positive 4. That should be what it is. So if we heat map that guy... Oh, we have the fern in the appropriate location. Great. Okay, that's what I want to see. Let's just increase the number of points by a huge margin. And just see what happens. Screw it. Alright, include run output points is equal to main. I don't even know if I have enough RAM for all this. I just increased the number of points by 1,000. So let me actually have HTOP on the side here. Just to make sure that I'm not like using all my RAM on just like random points in Julia. It's increasing. Oh no, we're fine. No, it's okay. Okay, we have all the points now. Let's just see what happens if we run image array. And now we run heat map. Oh, it's like, I know it's there. Like I see it. Okay, so let's change the fern. So it's going to go from -2 to +2. -2 to +2. And now we're going to do heat map again. Like, you see it. It's there. It's just like, it's so faint. How do I... Okay, let's drop the resolution one more time. So it's now, it's going to be, we are going to make it 50 by 50. Okay. And now we're going to do heat map. Okay, let's increase the number of points again. All right, I'm going to have this up here in the corner. And let's just see what happens. I think increasing the number... no, but if it took like a second to run last time, I can only really increase it by 1 order of magnitude. Include output points. That's going to take some time. Oh, what are we at? We're at 23 gigs. Crap. Cancel. Whew. Okay, I'm going to close Julia for a second. Well, almost crashed my computer. I recently grabbed high-end video card just for the DDR6 VRAM to do large data processing. Yeah, man, using GPUs for this type of stuff is definitely ideal. Why did the fern look so ugly? It was clearly there. Like, we were drawing it correctly, I think. Here's what I'm going to do, guys. I'm going to drop this down to this number of points, right? This. And we're going to run Julia one more time. We're going to include, and now we're going to create another set of output points. And now I'm just going to do using plots, and I'm just going to plot this. Because maybe it's a problem with the fern, not the problem with the... Like, there were two things. One, we drew the fern with a bunch of points. And then two, we turned that fern into an image, right? So maybe the problem is actually with the fern itself. Maybe I put one of these, like, things in wrong. It looked fine, but maybe I'm wrong. So let's do plot output points. Is this going to work? It might not work. I think it requires a different input type. Yeah, it definitely requires a different input type. Do you try LDDMM? I don't know what that is. Sorry. Okay. Let's go here. Let's see. We have all the output points. I'm just going to output this to a file. You don't screw it. Write DLM output points. Okay. Include output points, GNU plot, plot out.dat point type 7. Why is it a triangle? I wanted a fern. What happened? It's the Barnsley operator, out.dat, write DLM. Did I forget to write? Ah, GNU plot froze on me. Okay, Control D. Control D. Did not mean to do that. Include tractor search. Remove out.dat. Then what are we going to do next? After that, I'm going to do something. I just need to remember what it is that I'm doing. Output point is equal to main. And now if I open up GNU plot and I plot out.dat. Oh, crap. Okay, well, that didn't work. Back. Let's just go over here. GNU plot out.dat. I think I need these guys. What do you mean you can't find a file out.dat? Okay. Attractor search. Go down here. Write DLM out.dat output points. Oh, it's because it's after the stupid return. Reset. Julia. Include. Output points is equal to that. Let's go over here. Run GNU plot. Where is it? There we go. Okay, I mean, it doesn't look bad. But I think maybe I did something wrong. Because if you look at it... Yeah, okay, let's take a look at the Barnsley fern one more time. Because maybe I got the drawing wrong. Which totally reasonable. Okay. I think maybe I just got one of the arrays incorrect. Okay, this is in here. What am I doing? Barnsley fern. Wikipedia. Okay, here we are there. And let's just take a look at these transformations again. And let's see what I actually had written down. A tractor search. So I have written down, for the first array. Oh, the Barnsley fern is not just a random selection between these guys. There's a probability of choosing each one. Right. Okay. Yes. There's a probability of 0.1 for choosing this one, 0.85 for choosing this one, 0.7, 0.7. So this thing that I made wasn't truly general. Okay, let's think about it again. So we're going to create Sierpinski set, and I'm actually just going to do 0.33. How about I do? This is a really stupid data type. But it's what I'm going to do. 0.33. And then the last one is going to be 0.34. So what I'm doing here is I'm actually going to have like a probability in here of choosing each of these different guys. And then I'm going to put that into the chaos game. Okay, there. Over here. 0.01. This one's going to be, what is it? This one's going to be 0.85. This one down here is going to be 0.07. And the last one's going to be 0.07. Okay. And I think, let me check the other numbers just to make sure. 0.16. Yep. 85, 0.04, negative 0.04 of 85. Yep. And then 1.685. No, 1.6. Oh, right. 1.6 is there. Correct. So the next one's going to be 0.2026. Wait a minute. 0.2, 0.26, 0.0. 0.23, 0.22, 1.6. Correct. And the last one should be negative 0.5, 2.800, negative 2624. Right, 0.44. I think these are right. 85, 0.4, negative 0.485, One sec. Yeah, okay. I think the rest of them are correct. So let's go down here into the chaos game. And instead of just doing point of random Hutchinson, I'm actually going to create another function in here. Function to select select fx. It's going to read in a set of functions. fx is what I'm going to call them. And here, I don't like this at all, but that's okay. Okay, so now that we have a probability with each one of them, what I want to do is fx is of 1. What is that going to be? That's going to be so 1, comma 1 is going to be, that's going to be the array itself. So what I need to do is I need to say, I don't like this at all, but that's okay. We'll just kind of go with it. So down here, what I want to say is point is going to be equal to select function. Well, actually, let's call it select array. And read in the Hutchinson arrays. And here, we're just going to call it Hutchinson again, which is a set of functions here. 1 second. I just get so many freaking spam emails, and it pisses me off. Okay. So 1 second. So we have select array from the Hutchinson operator, and then we multiply that by the point. That should be fine. Okay. So we have the random chances. So I guess we're gonna say for, I guess we have rand. This is a really ugly way of doing it, but we're gonna say rnd is gonna be equal to rand, and we're gonna say for I is equal to 1 to size of Hutchinson of 1, and in here if rand is if rand is greater than Hutchinson of 1, comma, no, Hutchinson of I, comma 2, and RND is less than Hutchinson of 1 second, I plus 1, comma 2. Then we're going to return Hutchinson of I 1, I believe. Okay, so what does this mean? So we're saying for I, so basically we could have an arbitrary set of functions, right? Like that could be 3, could be 4, could be 10, doesn't really matter. And so the point is I created some random variable, and that's going to be, you know, each one of these functions has a probability. So we're going through each of those probabilities and we're asking, hey, is our random number greater than, is it, if our random number is I, so if our random number is 1, then the random number must be less than Hutchinson of I plus 1. But it must be greater. No, wait, Hutchinson of I plus 1. Nope, that doesn't work. The rotation happens around the base of the leaf, it seems. I don't think so. Intrinsic determinants are not even... Yeah. Right. Okay, so we're going to say random is greater than Hutchinson. No, that doesn't make any sense. RD sum is going to be equal to Hutchinson of 1, comma 2. Okay, so and then we're going to do R&D sum plus equals Hutchinson, this is really ugly, I'm so sorry, of I, comma 2. Okay, so we start with 1, and we say if R&D is less than Hutchinson of 1 comma 2. Then we return Hutchinson of 1 comma 1. Okay. Otherwise we just keep going and we say, you know, our random sum is Hutchinson of 1, 2, and then we say for I is equal to, and I think we're gonna have to start at 2 here. Let's see, of 2 of Hutchinson of 1. Perfect. So now we're just going to iterate through all the other functions. We're going to say if R&D is greater than Hutchinson of I2 and R&D is less than Hutchinson of I plus 1 of 2. I think, so the random sum at this point is going to be, so like, for example, the first probability is 0.01, the next probability is 0.25, right? So what we were trying to ask is, is our random number greater than the random sum minus, but less than random sum plus Hutchinson of 1. Yeah, this should work. And then if all else fails, we're going to return Hutchinson of end 2. Okay, let's see what that does. Include main. Yeah, that's what I thought. Attempt to access 4-element array at index 1, 2. So is it 1? Okay. Is it 1, 2? Is it like this? Include main. What line is this on? This is on line 48. Okay. Let's do 1, 2 here. Include main. 3, 2. Okay, so we got past that. So what line are we on? So I reckon that's what it is. So it probably needs to be like that, which means I definitely am using the wrong data structure, but I don't really care that much. Okay, over here we're going to include one more time. We're going to run main. 5 at index 5. How do we get to index 5? Oh, that's because this should probably be length of Hutchinson now that I know it's a vector. Include main. How do we get to index 5? So line 55, it's going to be if random. Oh, there must be a -1 in here. This is really ugly code. Main. Hutchinson. I misspelled Hutchinson somewhere. Hutchinson. Over here, include main. Oh, it ran. Oh gosh, it ran. Oh man. Okay, so that totally just, it did something. Okay, so quit here, run GNU plot out .dat. Okay. That's not right. Okay, so what's actually happening here? Let's do heat map of main. Heat map of output points. Using plots. Okay, give it a second. We're gonna try a heat map of this guy. There we go. See what it looks like. I'm sure, like the first 10 elements are filled and the rest are all zeros or something. Yeah, like we're seeing basically nothing here. It's basically all zeros. I don't know why that's the case. So let's go here. G. Oh, is it because why? Actually, I don't understand. Let's change the number of points here to be 100. So it's like feasibly, you know, include main. Okay. So it looks like just like the first 5 or 10 points are available, and then it just gets progressively closer and closer to 0, it looks like. Why does it get closer and closer to 0? So let's try it with the Sierpinski triangle, because that's the easy one. Include output points. Does this one actually work? New plot. Plot? No, it still doesn't work. Okay, that's great. That's good to know. That means that our random number thing was just broken. Okay, let's try to figure this out. Select array. So we have a random number, and then basically we're asking, is our random number less than Hutchinson of 1, 2? Okay. Let's just see what happens here. I think what's happening is we're not actually entering any of these. So let me just go into print line. Actually, let me do the following. Let me just see what this actually is. R is equal to that. So R of 1, 2. That is the array, and that is the appropriate number. Perfect. Is the translation ignored, so you only have the German? No, we're not ignoring the translation. Okay, so what do we have here? The next thing we want to do is, so we know that's correct, so we are getting the probabilities. We are, okay, so we have the random number is less than the Hutchinson of 1, 2. That's the random probability. If that's not true, then we're going to say the random sum is equal to Hutchinson of 1, 2. So the random sum is now at 0.01 or whatever, or 0.33. That's totally fine. And then we're going to say, well, if the random number is greater than 0.33, but the random number is less than 0.33 plus is less than 0. This should be, let's change this to an I plus 2. I of 2. Okay, so that should be okay. Then we return Hutchinson of I of 1. Otherwise, we add to the random sum. Okay, let's see what happens if we write this and we go to include. I mean, this really shouldn't. Oh, wait. Length of Hutchinson. Wait. Oh, we can just do that. So let's go here and let's try include again. Now we're going to try output points. Okay, so we aren't going to 0 anymore, which is fine. Let's go here, quit. Go new plot. Okay, that looks like a triangle to me. It's not a great one, but it's a triangle. Okay, so let's go back here and let's add in the Barnsley Fern again. And comment that out. And we're going to increase the number of points here to be 1,000, 10,000 more. Include. Output points equals main. Quit. Go new plot. That's a fern. All right. I think we got it. Okay, so now if we do image array and we do heat map of image array, that is a fern. Look at that. There we go. That's what I wanted to see. All right. So now we're going to do 0 to 8 negative... Negative 4. What does that do? Heat map image array. Yeah, that does what I expected to do. So let's change this to be 12, maybe? Heat map image array. Okay, look. This is the best fern we've gotten so far today. It's not great. It's pretty crappy and pixely. Let's increase the total resolution here to be like maybe 1,000, well, 100 by 100 or something. Now we're gonna do heat map. Okay, like it's better. Let's try 1,000 by 1,000. 1,000 by 1,000. Heat map. Okay, it's better. Like it's not great. You can still kind of see it. So I'm gonna change it now. So let's see, 0 to 12. Let's try to make it so it's 400 by 600. So 600, 400, and now we're gonna try heat map. Okay, well, it's fine. Like, whatever. We have our fern. It's fine. We have it. Let me just go ahead and save what we have. That took a long time. Like, way longer than it should have. Git add, a tractor search. Git commit, -m, adding, working, image, generator, I guess. Whatever. Git push. Origin master. Perfect. Okay. Oh, Lana Lux, what's up? How are you? I hope you're having a wonderful day. So for well, I'm stumbling over my words. Krobin EXE, thanks for following. Really appreciate it. Yeah, I hope you're having a wonderful time. So today, yeah, okay, starting from the start. Lana Lux is a wonderful science and tech streamer. She makes a lot of games, really good conversation. I tend to just have her on in the background lurking while I'm doing other things. Just great personality, genuinely fun to hang out with. If you can, definitely check out her stream. She's just cool. Agun X, thanks for following. I don't know how to pronounce that name at all, but Montu Swede Son, thank you so much for following. Really appreciate it. But yeah, you guys just jumped in when we were, you know, we're in a weird spot. I'm so sorry. Like we're in a weird spot. We are making fractals today. By the way, Lana, how was your stream? I hope it was wonderful. But yeah, so rating new PhD guy. I got my PhD like over a year ago now. Like it's been a year and a half, almost. Like I got my PhD in December of 2019. But yeah, so we're basically working on creating fractals and stuff like that. The actual question that we're asking is, how do you know if you are attracted to a particular Sierpinski triangle? So, you know, we were just kind of messing around and created like all these different images, like this one in here. I'm going to take it one step further, and I'm actually going to output this to an image, but right now we just have a heat map. So that's the next thing that we're going to work on. But it's just very basic stuff. We just got started here. And so let me go ahead and just, let's talk about the question. So if anybody has been on the stream before, you have to rename your nickname to Dr. Simuleos. I could. I don't know. Anyway, so what are we working on? Let's start at the start. So if we have 3 points, A, B, and C, and 3 more points, D, E, and F, what we can do is we can have these 3 points, extra points, generate 3 kids. One of those children will move halfway towards A, another child will move halfway towards B, and another child will move halfway towards C, something like this. Can you see everything? I think you can. Yeah, A, B, and C might be slightly cut off. So if those kids then generate more kids, and those kids generate more kids, and more kids, and more kids, and more kids, and so on and so forth, you eventually generate the Sierpinski triangle, right? And this is because those 3 functions, the one that brings you halfway towards A, halfway towards B, and halfway towards C, essentially create a function system that will effectively create the Sierpinski triangle. Now, an important point here is that this triangle is actually not a real triangle. It's just a bunch of points that look like a triangle together. That is to say that this is not a line, it's a collection of points, right? And so my random, stupid, arbitrary question is, how do I know if I have a random point that's just sitting out here, how far away it is from not necessarily just the Sierpinski triangle, but any arbitrary function system. And in particular, the output of these function systems are called attractors. That is to say, you know, if you have a random point in space and it's moving around and following this function system, it will be attracted to the Sierpinski triangle and almost always find its way on top of it. And so what I'm trying to do is figure out how to tell if you're attracted to, for example, the Sierpinski triangle versus, for example, the Barnsley fern, which is the other image that we've been generating today, right? 2 completely different attractors made in the same way. And the question is, how do you know if they're close together or not? And so right now we're at literally the infancy of this project. And eventually it'll turn into this whole discussion of like fractal compression and, you know, how to turn any image into a fractal, all this kind of stuff. But right now it's just like the very basic stuff. I missed a bunch of follows, and then I'll catch up with chat. Super Chihuahua, Paul Shack, and also Reset BTTN Pushed. Thank you guys so much for following. Also guys, for the record, it is currently 6:00 p.m. my time. I'm going to continue streaming the science and tech content for the next hour. Or so, but then I actually wanted to hop on to play some gaming content today. I don't normally do that. I feel kind of embarrassed saying that, but I did want to try some stuff because I'm miserably addicted to Guild Wars right now, and I just kind of wanted to play it a little bit. So in an hour, we'll be shifting to that. I do apologize that, you know, we're not going to be doing science and tech all night, but, you know, it's okay. I've already been streaming for 3 hours now. I think taking an hour-long break playing Guild Wars is not the worst thing in the world. Magitsub and also Monkist and Great Numbers, thank you so much for following. Really appreciate it. Guild Wars 1, I do enjoy Guild Wars 2. Don't get me wrong, it's a fun game. But I'm just not addicted to that game. I'm addicted to Guild Wars 1. What do we have here? December 2019, very nice. Yes, it's been before. It's been a while. Yeah, I'm always off and on for streaming, you know? Sisyphus, thank you so much for following. Really appreciate it. Let me see if I missed anything. Did Lana say anything in chat? If so, like, I hope she's having a wonderful day. My numbness might subside. Wait, what are we talking about? Numbness. What do we have? Looks interesting. Okay, so like I said before, we just generated this heat map of the Sierpinski, of the Barnsley fern. So the next thing I want to do is basically just turn this into an image that I can output as a PNG instead of having it as a heat map. So I thought this was a personal preference on Sierpinski rendering. I'm attracted to see 3D renderings, not the same attraction. Oh, yeah. So when we're talking about attraction, I do realize it sounds like romantic attraction, and I have to qualify. I'm not attracted to mathematical objects in that way. I'm sorry, but it's just I didn't know any other, like, it was just too clickbaity not to say, in a way. But yeah, I'm actually really happy. You just came in right when we got this fern working, so I'm actually really happy that you came in, because I just had everything like completely wrong for like most of stream today, but now it's kind of working. So, okay, let's go ahead and create a new function just to go ahead and write out to an image, some sort of PNG file, and we can go from there. Again, guys, if you have questions, comments, concerns, ideas, anything like that, feel free to let me know. I'll totally address it as soon as I see it in chat. And yeah, just let me know how you guys are doing. And again, I'm going through things quite quickly. I realize that. If you have like specific questions, please ask. I really do my best to answer everything that you guys say. But sometimes I don't do it right, So if I say something that's kind of a bit wonky, just let me know and I'll try to fix my answer. Or if I say something wrong, just flat out call it out, Let's see, Gannett AK, thank you so much for following. I love the channel and your initiative. Thanks for doing this. Yeah, so for those of you guys who may not be aware, this is actually a combination of different projects. It's also related to the Algorithm Archive, which is a basically book to put as many algorithms as possible into a single place. So here's actually the chapter we were just looking at earlier for the iterative function systems. Oh, well, 1 second. Where we kind of talk about all of these animations and stuff like that. So actually, if you're interested in iterative function systems, I already did a long write-up. Feel free to check it out there. The other thing that would be interesting to look at is the chapter on affine transformations here, which we talk about quite frequently during this discussion, and maybe also convolutions, but maybe we might not actually talk about convolutions too much. It just comes up in the same breath sometimes. It's also related to my YouTube channel, which can be found here, which is called Laos OS and stuff like that. Have you looked into Mueller-Paris city generation algorithm? It uses L systems, and these L systems are Greek to me. I have not. Also, L systems sounds Greek to me. I think I said Gannett. I think I said thanks for following Gannett AK. If I didn't, thanks for following. Okay, let's go ahead and get this image generation done. Also, I'm doing most of my coding in Julia. It's a good mock-up language. It's also relatively fast, so I tend to like it for most things. Okay. That out of the way, I think what I want to do next is just using images, which is a library available in Julia, and just output it as an image. Now, I always forget how to do this, so I'm gonna have to remember at some point. Let's go over here. This is some old code I wrote a while ago. I think over here is actually what I want. Let's go into, okay, there we go. VI image tools. Do I have anything that actually outputs an image? Image, there should be like write image in here. There we go. And how did I do it before? So here I just said pixels, normalize. Is it just save file? Is that all I need to do? Let's give it a shot. Okay, so here we're gonna do tractor. We're gonna do using images. Okay, and then we create image array. So now I'm just gonna write image. So function write image, and this is going to take in an image array, and I think I can just do save. Is it the file name first? Probably file name, and in fact I should probably do this all in the same. Yeah, let's mess around with this a bit. So we probably want write image file name, and it should be file name and image array. But I also want to do one other thing where I'm going to say function write image. Okay, and it's going to take in it's also going to take in points, ranges, resolution, and file name. Perfect. That's what I want. And then it's also going to have the point offset equals 10. And here, and we're going to say create image array. Actually, image array. It's going to be equal to create image array. 1 second. We'll talk about the L systems in just a second. And we want points, ranges, resolution. And I think that's all I need for that. Oh, and also point offset. Do I need to, how was I doing this before? Image, yeah, I specifically need to say point offset is going to be equal to point offset, which is kind of weird, but should be fine. And let's put that on the next line, just for fun. Cool. Perfect. Okay, so now we have the image array created, and we should be able to do write image, file name, image array. And just for consistency's sake, I realize this is different than how Julia does it, but I'm actually going to put the file name at the back. Just because that's how I think about it. So screw it. I don't care. So D X9, 9X. Paste in here. I did one too many. Oh, that made it worse. Sorry, 1 second. Okay, so that should be fine. Write that. Let's go over here. And let's do include. Oh no. Okay, we have to add packages. So let's go to add images, and while that's happening, let's read chat. As far as I understood, L systems are basically some sort of recursion description, but their notation is just weird. I'm gonna be honest, I know very little at all about L systems. Like, I've heard of it, and that's about as far as I know. Include. So this should take just a second. Well, it might take longer if I'm an idiot. Line 39. Function write image. I forgot comma. Try it again. Okay, so now what we're going to try to do is just write image. We have the image array already, but let's go ahead and regenerate image array. And now we're going to do write image, and this is going to take in the image array. 1 second, and it's going to out.png maybe. I don't know, making it up as I go along. Wonderful. Okay, let's figure out the error messages. Package IO, okay. So we're gonna do instantiate. See what happens. Try it again. Nope. Hi there, you're on a roll, interesting topic. What type of simulation can you run with a database of patterns like these ones? Nice stream. Yeah, that's actually a good question. So, and there's actually a number of different ways to answer it. Okay, let's do 1 second. Let me, I'm gonna answer that in just a second. Let me do, add image IO as well. Add image IO, and then I'm gonna add that up here. And then hopefully this works, and then we're gonna go from there. Okay. So the question is, what can we actually use this for, right? And there's actually a bunch of different things here. So what we're actually leading into, once we've generated the Sierpinski triangle, and once we know the distances from the Sierpinski triangle and all this kind of stuff, we're then going to move on to the next question, which is actually related to fractal compression. This is the ability to take any image and turn it into essentially a set of function systems, right? So if we go over here and we represent the Sierpinski triangle as, 1 second, this set of functions here, function 1, function 2, function 3, in principle, we can set any image to be a set of functions, right? And then the idea is, well, if we just, use this set of functions, we should be able to like drastically compress the image itself, right? And so essentially you can use this to generate any pattern, right? And to do that, you can basically, store any 2, 3-dimensional, n-dimensional space as the set of function systems, right? The question is, how do you generate that set? And so one integral part of that is, again, figuring out how attracted you are to one particular attractor, right? How close are you to this attractor? And then once you can figure that out, you can start to, find better ways to compress your data and stuff like that. The ultimate goal here is basically to turn any image into a really interesting fractal, like filter type of thing. But really the real ultimate goal here is to find a way to improve the old methods of fractal compression, which people don't use anymore because JPEG kind of won out in the 1990s or something. But, they didn't have as much computational power in the 1990s. There weren't as many parallel algorithms that existed back then. There were a lot of things that were different about the space back then. And I feel like it's kind of worth revisiting and just kind of learning about how to you know, learning about maybe why fractal compression died, or maybe reviving it, you know, like that's kind of the question. Like, how do we beat other existing image compression libraries and stuff? That's kind of where we're going with this. But again, the representation of images as fractals is done all the time. So, like, for example, you use it all the time for, like, you know, determining, you know, the coastline of Britain. Like, it's a way just to describe shapes and stuff like that, you know. ZPingZ, thank you so much for following. Really appreciate it. Again, guys, feel free to ask any question you want. I will do my best to answer it. Again, as you just saw, I might not be the best, but I do try. Okay. So we have that installed. Let's just see what happens if we go back and we just try including one more time. And we just try write image. Did it work? Mirage out.png. Did not work, but I think I know why. So in here, what we need to do is we need to normalize our image array. So we're going to do this and then normalize image array. Okay, and I think that should do it. So we're going to do include image array should be equal to that. And then we should be able to do write image there. So let's try it one more time. God, still not there. Dang it. And obviously I am in the, I'm in the stage where I can't even write an image to file. So we're very far from being where we need to be. Let me take a look at this image again. So heat map. Image array, just to make sure this is actually working. So give it a second. So yeah, we do see, it's faint, but we definitely do see stuff. Like it's definitely our little tree thing. So now how do we get that out to file? Nice thinking. This is very interesting. Yeah, I'm hoping it's interesting, right? Like, it's kind of one of the things. In terms of compression to the older methods, what's your expectation for size reduction? Size reduction is on par. Now, here's the thing that people don't talk about, and this is, you're going to love this when you see it. Let me CD projects, Flamify. There's one particular paper I found. Let me do ocular. Let's just open up all the star dot. Let's go to notes. I don't remember what paper it is, so let me just do ocular star.pdf. It's one of these papers. I just have like 10 of them in the same directory. It's not that one. Not that one. Not that one. No. This one. Wonderful. So I don't need any of the other ones. Okay, so this right here says the performance of coding algorithms on 256 by 256 images, right? So in general, the PSNR values of figure and print images, I actually don't know what PSNR stands for. I'm not very good at this. But presumably it's a measure of, I think we can just find it, right? PSNR. Okay. A peak signal to noise ratio, right? So that to me, yes, if it's signal to noise ratio, then we're totally fine, you know? So basically the signal to noise ratio, which is it's a weird ratio to look at, but the fractal image compression is actually, I guess maybe slightly worse than wavelet or JPEG, but it's all on par, you know, with all of that. Here's the kicker though. Here's the thing you're gonna love. I love this so much when I read about it because we hadn't done it yet, so I didn't know how fast this is gonna be. So the encoding speed for the wavelet transfer. Oh, let me scroll up. So I'm not. Okay, here's the thing. All the papers say the same thing. They all say that fractal image compression is relatively as fast for encoding, and relatively as fast for decoding, but relatively slower encoding. Right? So relatively, I'm like, oh, it's probably all the same order of magnitude. No. Encoding, 0.34 seconds, 0.11 seconds, 2.45 seconds. For fractal image compression, 5.65 hours, right? So like, if you're wondering why people don't do, if you're asking why people don't do, like fractal image compression, that's why. Also, how do I, 1 second. One second. There is a... Okay, they changed this and I don't know how to do it. How do I freaking ban someone from... Okay, that'll do. sorry, I don't usually have to, I don't have to usually do moderation on this channel, so I don't do it very well. I'm also gonna clear my terminal because that sucks, and you should never say something like that. Cool. Okay, let's keep going. I'm sorry. I need to do better with moderation. I need to change my side screen so it's actually easier to do moderation. Can I do that? How do I do that? I'll try to do that before next stream. I really should be better about it, but I'm not. Maybe that should work. That'll be slightly better. Okay. Cool. Anyway, so that's the thing. It's 5.65 hours versus like 0.34 seconds. It's way slower. So yeah. Okay, so we're gonna go here, close that really quick. And yeah, so that's kind of what we're working with here. So presumably it's not the 1990s anymore. So it's not going to be 5.65 hours. And I've come up with a few methods that I think will allow us to do this better in parallel. So in principle, it should be pretty quick. Yeah, that's the thing. I feel like maybe they were like implementing the wrong method or something. So I want to try it. I want to see what happens. Is it actually going to take us 5.65 hours? I don't know. But that's the thing. Like it's super cool in principle. It's just in practice, I totally see why people dropped it. But yeah, we're slowly building up into that. It's going to take time. In the next, like, maybe 3 to 4 weeks, we'll get there. It might be longer, actually. Like, the whole thing builds into this idea of the fractal flame method. There's a whole bunch of little intricate details here. Like, it isn't, like, this is technically a research project, right? So we're pushing that boundary of knowledge just a little bit. Just not much. Just a little bit, you know? And it's something I kind of feel like a lot of people don't show, like, what research is actually like. Specifically not on Twitch. Like, there's no one doing research streams. There's a few people doing research streams. So I'm like, hey, this is something that, like, this is specifically for an academic research, you know, potentially publishable thing, you know? So that's kind of where we're going with this. Okay. What was I doing? I was just trying to write to file. That's where I was, which clearly didn't work. Out.png was not what I wanted it to be. Let's go. Just make sure mirage out.png. Okay, so what I'm going to do is I'm just going to see if it works at all. So rand of, let's do 10 by 10. And now we're going to do save of check.png out rand of 10, 10. Okay, now let's do mirage check.png. Oh, okay, there's our 10 by 10 image. It's all black and white, which is kind of weird, but that's fine. Does it expect values in the range from 0 to 1 or 0 to 255? That might be it. It could be expecting from 0 to 255. But we did get a black and white image there. So my suspicions are... Okay, let's go here and let's modify it so we're using the Sierpinski triangle because that's slightly easier to see instead of the Barnsley fern. And let's see what we get. Yeah, so I think... Well, okay, how about we do the following? Let's see what happens if we do normalize of this. Maybe what I should do instead of normalizing is just divide by the max, because normalize might make it too small. Yeah, see how that's like way more grayed out? So let's do, instead of normalizing it, okay, so yeah, we're doing two things. One, we're going to use the Sierpinski triangle to start. And the other thing is instead of normalizing when we output, we're actually just going to divide by the maximum of image array. So we're going to do image array divided by maximum of image array. See what that does. So here we're going to include one more time. Output points is going to be equal to that. And then I want to do write image. And let's check out.png. Okay, look, you're right. This looks nice, right? It's our, that's perfect, right? We see it. We see it. My only problem is I thought I just changed it to be the Sierpinski triangle. So why is it, why is it that one? 1 second. Output points. I want to see the triangle that time. Include. 1 second. Output points. Oh, image array. So now if I look at it. right image of image array. Right. Quit here. And I look at it now. Well, no, that's fine. Yeah, okay, wonderful. We see our itty bitty Sierpinski triangle up there. Great. Perfect. That's all I've ever wanted in life. Okay, so we have our triangle. Perfect. Spice on, not sure. Thanks for following, really appreciate it. Okay, so let's go back to the fern. And you notice that the Y values were flipped. That's just because of the way the image tool outputs the array and everything. So let's go ahead and fix that, and let's go back to the fern. And yeah, that'll be good. I'm actually, can I just reverse the Y? No, this is fine. Let's do it. I'm not going to worry about it. Let's just do it the right way. So in the chaos game in here, no. What am I doing with my life? 1 second. Here, there. The question is, do we actually want to like add color and stuff? Maybe not today. I mean, we can, but let's not do it today. So where are we? We are, in the chaos game here. No? Chaos game. Yeah, in here. We have the output points. No, wait. What am I doing? Here, this is what I want. We are going to want to, let's see, so are we going to want to add in the Y value? Okay, so let's go include. Oh, no, I see what I need to do. I want to do that, and then I want to subtract out, yeah, that's what I want. The points here. And then I think this will give us what we want. Yeah, I think that'll be what we want. Okay, so let's go here and let's include again. We're going to do image array. And now let's do right image. Dagnabbit. I thought that was it. But it wasn't it. It wasn't it at all. Okay, 1 second. Image array worked. So let's try heat map of that. Right, there's nothing in it. Perfect. Okay, wonderful. Let's go back to the Sierpinski triangle. I'm sorry, guys. It's just a lot of trial and error at this stage. Okay, let's go here, include again. Image array is equal to that heat map of the image array. There is no triangle. Wonderful. Okay. What I'm looking for now is an upside down triangle, so that way when we write it to the image, it'll be flipped right side up. I mean, well, we had everything working. Can I just reverse the Y element? Like I'm going to try something really quick. Let's not mess around. We had code working. Like, let's not break something that's already, let's keep it working. And let's just fix it in the next part. Because I actually like the fact that when we do a heat map, it looks correct. So I kind of don't want to fix that. I think what we should do is fix the image generation so it just flips the y-axis for us. Points of I1. I think it's still minus ranges of 2, 1. Yep. Okay, so now let me see what happens. Let's see what reverse does. So Julia, let's do R is going to be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and let's just do reverse of array. Now, can I do reverse of array 1? No. So let's do methods of reverse. Okay, reverse. Okay, what do we have here? Oh no. 1, 2, 3, 4. Reverse B dims 2. That's what I want. So we want reverse R dims equals 2. 3, 2, 1. Dims equals 1. R 1, 2, 3. So if we do dims equals 1. 7, 8, 9, 1, 2, 3, yeah, that's what I want. Perfect. So now when we write the image in here, we're going to do image array. Hear me out. I hate these one-liners, but it is what it is. Dims equals 1. Okay, write this. This should have an right side up triangle. Include. Right image. Okay, didn't work. Image array. Right image. Okay, maybe it worked. Mirage. Mirage out.png. Wonderful. Okay, we've got, it's like one of those we have a modern art piece where we just have like a single Sierpinski triangle like sitting at the very bottom of our screen, you know? Why do you hate one-liners? So I just don't like... Okay, so in my opinion, one-liners are fine if you understand the language very well. But the truth is, at least for me, when I go back on old code, I never remember one-liners. Like, I always forget them, and then I always end up taking like 20 minutes to try to remember what it was that I did in that one line. And so like what I wrote there was not particularly one-liner-esque, but sometimes like specifically with MATLAB code and sometimes with Python NumPy code, and a lot of times with Julia code too as well, you get these like very like elegant one-lines, like one-line code pieces that do like an amazing amount of stuff in that one line. But like the point of the code, in my opinion, the point when you write code, you should not only be looking at, you know, what you're writing, but you should also be thinking about future people reading that code. And if people look at the code and they think, ah, that's clever, you probably wrote code that is like, you probably wrote wrong code, right? Like people shouldn't be looking at your code and thinking, oh, wow, this guy really knows how to code. They should be looking at your code and thinking, ah, I understand this. That's really cool. You know, like, so that's why I kind of like, I'm 50-50 on like, you know, it's actually one of the main reasons why I keep my terminal limit to be 80 columns, because I feel like, you know, if your lines are too long, that means either your variable names are bad, or it could mean a number of different things, but like it just means that you're probably writing code that people shouldn't be reading, like whether it's indented too far or stuff like that. So I tend to like, if I can, I stretch it out vertically instead of horizontally. That's just my own personal preference. And I'm not saying anything's wrong with other people's preference either. That's just what I'm saying. Most developers love one-liners and less code. Readable code is certainly more important than show-off code. Right, exactly my point. Oh, comments can help, right? But it should be that the code should be self-explanatory. And then you go to the comments. Like earlier today, like there was a comment I wrote in some old code that was like, perfect. Thank you so much, old me, for writing that old comment, because I definitely needed it. But like you can't just rely on people to understand the comments, you know? Exactly, comments could mislead and stuff like that. And a lot of times people just don't write them because they think, I'm gonna remember this. But like you're not gonna remember that. You're gonna look at the code 2 years later and you're gonna be like, what did old James do? Like, why did he write this crap? You know, like and that's the thing too. You lose understanding all the time. Like my Julia knowledge was way better 6 months ago than it was now. Like if I go back to my old Python code, I'm gonna have trouble reading it. I haven't read Python in a super long time. So like, it's just, you know, write code that like, basically the way I write code is if I'm writing code and I look at it, and I would like tear it apart in like a code review. I'd be like, look, I just can't read this. Or if I would say something like, I feel like new people couldn't read this. I try to write code in such a way that people who are new to the language can still understand it. I don't succeed at this all the time, but I try to do that. I strive to make it so someone who doesn't understand Julia, who doesn't understand C, who doesn't understand Python, can look at the code and still understand what it's doing. They might not know the specific details, but like, you know, you strive to write code that's simple and fast, right? Sometimes you have to give up simplicity for speed. But most of the time you can get both, you know? It happens often, especially when I had to maneuver between multiple projects. The best comments are ones that explain confusing code. Worthless comments are ones that state the obvious. Comments or just frustration. I agree. Worthy goals. I prefer to write code with at least comments as possible, if not possible, but it's bad code. I kind of agree with that as well. Like the code should be self-explanatory, but there's definitely going to be issues with it. Like sometimes I'll just write out comments for code that I wanted to write. Like I aspire to write this thing, but it's not there yet. So I'll say this code will eventually do this, or like this code is meant to do this. And that way, if it doesn't do that, like people know at least what I was trying to do and they could fix it later, you know? But yeah, it's one of those things. Like it really does depend on the person and the language and all this stuff. Like I'm not knocking anyone for the way that they code. I'm just saying that like, for me in particular, I try to write code in a particular way. Is it the best way? No, it's just how I write code. And you know, I will never make claims that I write good code. But I will make the claim that I try to write good code. And I think that's the best anyone can do, you know? Okay, so let's include this again. Like for example, right now you can clearly see that this is like a work in progress. Like I literally started on it today. So like, you know, we have like 150 lines of code written in a few hours. It's not bad. It's an okay development pace. A lot of it is you know, debugging and stuff like that. But I think if this works, we are gonna have our Barnsley Fern image written out. Oh man, that it's a little bit light. but it's there. All right, let's try it one more time. I'm going to increase the number of points, which should increase the... Actually, let's increase the number of points significantly by a factor of 100. Rate that. Go over here. Include. Include one more time. What am I going to do next? I'm going to actually instead look at our image array, and this one I'm going to just say write image instead. So let's do write image, which should call the other function that we created. And then the next thing I wanted to do is make it so this says the file name, which is going to be out .png. Oh, I think that worked. So let's try Mirage out.png. It's still very light. In fact, I don't think it's any different than the image we just... I don't think it's any different than the image we just generated. I think it is the image we just generated. Let's try it one more time. Output points main. Yeah, it's definitely the same point. So now let's try write image. And now we're going to try Mirage out.png. It's still too... I agree with your points. I have a similar view. It's just interesting. I've never heard developers say that they hate one-liners. Yeah, I get really pissed off when other people do them. And so I know people get pissed off when I do them, type of thing. See, it looks pretty if you zoom in. Okay, let's try it again. When it's useful to document code, like the interface to a class, I prefer to write the doc outside of the source. Even if it's in this way, it is in this way at risk of getting out of sync. Yeah, I understand that to some extent. It really does depend on the programmer, you know. Okay, so maybe I still need more points. Okay, let's see what happens. Include output points. I'm gonna run htop really quick. I think I still have my htop terminal. Okay, let me have this available just in case I accidentally use too much RAM. Because 10. Okay, good. I accidentally almost used too much RAM earlier and like just completely destroyed my stream. Have you ever played with any Mandelbulb software? I've not, but I've seen the results. It's pretty cool. Actually, some of the results that we'll be making soon should actually be quite similar to some of the stuff you see there. We're actually going to be hopping into the Fractal Flame method pretty soon. In fact, I can show that off right now. So what we had worked on previously, let me show it over here. CD backup directory, Mirage something.png, save one.png. Okay. We actually worked on generating these kind of, they're called fractal flames. It's a combination of a bunch of different fractals put together. And so we were generating this not too long ago. This is what we're working on. I think Apophis is actually fractal flame. I think it uses that underneath. So this is a combination of a bunch of iterated function systems put together. It's like one that does a heart, one that does like a sinusoidal oscillation, a bunch of things put together, and you get something that looks like this. So this is kind of the stuff that we'll eventually be making. It's just basically we did that before, and now we're extending this to fractal compression is the idea. We're still generating more points. I've not run out of RAM yet, so it's okay. Can you push it to 3D? You can. It's just, it takes a lot longer. I mean, like, look at what we're doing right now. I'm spending forever, like, just generating a bunch of points for the Barnsley Fern. So this is why, probably not next week, but the week after next week, we're gonna actually do some GPU work to make it a lot faster, right? Because we're really going to have to accelerate this if we want to turn any image into a set of fractals, which is literally fractal compression. We know it's going to take 5 hours, so let's do better than that. Like, we want to make it like 10 minutes. If we can like compress any image in a way that used to take 5 hours in like 10 minutes, I think we can. Factor of 50 improvement. Wait, let's do some quick calculations after I write this image out. Okay. Mirage out.png. Did it get worse? It looks like it got worse. Okay, let's modify the image that we're outputting then. Let me do output points here. Oh, I just ran it again. No, I meant to look at the number of points. I didn't mean to run it again. Okay, well, while that's running, let's talk about okay, let's talk about it really quick. So CPU versus GPU. CPU versus GPU. Okay, so for, embarrassingly parallel systems, you can usually get a performance benefit of up to 50. Sometimes people will say up to 100 between the conversion from CPU to GPU. This, of course, depends on hardware. It's not really... I hate it when people do like these things where they're like, oh, we got a 50 times performance increase when we moved to the GPU. It's like, well, kind of, but did you really? Because like, you're not using the same hardware, and it's kind of hard to make that. Anyway, the point is, you see, usually you can, on similar, like, levels of hardware. And again, this is a very weird claim to make, but you can usually see an improvement in speed, right? 50 to 100 times. So if we're talking about 5 hours of time, right? This is in the 90s, so probably nowadays it's only 30 minutes of time, right? Because we have way more compute power on the CPU. And then if we divide that by another factor of 50 or 100, we're actually talking about maybe 30 seconds. That's not unreasonable, I think. If we can turn this code into something that is relatively embarrassingly parallel, in principle, we could be looking at a 30-second render time. That's remarkable. For every frame, we could do a video, and if every frame is 30 seconds, that's really good. Like, honestly, that's reasonable. It's still taking forever to generate this one image, though. Okay. Anyway, how are you guys? I hope you're having a wonderful day. If you have any questions, comments, concerns, anything like that, feel free to let me know. We're just... Oh, it's done. It's done. Okay, so it is a... How many zeros is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's a 100 million points. Let's change the image resolution to be 200 by 300. And let's see what that looks like. So Mirage out.png. It just doesn't... Am I doing this wrong? Like, let's go ahead and remove out.png. And let's just try it one more time. Look at it. I guess it's right. I mean, like, it's fine. It's why is it so, like, not good? Okay, let's try this again, and we're actually going to increase the resolution this time to be let's do 600 times 2, 1200 by 800. Ah, that was 120 by 800. 1200 by 800. And let's just see what it looks like. The memory usage, it was fine. It was only 10 gigabytes, so we could use more, but it was mainly the runtime. It was compute heavy. So that's why, like, on the GPU, yeah, I realize that you're running out of memory on the GPU, but in principle, you can convert a lot of that memory to, like, you don't have to keep as much data because of the way that we'll hopefully be parallelizing it. See, now it's just invisible. Like, you can't even... I mean, like, again, when you zoom in, you can actually kind of see it doesn't look bad, right? Like, that looks pretty cool. Okay, this means what? I think what I actually want to do is, like, clip it a bit so that, like... Yeah, okay, we need to think about how we're doing the normalization here. I think the normalization is what we're doing wrong. We need to shade it differently by... Instead of just dividing by the max, maybe we divide by, like, half the max. And then we say any values over, like, 1 or something, we just kind of... Let's see what happens. Let's do the following. So we're going to do a tractor search. I'm going to modify the code so that we actually don't normalize it at all. And we're just going to see what happens. I don't even think this is going to write. Oh, no, I want the reverse. Image array. Perfect. Okay, so we're going to include this again. No, we're not. Now we are. Okay, now we're going to do write image. Take a look at that. Should be up here somewhere. Oh, no. It's just all black now. Oh, well. Just increase the brightness by image over 1K or something. Yeah, we could do a gamma. Yeah, we could do that. That's what we did with the fractal flame method. But I think it's fine for now. Yeah, okay, let's leave it as it is for now. And let me just go ahead and write, just save what we have because it's kind of working. Yeah, let me save what I have. So let's do git add a tractor. So 1 second, let me add a comment at the start. So up here, I'm just going to say to do. What am I going to do? I need to fix image brightness when writing images out to file. Cool. Okay, so I just need to make sure I write that to do. And then the next question that we're going to answer hopefully tomorrow is again the question that I had at the start of stream, which is how do you know how far away you are from an attractor at any given point? So that's the next question that we have to answer. But I think this is actually a pretty good place to stop today. So like, how do you tell if you're attracted to the Sierpinski triangle? How do we know that this point here is actually, you know, how far away it is from any arbitrary attractor? That's the question that we're going to build up to tomorrow. So let's do git add attractor search.jl, git commit -m. Adding ability to write to file. Git push origin master. So yeah, I'll admit I've been streaming for 4 hours, and you know, slightly over 100 lines of code for 4 hours is not particularly impressive. But you know, I hope that like maybe you look past that, and it's I don't know. We'll see. We'll see how it goes. I'm going to be right back, guys, and then we'll kind of wrap up the programming part of today, and we'll move on to the a little bit of gaming today. I feel a little bit embarrassed for doing gaming on stream. Like, I don't usually do it, but I'll talk about why when I get back. So give me just a second. I'll be right back, guys. Yeah, 1 second. Okay, back. Give me just 1 second, and then we'll hop into it. 1 second. Okay, so I should be back. My face should be on camera and everything, I think. Oh, wait, maybe not. Did I screw up? No, I didn't screw up. I'm okay. Okay, so let's just talk about what we did today, where we're going to go with the programming stuff. So let's do journal, new page before, right? So like I was kind of alluding to before, the entire goal of this project is basically to turn any image into a set of fractals. And this is nice because it gives an analytical form to any image. Now, for those of you guys who might not know what I mean we're taking any image and turning it into a set of equations. Now, there's obviously limits to this, right? Like you can't just turn any image into a set of equations. And we want to explore that. We want to see how far we can take that, right? And this was a lot of heavy research that was done in the 1990s, right? A lot of people were talking about it. It was, you know, people thought it was going to take over, and that's going to be the de facto way to do image compression. But it didn't catch on, partly because we didn't have the computational power, and partly because, well, better ideas came along, wavelet, JPEG, all this kind of stuff. So we're kind of revisiting that, and we're asking a few questions. The first question is, you know, first of all, how do you do fractal compression? Is it actually worth doing? But the main question I have here is, how much can you compress? How much can you theoretically compress? You actually compress? And the reason this is an interesting question for me is because I just want to know it. Like, it's one of those things, like turning any image into a fractal is super cool. And seeing that it's actually useful in this way, it makes it even cooler, right? It's one of the few applications I've seen of fractals outside of just being pretty, you know? And being used to measure things via like a weird Hausdorff dimension type of argument. So that's one question that we want to answer, right? But then the other question is, how much data can you lose? Can you lose, but still have a good image out? And so the reason I'm actually asking this question is because if you look at these images here, right, it's kind of a combination of a bunch of different iterated function systems put together, right? And so the question that I'm asking now is like, let's say I just took my face and I turned it into a fractal flame. Like, well, we know based on the image compression literature that I can do a pretty close approximation to my face via fractal compression. But my question is, if we lose, like, it's a lossy compression method. So if we lose some of that compression, like if we make it so we don't properly show my face, can I make my face actually look fractally? Like, will this turn into a really cool fractal filter? I don't know, but it's also kind of interesting. So the next questions I have are more technical, like how do you parallelize this? Parallelization, right? How fast can we make this? And then, you know, kind of follow-up questions are related to these top three, like, you know, can we actually push that boundary of human knowledge? Is this publishable, right? Right? And if this is publishable, that's really cool. It would mean that like we've done something that like really pushes that boundary of human knowledge just a little bit. And this is where my mind is at for the next few weeks and what we're going to be focusing on. Like I said, just a few, like maybe, actually I've said multiple times throughout the stream, but obviously we were rated by Lana and stuff like that. I'm actually going to be doing some gaming on stream. And again, I feel a little bit embarrassed about that, but I think it's fine. You know, I've already been doing science and tech streaming for 4 hours, so I'm happy enough to hop on and do something else. It's 7 o'clock p.m. my time, so I'm just gonna move over to Guild Wars, stream that for maybe an hour, hour and a half, something like that. Just do the dailies, just kind of talk about the game, chill, relax, this type of stuff. If you want to hang out and chat, feel free to do so. Obviously, anything that we chatted about today, totally fair game to talk about more. I just kind of wanted to share. I love the game so much. I always say that I don't like gaming, and it's true that I don't usually like gaming, but there's something about this one game in particular that I'm horribly addicted to, and like, I just kind of wanted to, you know, play it on stream a bit, see what people say about it. So let me go ahead and change the stream info, and yeah, we'll move on to that part of stream. I just don't know what to call it. Okay. Okay. I think we're good to go. So I just switched categories. But yeah, if you guys want to stick around, please do. Again, I also understand if you don't. Feel free to hang out. There's a whole bunch of really good people online. Like here, I'll just call out some people that are online right now. CM Griffin is online. Tim Bideau is online. We have Ginger Bill online. All these people are great. So feel free just to hop over to their channel if you wanted to watch something different. Totally understand. But yeah, we're gonna hop on to doing some Guild Wars, so let's go ahead and talk about that really quick. Okay, so I'm going to close that. Wait, close that, open up Lutris, and launch the game. Oh man, I just don't think you understand. Like, I've spent too much time on this game recently. I have to get out my Epic Gamer mouse for this. Like, I'm just such a nerd. It's fine. It's fine. I just feel like I just don't get it. This game is just like so addicting to me. Okay, I'll talk about that in a bit though. Let me go ahead and modify my my setup. So give me just a second here. Oh, also I need to do this so you guys can't see my password and stuff. But you guys still hear it, so like maybe it's not that good. Grab that, play, and now let me go here. And I think I specifically want this over there. Okay, and then I want to press F11 here so I can set this all up. Graphics, window, this I believe is what I want. And then you should be able to see the whole screen if I've done this correctly. Yeah, this should be fine. I think this is what I want to see. Perfect. Okay, looks great. So I think there's a few other things I need to do before I start playing this on stream. Don't really remember what those are because it's been a long time since I did any of this. So let me increase this. You guys should be able to hear the background music for Guild Wars. And let me go ahead and modify the sounds here so it's a bit different. Effects volume, we're going to drop that down a little bit just because it is kind of annoying. Highest quality sound, sounds good. And yeah, so here we are in Guild Wars. If you guys don't know the game, it's really fun. Like, don't think of it like an MMO. It is an MMO to some extent, but think of it like a live action deck building game. And it's actually really fun when you think about it that way. Like, it's just fun. Like, I don't know, I have no other way to describe it. Okay, so what I'm gonna do today, just because I feel like it, I'm gonna go to Embark Beach over here. I think I've set up my keybinds. Yeah, I set up my keybinds so I can press shift. And I'm just going to grab a daily mission and just kind of play it a bit, talk about it. And yeah, we can just, I don't know, chat about it. So what else am I going to do? I think the other thing I want to do is check my inventory, make sure that I have it managed appropriately. And yeah, just hop right into it. Commandant, yep. So basically, okay, I guess brief introduction to the game for those of you guys who don't know. Like I said, don't think about it too much as an MMO. It is certainly an MMO. Like it's quite fun. You see all these other people playing. What is going on? Why is I'm having some trouble with, yeah, like for example, I'm pressing buttons, but she's not moving for some reason. Is that something wrong with, weird. Oh yeah, I'm not playing Guild Wars 2, just for the record. I'm playing Guild Wars 1. I'm having some trouble with inputting here for some reason. Not exactly sure why. So what I might actually have to do is put the screen full screen. No, I can't do it full screen because I've got a weird resolution. Yeah, okay, maybe I can just deal with it. Like the inputs are weird. Like for some reason I can't move around like I normally do. But I guess it's fine as long as I know it's a thing. Anyway, so for those of you guys who don't know, the way the game works is you have two class system. You have Paragon and Rangers, who I'm playing with right now. But you have different builds for different classes. So like, for example, I've been messing around with Paragon Ranger a lot, but you could also do Paragon Mesmer or something like that. The idea is that your primary profession gives you some added bonus. Like for example, Paragons, anytime a shout or chant, a particular skill type, lands on your allies, you get extra energy. And it's super fun because of that. You actually can do a lot of things with their build craft that you can't do with other professions. And similarly, other professions can do things that, I can't do with those professions because, I don't play those professions. I play the Paragon predominantly. Now, what's interesting is, when you're playing this game, you have access to all of the skills for your primary class and all of the skills for your secondary class. You just can't use that secondary class's primary attribute. So, for example, again, Paragons is leadership. They just gain energy when you use a shout on an ally. So, I don't know. It's just fun because you really can just play with these builds, and you have like a whole bunch of henchmen that follow you around, which you can also modify their builds for as well. And so it's quite fun. I really do enjoy playing, just messing around with it, playing and just coming up with a bunch of build combinations. Like you can do a lot of grinding in this game, but I certainly never really did that. Like I really just spend all my time just coming up with build combinations that seem fun to me and then just trying them out. And if they don't work, that's totally fine. I try another build combination, So I'm trying to figure out exactly, it seems that when my mouse is clicked, I'm not able to walk normally. I think that's what's happening, which I just need to know about. It's totally fine. Okay, so what I did today is I actually just grabbed the dailies for today, which is a Zaishen quest. Basically, every day you do certain missions and you get certain bonuses for that mission. So I'm going to hop over to Gate of Madness, and we're just going to mess around. There should be people here, I think, already for the Zaishen mission. If not, I can go ahead and ask if people want to join. LFG, Zaishen mission, hard mode. And let's just see if anybody joins. It is this one, right? Maybe I got the wrong one. If I'm in the wrong one, that's kind of embarrassing. Zaishen mission, yeah, Gate of Madness, and I am in Gate of Madness. Perfect. We'll just see if anyone hops on. I do enjoy really playing with other people, so it's kind of one of those things that I don't know, I just like having other people to play with. But yeah, so if no one's here, which is fine, it is an old game. There aren't too many people that are live. I might actually do the vanquishing first then. So let's go out here. And so luckily the vanquishing here is like in the same area, so I literally just have to walk outside the door. So I'm just gonna add a bunch of heroes and we're just gonna go for it. And if you guys have questions, comments, concerns, anything like that, feel free to let me know, and I'll address it as soon as I see it in chat. But yeah, I really do like the game. I got miserably addicted to it again recently. Like it's not even like a small scale addiction. Like I've lost sleep just thinking about different builds to try. Just because of I don't know. I have not been. I've like solely been thinking about this game for the past like anytime I'm not working on Grant stuff or like a little bit of my stuff, I've been like really focused on this game for some reason, and it's just really, it's I don't have any other way to describe it other than like, I'm just addicted to it. So Ruptured Heart should be right out here, and I should just be able to start doing it. So the way vanquishing works, actually, let me also check F11 interface, and let's move this down, this down, this down, and make sure that everything else is also good for stream. The hints we don't need. I think everything else is basically fine. The dialogues have been shifted around. Okay, that should be fine. Okay, so let's go. Again, I'm running into some issues with like the control when I'm in window mode for some reason. It's probably a Linux thing. But yeah, so the idea with vanquishing is that you literally just go around and kill everything on a map. So the reason this is kind of different than what you might see in other games is that with Guild Wars in particular, oh, also let me add a hero quest. With Guild Wars in particular, there's no respawn timers. It's all heavily instanced. So when you go into a new instance, you will always be fighting the same enemies. But then once you beat them, they're gone for good on that map. So it's kind of nice because it means that here it is, control. You never really have to deal with you know, people coming back up randomly in the middle of a fight and stuff like that. I'm just seeing who I want to attack first. So I think I'm going to want to maybe get the sorcerer first over here. Oh, I'm not doing the build I want. Let me go back. I want to do a different build, one with a pet. It's not a meta build. It's just a build I enjoy. And I figure, you know, who cares? It doesn't have to be a meta build. So let's move that out, move this out, give myself an extra speed boost. And then the other thing I want to do is add volley. Perfect. Okay. I think we can just go again. But yeah, so a lot of you guys might know there's another game that came out called Guild Wars 2. It's a fun game. Don't get me wrong. It's enjoyable. It's just, it doesn't kind of hold my attention as much as this game does. So the reason I'm playing Guild Wars 1 is just because I enjoy it more. That's kind of where I'm at. And I think I've always kind of enjoyed it more. Okay, so I guess we're just gonna hop around, and there is a monolith over here. So actually, we do want to go this other direction. I get added bonuses for killing Marganites, which is a particular group of people. But yeah, if you guys have played this game before, or you guys want to talk about other games that you enjoy, feel free just to talk about it. I mean, so I think we're gonna want to grab the Ascendant. Yeah, probably the Ascendant first. Yeah, let's go there. Okay, and we'll just go. Sure. So yeah, the thing that this build's actually super fun. The way it works is basically the moment that the enemy gets half health, I have a skill that instantly recharges when it hits someone with half health, and then I can just kind of spam it, and it's just, I don't know, it's enjoyable. So there's a cleric over here. There's also a boss, so I want to be careful about that. It is I think, elementalist, but I'm gonna get the cleric first. So we should be able to knock him down pretty quick, I think, unless I suck, which I could. So we got the cleric down. There's an executioner over here that I'm actually going to take down before the boss because I have a lot of squishy people on my team, and so I kind of want to make sure I get rid of them. So let's get this boss over here. It should be fine. There's a Blade of Corruption, but I don't really want to deal with him right now because if he goes under half health, yeah, he does a particular skill that will have him summon like an exact replica of himself, which is really quite annoying. I think we're good to go. So I think we can just keep moving on to the next area. And let's see what we have here. So we've got, so I'm going to want to pull over here and just bring people to me. And the reason for that is just there's too many people over there. So let's see. I'm going to try to grab probably the monolith group, actually. Oh, nope, they're coming this way. Let's just grab the cleric. All right. Then they'll just run back over here, and we'll just try to grab that cleric first. Oh, there's 2 clerics. Oh no, this is gonna suck. That's okay. Let's move my team back up. Yeah, hopefully this will work out okay. So also one thing that I'm doing is I'm actually, like, every time I, oh, come on. Okay, so we got him down. So there's another cleric back here, which is fine. We'll grab them. And then there's also a sorcerer over here. Also, for those who might want to play, these are all NPCs right now. I could have grabbed other players. I just decided against it. Well, it's not that I decided against it. But yeah, so right now it is all NPCs. It's a, oh, come on. So I'm going to modify my sound also so you guys don't have to hear the chick sound all the time. I've gotten used to it because I've, you know, I hear it all the time, but it's probably not normal for you guys. But yeah, so essentially, right now I'm playing a particular mode that basically has me kill all the enemies in an area. It's not the most engaging content. Is this free to play? It is. Well, it's buy to play, so you do have to buy the base campaign. Ooh, these you probably want to get the crags first, right? So, but it's probably. I mean, it is kind of expensive. It's actually more expensive than the sequel because the sequel is free to play. But you know, come on. Okay, so now the next one. Actually, where are we with? That's probably fine. We probably get crags first. Yeah. So again, take some time, but I really do enjoy the game. Like it's definitely my favorite game. Like by a wide margin, honestly. Okay, what do we have here? So see, now they're half health, and I can just kind of spam. You know, I don't really even have to think at this point. Well, unless I get blind. So now I do have to think. And my party's going down. I should have brought some like actual heal skills, but I didn't because I was kind of, you know, too arrogant, and now I'm kind of too late. Sick of WoW may check it out. Super fun. I really do enjoy it. But also it's really old. This game is like, you know, Guild Wars 2 is probably closer to WoW. I actually don't know what these guys are, so probably Acolyte is what I want to grab. So let's see. We hear nothing from the game. That does not deter me. Oh, you don't hear anything from the game? Oh, let me check. That's an OBS issue. But let me check after this fight. It should be fine. Okay. You just got to get this Dune Carver. Okay. So you should be able to hear something from the game. Oh. Wait, maybe you don't, actually. Let me... What happens if I increase this? Can you hear something now? It's probably quite quiet. Is that... Maybe it's fine? Maybe that's what I need. You're good at context swapping? My brain does not do that so well while streaming, but I try. Yeah, it's fair. I mean, it's kind of hard to do things. Okay, so where am I going, actually? So I actually don't know this area at all. Probably should have checked it, but it looks like if I go this way... Yeah, I probably want to go this way, actually, for a bit, because there's probably a mob up there to kill. And then again, I'm just going to try to clear all the enemies in this area. I honestly did not do vanquishing for the longest time. But then I kind of got into it recently. I don't know why. It's something that I just got into. Oh, come on. The other thing is that my setup's a bit weird here. Good, monoliths. My setup's a bit weird here in that, like, again, for some reason, like, my input doesn't allow me to input both my mouse and my keyboard at the same time. So, like, sometimes I'll just stop, like, walking for some reason, and it's kind of, I don't know, it's a bit weird. Is the sound okay, by the way, now? I think you guys should be able to hear it. The camera's decent in this game for such an old one. Yeah, it's super old. Let me increase the volume on my end. Again, let me know if you guys are able to hear anything, or if you're having troubles with it or anything. Yeah, the game is Guild Wars. Okay, so it's okay. But let me know if it's too loud now. Now I'm a bit worried it's too loud. So let's grab this, and I'm going to actually attack the Acolyte here, because they're a monk, and you just have to make sure that you get them. Vocal freaking minority. I hate this so much. So this particular skill, I use a lot of shouts in my build, just because that's what the Paragons do. They use a lot of shouts. And vocal minority basically means I can't use shouts. Yeah, that's all it is. So I'm kind of stuck until someone gets rid of vocal minority. And the thing is, I wanted to kind of use like a somewhat meta build. And this particular group of builds, just like, I don't know, I don't very much like it. I kind of want to build, like, I want to change the build that I'm using. But it's fine. Like, it's good enough for now. It's just that everyone kind of uses this set. So what do we have over here? It looks like we've got a big group that I can probably pull apart. So I'm just going to bring my my heroes back here. And I think if I just attack one of these guys, they'll come in. There's a cleric there, so probably that's the one I want to grab. I need to make sure my pet does not run in. So come on. And then should be fine. So now we're going to grab that cleric in there. And we should be good to go. Oh, that's the Ascendant, but it's fine. Well, one of them will go down. It's okay. Who cares? Let's just get them. And now the cleric. Over here. Should be good to go. And yeah, so they're doing Spellbreaker, which basically would mean that none of my casters could comment on it, could attack them. Which I feel like I put down the wrong volume. So where are the chicks coming from? Background audio volume? I think that's the one. No, wait, which one is it? Dialogue? UI volume? Okay, there's one of them that's making chick noises, and I want to like remove that so you guys don't have to hear it. Like again, it's something that I'm quite used to, but I feel like a lot of people watching the game for the first time might be put off on it. Okay, so I get added bonuses for killing the monoliths. The interesting things about monoliths is they can actually change their profession mid-fight, which is cool. I mean, yeah, so here you see that they're changing to something. I don't exactly know what they're changing to. Okay, let's see if we can figure out where the chicks are coming from. No, that's fine. Master volume? No, master volume is obviously not it. UI volume? I can't tell if that's it. Maybe it is? Yeah, let's try removing the UI volume for now. As you can see, we're not really in any danger here. Like, even though it's hard mode and everything, we're usually fine. Yeah, I think that got rid of it. Perfect. Okay. But yeah, if you guys want to talk about like the build that I'm using and stuff like that. So again, I kind of mixed a Paragon and a Ranger. This again is not a normal combo. So let's do the Acolyte. Actually, which one is the Necro? Because I just want to make sure Vocal Minority doesn't hit me. I'm going to guess it's the Defilers. So I'm just attacking them from a distance, so they're going to have to run up. But I think we want to get the Defilers first. Yeah, freaking Vocal Minority. Every time. It just ruins my build. It's fine. I just have to wait for someone to get rid of it. And I just did not bring enough Hex removal on this set. So there's nothing I can do about it. I just have to wait for it to kind of... Oh, there's a Dune Carver here. Yeah, just have to wait for it to leave. And my build is very dependent on shouts, so I really need to get rid of those Necros as fast as possible during every fight. Come on. But yeah, so there's some weird input lag and stuff like that, in particular because of my setup, but for the most part, it's fine. Let's see, where am I going actually? So I need to clear this entire area. So I think what I want to do is actually clear the guys in there first, and then make my way out and around, I think is what I'm going to do. So let's go ahead and grab this group in here. I think that's the right way. Yeah, let's go ahead and get near. Yeah, let's go this way. Okay, so what do we have here? They have Effigies, Acolyte, Dune Carver. They do not have... Okay, good. So this group's easy because they don't have anyone that has a shout. So we're going to grab the Acolytes first. Go ahead and attack them. Should be relatively quick. I say they're easy and watch us still fail. You know? Let's see what we have. Life Bond. Totally easy. There's a monolith coming up. My pet aggroed it. Oh no. It's fine. Totally fine. We got this. Come on. Okay, so we got the Acolyte down. Let's just keep going and hope that we don't die. I really should have brought some sort of like damage reduction. That's what the Paragons are really good at, but I didn't because I just didn't. I don't know. I wasn't thinking. I usually don't. I put a speed spell on instead of a damage reduction one. So, but yeah, happy to talk about how the game works. You know, stuff like that. So, yeah. Let's see. So we got that down. Now my question is, should I... So I have to clear this whole area, and I'm not actually sure how big the area is. So I'm not sure if I should go down here. Maybe I should go down there, and let's get that area first. Again, I'm relatively new to Vanquishing, so I need to become better at it. Okay, who's this group? This is just Margonites. Probably want to grab the Shadow of Fear first. It's freaking obstructed. Yeah, of course it's obstructed. Okay, perfect. Yeah. They're the Necro, so they could potentially, you know, have shout like removal, but I don't think they do. That's the thing. Like, so of the professions in the game, the Paragon is like either weirdly broken in a good way or weirdly broken in a bad way. You know, throughout the game, it's been 50-50, and it's such a weird profession. Like, I really enjoy Buildcraft for them because, like, half their skills are just completely useless and very difficult to figure out how to use. So, like, for this group, I'm going to want to grab probably the source. No, actually, they're all fine. But I want to pull them from that group so that we don't fight too many at a time. So let's grab the Ascendant first. Oh, it doesn't matter. Let's just grab the blade. Whoever's closest, it doesn't really matter. Don't attack, pet. Come back. Come back. Wonderful. Okay, so now we can attack. We'll grab the Sorcerer first, I guess. It doesn't really matter with this group. Okay, so the Ascendant. I think the Ascendant has a res, maybe. Okay, keep going. I think the Ascendant back there is the one I want to grab. Okay, perfect. And now we just have the Blade of Corruption and people close by. I usually try to get them... Like, usually I go for the caster in the back, usually the monk, and then I try to get the people close up. Just because, again, my line's really squishy, so if people come too close, they are in a lot of trouble. But I think it should be fine. So as you can see, we've killed 66 so far. I want to get the Acolyte first. Unless there's a Defiler, there's not. Perfect. Yeah, but in general, like, we're not struggling at all with this, so it should be fine. I didn't realize the Awakened Grey Giants were Rangers. I never paid, like, attention at all. Oh, that's another cool thing about this game. Like, every single one of the characters in this game, all the enemies and everything, they all use actual player skills. Were they resurrected? So, you know, if you want to, like, learn how a skill works, you actually will see it first in PvE before you see it in PvP. Now, admittedly, the PvP is dead in this game. Like, it was alive at some point, but it is no longer alive. But, you know, to some extent, I kind of enjoy playing this game because I kind of want to get people into it again. Like, I know no one's into it. I know it's a dead game, but, you know, I don't know. I don't want it to be dead. And so I just kind of play it a lot. Because, like, I definitely, like, I've played this game for a long time. Like, if you look at age here, I have, you know, almost 3,000 hours in this game. So, I don't know. I feel like it's one of those things that, like, my entire childhood is, like, in this game, you know? So, let's see. There should be a Ghostly Scout up there. Wonderful. Is it the Alt button that's killing me? It's probably the Alt button that's killing me. Yeah, maybe it's the Alt button. I remember now. The Alt button made everything weird. So I have to make sure I press the space button instead. Okay, so this guy is Corsair? No, that's Undead. Okay. We're just going to keep going. There's like a Shambling Mesa in here. I don't remember. I think they're Earth magic. I don't remember. No, Sandstorm Crag is Earth magic. These guys are... Oh, I don't remember. Oh, Warriors. No, we really should have gotten the Crag first. Like, it's fine. It's just that they can do more damage. All right. Yeah, I'm gonna drop down the volume of the what volume should I drop down? It's probably fine. It's just I kind of realized that, you know, those guys were being a bit annoying. Like, this sounds kind of weird. Okay, so I'm gonna have to pull this group, otherwise I'm gonna be in trouble. Now, I don't know what counts as undead. I don't know if this entire group counts as undead or not. So I'm just going to pull them up, make sure my pet doesn't come along, and there should be an Acolyte that we go for. Acolyte, perfect. Okay, and then we just kind of go for it. So this game is actually deceptively hard. Like, I feel like I'm making it out to be a bit easier than it is, but, like, it's quite difficult. Like, this game will, like, really put you through the ringer. The daily mission for today it was known for the longest time for being, like, one of the hardest missions in the game. And for good reason. Like, it was tough. And so that's kind of why I decided I would do the daily quest first. So, oh, well, I'm doing a bad job keeping my energy up. Maybe it's because these are all mesmers and maybe they have energy, denial. Okay. So what we see over here is a worm spore, whatever. It allows us to enter, like, this giant worm creature, which is, like, gives us added damage and stuff like that. I think, actually, I don't know if my builds do better than they do. So one thing you'll notice is there's a group kind of coming up over here that I'm watching for, just to make sure that they don't take us over. But it seems like they're going the other way. So I'm just trying to explain everything that I'm doing for those who might not know the game and might be, you know, considering buying it. Oh, they're dodging. Perfect. Okay. So I'm going to get into the worm spore. And I'm just going to pull up the... Yeah. So the other thing is when I get it, I have to make sure my pet died. Oh, no. Does that always happen? I guess so. I have to make sure that everyone got in the worm. Perfect. And now we're just going to attack. So let's see. I don't even remember the builds here. Oh, well, that was easy. So I'm just going to kind of move around and see what we can do. So what do we have over here? Cavalier Acolyte is what we want. Actually, I've never really played in the worms as someone who had a pet, so I don't know for sure if I get the pet back, like, you know, when I leave the worm. So we'll see. Also, these guys are doing way less damage than I remember. Holy cow! Like, I would have been better off just not doing this. Yeah, like, honestly, would have been better off had I just not entered... You see, now one of my allies is going to die because I just didn't... Oh, man. Jeez. This is like... Okay, so now we aggroed. Why am I so bad? Oh, my gosh. I think the Acolyte's dead, so now we have the Thought Leech, and then the Cavalier. Or whatever. Cavalier? Okay, then hopefully... we can get these guys before Gwen dies, because Gwen is dangerously low, and there isn't really much I can do about it. I need to check Janunda Whale. Gain 500 health if there's no enemies around. Yeah, so now everyone's gonna wail because Gwen died. Okay, so we have to get this guy, and then we're good to go there. Just the Awakened Blade Master. Oh man, this is like way more stressful than I remembered it being. I don't even know why I joined the worm group, because honestly, like, it's just not as good as my normal builds. I always thought the worm's like super overpowered, but I think I was like just completely wrong about that. Okay, so again, we start with the Acolyte. Move in. I don't remember. Let's see. Yeah, let's keep going. Okay. I have Vocal Minority, but it doesn't matter because I don't have any shouts right now. Perfect. I think if I just do this, it should be fine. Wonderful. Got a Honeycomb. Oh, the Acolyte's back up? I don't know how that happened. Perfect. Okay, so as you can see, we have 94 kills. I'm not sure how many are in this group, but we're about like maybe a third of the way done. So we'll just see how it goes. Let's see. 1 second. The Shambling Missiles are walking away, which means this might not work. No, it didn't work. Crap. That's okay. Yeah, that's fine. We'll still get them. It's just 2 enemies. So let me check the map, see where we're going. So clearly this area is not too bad. So I'm going to move my way up here. And I think I'm going to have to go back here because there's probably some enemies in there that I'm going to kill. But, you know, slowly but surely getting there. I should probably get the gold coins. Honestly, I don't think the Spore was too useful here. So let's just charge in, grab this guy, and just keep going. Again, happy to talk about whatever you guys feel you want to talk about. Even if, again, it doesn't have to be gaming related. Could be anything. Okay, so which way do I want to go here? I'm going to work my way out and around is what I'm going to do. Okay, so there's another group here. Probably want to get the Acolyte first. They are walking this way, but I think we can still get them. Yeah, should be fine. Okay, and now we're just going to go that. Oop, 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 oop. Nope, nope, no smash. Okay. Again, Vocal Minority, but who cares? Okay. And then we should be good to go if we can just hit him one more time. Just one more time. There we go. And now we grab this guy. And I think that's it for this area. Okay, so they did count as undead, which is fine. Okay, so I guess I'm just going to keep going around this area. And so the worms actually can't go into this area over here. So I'm going to go ahead and grab these Craigs or whatever they're called over here first before continuing. Yeah, that should do some damage or not. Apparently I just missed both of them, which is fine. And I'm about to die, which is not great. Okay, yep, I'm going to die. There's nothing I can do about it. Okay, well, can I run away at least? Maybe? Oh, no, we just killed him, I think. Perfect. So the whale gives me most of my health back. Do I need to go that way? I think that way is just a portal, so I might not need to actually go that way. Yeah, I'm probably gonna have to go to, well, nah, screw it. Let's go that way. We're all gonna have to get out of our worms at some point. Now my question is, what happens with my pet now? Because okay, my pet's fully resurrected. Perfect. Okay, let's talk to this ghostly spirit over here. They give you certain buffs. Just, you know, extra points and stuff when you kill certain enemies. I already had that buff though. So that's fine. Okay, so let's just keep going. I just have to remember to press the shift key instead of the alt key. And I think that should fix my issues with the whatever. Okay, so we have 105. We're slightly over a third of the way done. I would argue maybe 2/5. And again, we're just kind of working our way through. I don't care what this person is selling, so it's probably fine. I'm looking around for any enemies. There is some up here, just a typical awakened group. So we're just gonna attack them. Now the one thing I have to check out is for defilers. There are not any, so it should be easy. And we're just gonna get them when we can. Okay, so now I see why there was a worm spore. I think we have to go that way. So we're just gonna attack this acolyte. For some reason, it's going down a bit slow, which is somewhat surprising. There we go. Okay, so now let's grab the effigy, who is an elementalist and can deal some damage. And then we'll get the this blade master here, who is just kind of wreaking havoc. I did not mean to attack the spirit of quicksand, but that's okay. And yeah, so I'm not seeing so much in chat, which is fine. Like, obviously, totally fine. Awakens head, there's 2 of them. Okay, one more. Okay, I think I do need to get in the worm spore. So if we go this way, we're actually going to die. So I need to get the worm spore now, which is back there. I probably should not have. There's an awakened blade master and stuff, so let's grab that group as well. And also some monoliths. Maybe should we grab them before or after we get in the worm? I'm gonna say we grab them now. So let's see. There are the Cavalier, Acolytes. I think is who we want to go for. Okay, and we'll just keep going. I didn't realize that these guys counted as undead, if I'm being honest. I probably should have, but I just never, like, when I played the game earlier, I just think I never recognized that these are undead creatures. In the story, they are actually, like, servants to this guy named Palua Joko, who's like this, you know, oh, that's the Cavaliers can revive. That's what I missed. Who's like this undead lich character and all that kind of stuff. It's actually, I quite like the story of the game. I understand why people might not like it, but get the worm spore. And every time I do that, my pet dies and it makes me feel bad. I think we've cleared this area. I mean, we can look around one more time, but it looks like we're pretty clear. So let's grab the monoliths over here. I think we've got this area. So one problem with the vanquishing, though, is that, like, when you're doing the vanquishing, like, I'll be honest, like, sometimes there just aren't creatures around to kill, and it gets a bit frustrating. So see, how do we want to do this? I think going this way... Actually, how do I want to do this? I think I'm going to go this way for a bit. We're going to grab the acolytes. Yep. And then we have to remember that the Cavaliers have resurrections, which I was not aware of before. I just totally missed Oh, that is a boss. Oh, we might be in trouble. I just didn't... Okay, that's fine. It is a boss monk, which is not great. But Signet of Judgment, which is probably fine. Okay, Sunburst Spear, totally fine. Should be good to go. And then the effigy. I don't remember what the Sunburst Spear looks like. Let's see. Actually, I quite like that spear, if I'm being honest. I think it looks pretty cool. But it's not particularly good in terms of, like, stats. So I guess we're going to go this way. Let's see. Map. And then I'm going to work my way around. I do think I need to go back, though. So what I might actually do is Zetuka's Jug. Yeah, we'll go. I'll grab that. There's no acolyte there. Interesting. Okay, so I think I need to work my way back because I'm pretty sure there's going to be an enemy around here that I need to kill. So let me just go back there. And then we'll keep going from there. I recognize that vanquishing is kind of a weird thing to jump in on too. Like, if you haven't played this game before, it's probably, like, not a particularly, like, engaging part of the gameplay to watch. Totally recognize that. Oh, how do I... Are you telling me I'm going to have to go all the way around? Do I have to go all the way around to get in there? Oh, Oh man, I'm positive there's going to be a few enemy patrols in there as well. If that's the only way to get there, though, okay, I guess I'll try to hope that there's no one there, and we'll get them at the end. Oh, it's going to be like 10 minutes or like 5 minutes of just walking around. So while we're just running around, I'm going to go this way and work my way up here because I know that we need the worms for some reason to get over there. So this area, only the worms can go in, so humans can't. But yeah, in Guild Wars 2, they actually have a lot of different like races and stuff like that, but that's not this game. 1 second, I have to wait for the rest of my team to catch up. Okay. So, but I do really enjoy this game a lot. Oh, I should have gotten the Crag again. I always go for the wrong guy. That's fine. So now we have the Mesa. Should be easy. Oh, hello, Desert Worms. How are you? Okay. I did not realize. There's Norgu. Goodbye, Norgu. Man, these guys are no joke. Okay, hopefully we can... Yeah, Norgu's dead. That's probably fine. Yeah, this will probably be fine. I didn't realize these dead worms... They're like pro. Holy cow. Okay, Solemn Sphere, totally fine. Everyone's wailing, should be fine. Okay. Let's just keep going this way for a bit. It looks like, honestly, there isn't much more to this area. Looks like it's just some mesas up here and Sean over here. I don't really know what Sean's doing. Okay, screw it. Let's just go. I use Arch, by the way, down here is kind of a bit struggling. Okay, so we're full health. Let's go ahead and get these mesas up here. Did we really have to come all this way just to get these mesas? Is that it? I'm sure the quest was like, just come over here or something like that. I should have taken the quest now that I look at it. But it's probably fine. Okay, so we're close to finishing this up. Okay, perfect. I'm sure that was the quest, just to talk to Sean. Well, let's just go a bit further just for map completion. Just to make sure that I'm getting the areas. Should be good. So there's a lot of things to do in this game, but a lot of it, like, I'm gonna admit, a lot of it does feel kind of grindy. Like, for example, like what I'm doing right now, you're just kind of clearing all the enemies in the area. It's kind of more of like a, I don't know, I think the reason I enjoy it is more for a, oop, hello there. Let me just do this button. Like, it's just a enjoyable, like, kind of casual game. It can be quite stressful. It can be quite difficult. But for the most part, it's just, I usually play it because it de-stresses me more than anything else. Oh, there's another desert worm coming up? How? I thought I just got them. That's fine. It's good we got them now so that, you know. So the desert worms do go up and down, so somehow we might have missed them. Yeah, there was actually, the other day, like, my friend and I were trying to find, like, you know, maximize an elite skill. So the way it works is if you want to get an elite skill, which are these skills with the golden bar, the only way you can get those is by killing an enemy and then capturing that skill from them. Because, again, the enemies in this game use allied skill bars. Gwen, what's her... She's at -14. It's not so bad. Okay. So, you know, in order to get the elite skills, you have to capture them from your enemies. And so we were trying to capture an elite skill from this worm boss. And quite frankly, the worm boss just kept going underground, and we accidentally killed it when it was underground. And we couldn't capture the skill because the boss was not there anymore. It was underground. So, yeah, it was a bit frustrating. So I'm just kind of scouting ahead. You know that my party's back here, and when you're playing the game, you want to make sure that you're with your party, specifically with my profession, which is a paragon. I really do get a lot of benefits from being around. Sadistic Giant, really? I'm just going to get this locked chest over here. Giant's Boots. Let's see what those are. What do we have? I'm actually going to have to do some inventory management in just a second. Earth Prayers +3. I don't think anyone actually wants that. So, you know, when you look at like basically items and stuff, you can identify them and get added benefits. The Nomad Giant. Why does everyone have ulcerous lungs or something that's like, you know, keeps you from activating shouts? Okay, I'm gonna grab the Ancient Scythe because I don't know. It's good to grab. It will if I what did I say? If I need like extra iron or something like that, I can get it from that. Oh, there's another Jenner here. Interesting. Oh, I should not have done that. Oh, I'm gonna die. I was too far separated from my party. And I really gotta make sure that I'm like grabbing the edges of this map because there is the potential that like you also need like a cartographer title, which you get from, you know, going through 100% of the map. But sometimes you do have to kind of scrape the edges a bit to get there. I think maybe that's why they like added a like random NPC right here so that you would get to that exact location and talk to the NPC. So if you were looking for the cartographer title, you definitely get it. But you know, like if you look at the map, you'll see that some of the areas unfog around where I'm going. So you just have to make sure that you're relatively close to the edge as you're going around. Yeah. So, how's everyone doing? Hope you're all having a great day. Let's see. So we're gonna have to get out of the worms here, and then I think we're just gonna grab the groups around here. Should be pretty quick. So what do we have? We have Graven Monolith, Sadistic Giant again. We're gonna have some trouble with them because of the ulcerous lungs, but it should be okay. So I'm gonna grab the Monoliths first over. Well, no, the Giants are closer. Let's grab them. There's also a Ghostly Priest over here. Again, they give you certain benefits. I have ulcerous lungs, which means I basically shouldn't shout. It's not that I can't, it's just that I really shouldn't. Because it will give like the entire team like a lot of health degeneration and stuff. Which sucks because my entire build is really reliant on shouts and stuff. Okay, so I think if I just get this area in here, I think I can work my way back around and then we'll be at the Mouth of Torment again. Honestly, we're only about halfway through with this particular Vanquish. I didn't realize it would take so long. But you know, it's okay. How do I want to do this? So I know that there was a group of enemies that was going this way, so maybe actually I want to go that way. Are they giving me a buff that I already have? No, what is this buff? Giants. Oh, so there's gonna be a lot of them coming up. That's not great. Let's go and grab that group that we missed. It's right up here. And there we are. So yeah, this is my one big complaint about vanquishing is sometimes it's just like 2 or 3 enemies, like really far away from other groups. So like sometimes you just gotta have to, you know, run around the entire map. And it's a bit frustrating sometimes. But luckily, as long as you can get like a real party for the missions and stuff, usually they're pretty good. Okay, so 105 gold. Okay, where are we going? I am gonna keep walking this way a little bit, see what we can find. I think it's okay. I think maybe I can actually work my way. Yeah, we'll see where I can go because there's definitely a group of enemies right there. So I might be able to work my way back to the start and grab those enemies that I'm pretty sure I missed at the start there. So you can see the enemies are kind of migrating in. I don't know what they are. It's just Margonites and stuff. So we probably want to see what they have. Actually, what are they? Awakened Defilers. Okay. So there should be a Acolyte back here. Oh, I missed him. Oh, it's okay. We can get him. I just had to make sure that, you know, my pet has been doing nothing. Yeah, let's just grab all of them. There's a freaking... They got me. That's okay. It's fine. Let's grab the Defiler so they can't get me again. And now I just have to wait for the... I have to wait for the Hex to wear off because, again, I just didn't bring Hex removal. Okay, it's down. And unfortunately, they died. So there wasn't really much I could do about it. Okay. So let's see. I think this does bring me back to the start, which is great because, again, I think I missed a group over there. So we'll go back and grab that group. There are some more people over here that I know I'm just going to... Yeah, here they are. So let's grab the Cleric. I'm not too worried. I think we should be fine. So the Cleric has Spellbreaker. This is a boss. I didn't realize there was a boss enemy in here. That's fine. Again, it's a Paragon boss, and I just the AI does not do very well with Paragons, so I usually am not too worried about them. Okay, another group up here. Again, it looks like it's just Margonites, so we'll grab the Cleric first. Oh, I should have done. Yeah, it's fine. Is there a? There's not. So the one I look out for when I'm looking for enemies is the Warlock, because again the Warlock again has the shout or the hex that makes it so I can't attack. So that's the one that I have to kill immediately. Overall though, this is relatively quick. I mean, we'll get through it. I just have to figure out where the rest of this map is. So I know. Let's see. I know there was a bridge over here, so I think the best way to do this is probably to walk back through where I started. So I think there's another few groups over here that I missed. Oh, there's a lot of enemies. Holy crap. What is the best way to do it then? Should I go back around this way to grab all those guys and then work my way back through? I think that might be what I want to do. Yeah, that's what I want to do. That's totally fine. What OS are you running? I'm running Arch Linux. One of these, one of my henchmen is actually, I use Arch, by the way. Defiler. Sorry, I missed that a few minutes ago. I was not, it's just freaking Defiler every time. I just haven't been keeping up with chat. I'm sorry. I need to be doing better about that. Like, chat's on the side of the screen for a reason. I usually do a lot better when I'm doing like programming streams and stuff, but I struggle a bit with the gaming streams. So let me just clear this area. There's a locked chest here. How many lockpicks do I have? I still have another one. So it was broken though. Here's a Ripper Blade. What is a Ripper Blade? Does it look cool? I mean, that looks cool. I don't know if people are into it. Oh, but it's 13 swordsmanship, so no one actually cares. Okay. So what did I say I was going to do? I think I have a lot of enemies to kill. Let's grab, like, just get rid of this group over here, just so that I don't have to come back to this area in particular. There's no Defiler, so we should be okay. Oh, there was an Acolyte, though. Yeah, we want the Acolyte. Yeah. Again, if you guys have questions, just ask. I'll do what I can. To answer them as soon as I see them in chat. Effigy. Dune Carver. Oh, we just pulled. Okay. That's probably fine. We'll do okay. Okay, perfect. So now we have to get the Dune Carver, which is still there. Right. Okay, so maybe we won't do okay, because this Sandstorm Crag is like really royally, it's hurting us, but that's okay. Let's go there. No, come on. Okay, it's fine. Yeah, we got this. It's easy. Yeah, easy. I don't know what I was worried about. Yeah. Shouldn't have been worried at all. Easy. Alright, let's keep going. Again, I'm just gonna clear the area. No, I'm gonna work my way back around here. So let's go back to the start. And go from there. But yeah, the game is super old, right? Like, it was made in like 2002 or something like that. But there's a lot of charm to it. There's not a portal that I'm going through, right? Where is that portal? It should be right there. Perfect. Okay. So I think we've already got the blessings from this ghostly spirit, but we'll talk to him anyway. And there's some Margonites up there that we're going to have to work our way through. Yep. Okay, so do they have a Warlock? I don't think they do. So I think we want to go for the Cleric first. Did I screw up? I think I did. Yep, definitely screwed up. Should not have attacked just then. That's okay. Again, like, we haven't really been struggling so much. I mean, I used to struggle so badly with this area of the game. Like, honestly, the first time I played through the game, like, I didn't realize there was armor in the game. So I didn't realize, like, you had to buy armor for your heroes. For you. So I just went through the entire game with starter armor. Completely on accident. And so the way this game works is that the enemies will aggro or will, like, attack you if you have the least armor on the team, because they're assuming that you're a caster, because casters have less armor. So they just kind of attack people with less armor. So I would always be the one that was killed first, because I just had starter armor. Actually, wait, that might be the only group that we have to kill. 1 second. So we might be able to just walk our way back now. Yeah. Oh, there's another locked chest, but I don't have a key anymore. Crap. That's okay. One of the titles in this game is for opening 10,000 chests, and I have 3,000 hours in this game, and I've only opened 221 chests. So probably not getting that title, if I had to guess. I'm just gonna work my way back the direction I came, and we're gonna work our way around because I don't need to clear that area. I've already done that, so we're just kind of slowly but surely work our way around. It's 7:44 p.m., which means I've been playing this game for about 45 minutes or so. So we should be finishing this up soon. Again, we're like 2/3 of the way done with this, and then we have one mission to do, and that should be quick because as long as we can get hero or other players to play with us, it's usually pretty quick. I just switched to a more like meta build for those. Ooh, hyena. I don't actually want a hyena as a pet. I've got my flamingo and I'm happy enough. Okay, so we're gonna, there's a lot of enemies, so let me pull a group. Actually, no, they're coming to us. That's fine. Right, so there is a Reaper. It should be fine. I don't see any problems with this. Yep, the cleric's down. Well, should be down if I can do my build properly, which I apparently can't. Let's no longer flag the heroes so that they start moving about. And I think there's a boss right there. No, that's just a bowmaster. But I've got a feeling there should be a boss around here somewhere. So I'm going to pull one of these two groups. Maybe the monolith. Oh, no, I grabbed the wrong group. It's okay. Let me just move them back a bit. That's fine. We got them. This will be easy. So actually, this build like doesn't really use a pet at all. Like really, there's no reason to have a pet on this build except that all my everyone's really squishy. So like if they get hit once, they basically die. So the pet's really good at like making sure the enemies attack it instead of my heroes, which is really important. Yeah, perfect. Wonderful. Okay. So now we're going to go up to this group. Should be, again, I think we're on the tail end of the Vanquish. So let's do the cleric here. Yeah, should be fine. Okay. Guess maybe not. It's okay. We're doing fine. Wonderful. Okay, so the bowmaster is the next one that we can take out. And then we're just going to go for the, yeah. How did they heal? Oh, press the buttons wrong. That's okay. I don't see anyone over there, so we're probably fine. Let's see, where are we going? I guess I'm working my way through here, and then I'm going to work my way over there. I guess that's what I'm doing. Who is this guy? Spirit of Quicksand. Should be fine. Keep going. That just means that this group probably walks all the way up here and then goes down there. There should be a cleric with these guys somewhere, but maybe it's just the Ascendant. Now, I want to be careful not to aggro too many people, so let's just... I think I can attack them from here. Yeah, and then they'll come this way as long as my pet doesn't run in. Okay, so now the pet can run in. Let's grab the Ascendant. Oop. I keep pressing the wrong button, and I just... Shadow of Fear, sure, why not? Yeah, let's go. The way this build works is I have this thing, there's this additional mechanic called Adrenaline, that is basically, so you have energy, which is a blue bar. Adrenaline is this way that you can like, oh, there's actually another group up there. It's basically just another energy mechanic. And so the way this build works is I have something that allows me to consistently get double adrenaline. Actually, 140% more adrenaline. And then I just kind of like burst through it, you know? And so I use that to gain more energy and everything like that. It's really dependent on adrenaline. And so I have this thing that by putting these two skills together allows me to keep the adrenaline going all the time. Again, ulcerous lungs, but whatever. I just need to know that that's a thing. And then I did see that other group that was kind of like going in this area. So I just have to remember that's where I need to end this circuit. So that means I need to go this way, kill these groups. I don't want to aggro both groups at the same time. Yeah, especially not... Well, no, this group's actually probably pretty easy. Let's grab the seer. Oh, I had ulcerous lungs and I was not paying any attention. It's okay. But yeah, there's a lot of things you can do in this game. Like a lot of people have been getting really into like speed clears, which are, you know, like speed running, but for like specific elite dungeons. I've actually never played an elite dungeon in this game. It's just not something that I found particularly engaging, you know? It's fine though. Again, I was more of like a build crafter. That's what I always did. I was always pretty happy whenever one of my builds went meta. And there were a few, definitely a few. Again, almost mainly just Paragon builds. That's what I normally build. Okay, next one. So let's see. Yep. Oh, well, it's probably fine. And these guys. Okay. Yep, perfect. Oh, I'm blinded. Crap. I was not paying attention. That's okay. Okay, let's keep going. Yeah, just gonna see if there's another enemy group over here that I missed. I don't think I did, but maybe. Yeah, because we're so close to the portal now, I'd be surprised. Yeah, I'd be very surprised. I think this is where I started. Yeah, this is where I started. Okay, great. So this is just moving the other direction from where I started before. And again, we're so close to being done. We're like literally 10% away. And then I can move on to today's mission. And I think that's where we'll end it for today. We'll just do the mission and stuff. So there's a particular title in this game that you can go for called God Walking Amongst Mere Mortals. It's basically for maxing out as many titles as you can, like, well, 30 titles. It's not as many titles as you can. I've always wanted that, but I never really went for it because I just never went for it. I don't know. My inventory is full, so I'm going to have to do some inventory management. I'm going to drink the jug. Probably shouldn't have, but that's okay. And let's just mess around a bit. So what I'm going to do is just kind of anything that's not a anything that I can salvage, I'm just going to go ahead and do that right now. It should be relatively quick, just to free up some inventory slots. There's actually like a mercantile summoning stone that I could use, but I just didn't feel like it. Salvage item. This up here. 1 second. This should be enough, I think. Well, I'll just kind of finish it up since I'm doing it. Longbow. And then I think dead staff. Okay. Grab the axe. We can probably get the whole group together. It's going to be hard to split them, but I think I can still do it if I want. Oh, is there a warlock? No, there isn't. We're fine. I just hate warlocks so much. They also do this thing where they make it so I can't use my shouts and stuff. It's just annoying. Sites of Chaos is really doing a number on Livia. That's okay. Let's do the sorcerer over here. Sorcerers are also kind of annoying because sometimes, you know, those enemy types carry blind, which is quite annoying for a lot of the, you know, martial users like I am. Sunburst Spear. I really like the Sunburst Spear. I think it's actually my favorite spear, like my favorite spear in the game, like just design-wise. I mean, there's like the Voltaic Spear and stuff like that that are like also really good, but I like simpler designs, so... that was another thing, like Guild Wars 2 has like super like, not gaudy designs, but it's like a different level of like visual bloat in a way. This game's like way more subtle. It's also more about like parties and stuff like that than Guild Wars 2 is. So I think what I have to do here, I think I'm going to have to work my way down this way and then around here and then back there. So I think that's what I'm going to do. So I'm going to move back here. There's some giants, which sucks. And then there's a monolith back there. These are also... Okay, let's just go. We want to get the sadistic ones first, but there's nothing I can do about it. Oh, wait, do I not have ulcerous lungs on me? Nice. Okay, so the monoliths are coming up, but we should be okay as long as we get this nomad giant first. The monoliths really don't do too much. They're just kind of annoying. Okay, never mind. There's blind, and also, is that dazed? Oh, it is dazed. Okay, well, I don't have to worry about dazed, but I do have to worry about blind. Give me a second. Yeah, let's go. Blind. Okay, let's just keep going. There's some bleached bones up here. I actually don't know what these are. That was a trap. Oh, wait 1 second. Why am I... Okay, hello. I am consistently running forward, and there isn't really much I can do about that. So let me minimize and maximize again. Okay, good. good, good. Um, there's been some weird things that have been happening because I keep pressing the Alt key. And the Alt key is like, what is this? What are the bleached bones for? The Alt key is obviously useful for like moving screens around and stuff, but, oh, hello. We probably want to get this guy first because he might have ulcerous lungs. Oh, nope. These are all easy. I think, unless the Nomad Giants, are they? No, these are all easy because they're all Rangers. So, but yeah, chat's kind of quiet, so I don't know. I don't know if I should do more gaming streams or not. Like, it's not something that I typically do. So I don't know. I might just play it on my own, you know, type of thing, and not worry about it too much. Okay, so there's another pneumatic giant here, and should be good. Okay, Giant's boots. We're so close to being done though. Like, I mean, look at that. It's mostly finished. I'm gonna run back here just to get to that next portal. I don't think there's anyone back there though. Oh, never mind. That looks like there is. Oh, this just is the ghostly spirit. And this should clear a bit of the map. What is that? It's Ganji. Maybe I should have taken these guys' quests. Like, I'm pretty sure I would have completed them if I would have just taken them. I don't know. I mean, do they give me anything? I guess Lightbringer points. Ancient artifact? It's fine. It's fine. Let's just go. I probably should have taken those quests because again, like, there's probably nothing bad about it. So, okay, so I'm gonna work my way up here, back around, and then I know there's an enemy group patrolling that area. In fact, that might be the only enemy group I have left. Nope, that's not true. Here's some more enemies. Well, there goes that theory. I'm not gonna take the spore because I don't really need it for anything. And let's see, sadistic giant is the one I want. Let's just grab that. Please just don't use ulcerous lungs. Get them. Good. Perfect. Now it doesn't matter anymore. Yeah, like I will go for the warlock before, like the necromancer before going for the monk if I know that they have like ulcerous lungs or something that makes it so I can't use a shout. Just because, yeah, sure, I know you have to get the monk, otherwise you're not going to win the fight. But like at the same time, I just can't. Like, they're literally preventing me from playing the game. So it's just, I hate the fact that ArenaNet, who are the ones who developed the game, like basically just invented a skill that makes it so certain people can't play. It's kind of, I mean, I get it. It's like the same as how in Magic, like, there's like cancel spell and stuff like that. It's the same thing. It's just a hard counter, and I don't really like those types of counters. What are these bleached bones? Should I know what they are? Sadistic giant. Let's grab them. All right, ulcerous lungs has been gotten. Pneumatic giant. Perfect. Easy. Now, where does that bring us? That portal. That brings us... Actually, where does it bring us? That brings us to Crystal Overlook. Oh, interesting. That's actually... I didn't realize that was here. Okay, so there's a bridge there. I don't need to go over there. Well, maybe for map... Well, it's fine. It's fine. Let's just grab this group over here. Again, I kind of want to finish the Vanquish. Neither of these are an issue. They're both pneumatic giants. I might go over there just for map completion, but I'm pretty sure I'm gonna have to go to that same group like when I do the vanquishing for Crystal Overlook. So, but just to be safe, let's just run over there. There. Okay, but we're close to being done. I think we just have this last group, this last section to get, and I think there's only that one group that I missed before that we have to grab, and I think we're basically done. Who's this guy? This guy is, never mind. I said that twice and I've been wrong both times. So we're going to grab the sorcerer first. Yeah, so far this has been a relatively easy vanquish. I thought it'd be a lot harder than it was. Again, I used to be terrified of doing vanquishing and stuff like that when I was younger because I don't know, it's one of those things that you get kind of in your head about how like, oh, you're not good enough to do this type of thing. But it's actually like nowadays with the builds that are available and all that. Sadistic giant, there. It's actually usually pretty easy to do nowadays. Okay, yeah. So I'm just gonna make sure I grab the appropriate parts of the map. And then we should be good to go. Okay, No mad giant. Okay, perfect. Alright, just gonna kind of make sure that I'm, you know, getting this part of the map. I'm gonna move back over here. Oop, hello, bridge. Oh, we're so close, come on. I'm just hoping like I didn't miss a patrol. Like that would be awful. I mean, the thing about vanquishing too is it's one of those things that's a bit grindy, but I find it kind of oddly relaxing in a way, you know, like you're just kind of going around. It's like, you know, picking weeds or something, an Animal Crossing type of thing. So I know there's that one other group to get, and I think that's it. I think once we get that group, we're done. Have I been over here before? Yeah, I certainly have. So, and then I think there was just that one group going this way. We should get there. Yeah, right there. Has to be it, right? Like we're at 236. It looks like we're almost completely done with the Vanquish. So this has to be the last group, right? We want to get there's a Cavalier who has a res. So we probably want to make sure we get them. Did I just went all in there. I didn't even like pretend to care. Okay. The Cavalier is the first one down, and then the rest of them should be pretty easy. Thought Leech is fine. Well, I use Arch, by the way, he's about to die, but who cares? Assuming that this is the last fight, it doesn't matter. The only like downside for dying in this game is that you get a death penalty, and it means that all of your, well, it's actually kind of a big downside. All of your skills and everything end up being like 15% less effective. So it basically means all your stats are 15% less effective. So the Awakened Heads should hopefully be... Oh, I see what's happening. I never realized that the Awakened Heads come off the Awakened Giants. Interesting. I should recognize that for next time. Please be the last one. Oh, no. Crap. I'm at 241. Oh, there's a Blade Master back there. Oh, thank goodness. Oh, I thought I missed like a group somewhere. Okay, perfect. So now we're going to go back here. Just head on over to Gate of Madness, and it should be quick, Gate of Madness, I think. Oh, hello. I need to go to the merchant, wherever they are, over here, and just sell all my stuff. And then we should be good to go for there. Let's see if there's anyone in the party search. There is. Okay, so sell. We have a lot of these things to identify. That should be okay. So we're just going to sell some stuff here. Morganite mask. Are these... They're crafting materials, so we should keep them. Mummy wrapping. Sunburst spear. We can get rid of that one. And Johnny's boots. I'm fairly certain that no one cares about earth magic, so I think we can actually sell these as well. Earth prayers. Oh, maybe earth prayers people care about. This one... and I think Marganite armor down here. And now let's just identify everything and see if there's anything good that we got. So none of these are really... Yeah, because they're all weapons, it doesn't really matter too much. Health plus 30. Oh, actually, this one's not bad. Lengthen crippled duration by 33%. Has casting time of spells 9% though. I might just sell it anyway. Improve sale value. Let's see, what do we have? Spiked axe, measure for measure. Armor plus 4. Ideally, you want armor plus 5. And then the longbow here. So let me join this guy's party. Yeah, it should be fine. Oh, leave my own party and join this party. There we go. And then let's do some selling over here. So what do we have here? I think I need to sell this one. Oh, why am I the lead of the party? Who gave me a party search? Bunny. Okay, well should be fine. What are they running? Signet Spirits, yeah, cool. Let's see. LFG, Zaishin, mission, hard mode. Okay. 1 sec. Merching. Okay. What do we have here? I'm going to do, let's add this guy, join, and let's just go. So we can sell this guy. Yeah, I think we can sell all these guys basically. Except for maybe the Earth Prayers one. The rest of them are probably fine. Yeah, and then I'll just throw all of everything else in the Zunlai chest, and then we should be good to go. Who's this guy? Yeah, let's accept that one. What do we have? I already sent them a request, and now let's go to where's the Zunlai chest? Ah, there it is. Perfect. By the way, Peach Rules, thank you so much for following. Really appreciate it. Okay, so let's go here. Just drop all these guys in, and then we should be good to go. Oh, I have way too much wood, though, which is probably a good problem to have. So let me move this guy over here, just so I don't accidentally sell it, because I could use it later. And 1 second. Bones over here. Oh, I have too many bones as well. That's fine, I guess. And then I need to move the wood here. Perfect. Okay. I haven't done Jane Quarry in a year. Hasn't seen you. Okay. So I think we're good to go. Let's see. Who do we have for party menu, especially at? They seem to know you. Glad you guys know each other. Let's see. I think actually I feel like I know Toe Joe. I feel like I've heard the name before. So let's go over here. I'm gonna load a more like, I guess, more traditional build. Let's see. I was gonna go Imba. So Imbagon it's a build that basically means that you just do a lot more, like you basically have the amount of damage that your heroes or your allies take. Let's see, what do we have here? I'm gonna do one more LFG just to see if anybody else is looking for the group. But outside of that, yeah, I guess we had them. That's fine. Well, okay, maybe we do. Yeah, perfect. And let's just add this person as well. For some reason, or Ellie. They weren't responding to the party request, which is fine. I'm happy. So let's see. Let's see. I hate that I'm party lead here because it makes it seem like I know what I'm doing when I don't. We could probably do this. Actually, I mean, we just did the vanquishing, so like, if they're all at that level of difficulty, we should be fine. Yeah, so we'll just see what these guys say and go from there. I know the chat's been quiet. I'm sorry about that. I feel like, I don't know. We'll just see what they say. So right now, the way that this build works is basically I just do a lot of, actually I probably want to switch this so that, because we don't have anyone doing a lot of martial damage except for me. But essentially, the way it works is I gain a lot of adrenaline. I use that adrenaline to channel a shout. This shout doesn't last for very long. It's only like 4 to 5 seconds. I think it's 6 seconds at most. But the nice thing about it is that I was going imba. Let's see. But so we're trying to figure out who does what. I mean, I'm happy to add heroes, but let's see, what do we have here? They do damage, right? Like that's their thing. Vampirism, agony, bloodsong, Kemi Rose. Okay. Let's see, I don't really have a preference. Okay, so we'll just see what they say. I'm not too worried about it. Usually, it's sometimes difficult to find, a good group, so... but I think it's fine. We're doing fine. Okay. So let's see. What's Bella running? It's definitely not Blood is Power, which is what I usually use for Necros. Life transfer, necrosis. Okay. Sure. Okay, let's just, I think we need some more damage. I guess. Let's see. So the thing is, I don't know. I don't know how well Mesmer Way works. So the way it works right now is people usually just like put a bunch of Mesmers on their team. I mean, Ranger, a Necro, a Durv, and a Rit. Tojo is going to bring... They are bringing... Clamor of Souls. Oh, they're Rit. Oh, for some reason I thought they were a monk. Oh, no. Okay, that's fine. Channeling. I think... Okay, so maybe we're fine on damage. So we actually need... That's fine. I thought we were in an issue where we didn't have enough damage, but actually it looks like we don't have enough support, which is fine. Okay, yep, cool. Sure, we can add melee. I mean... let's see. What do we want here? There are so many options. The other Paragon left. Oh no, they said BRB. Okay, fine. Fair enough. We'll see. I'm just hoping we can get this group going soon, and just go ahead and go because, kind of a bit. This mission's a bit long, so I'm hoping to get through it. Well, I mean, if, sure. Okay, so they're doing, yeah, okay, this is fine. So we wait for, who was it that just left? Governatress? I don't remember. You'll need some healer at least. Yeah, I agree. Let's see. So we need... Yeah, we do need some support, but usually the Writs can do pretty well for support. Like, I don't usually run a monk. But I'm happy. Maybe we add a monk. A monk hero. Anyone a preferred healer? I mean, I think we're okay. I mean, we got a Derv, we got a Mesmer for damage, we got 2 Writs that can do a lot of damage. I'm gonna be imbaing. Everyone seems to know Toe, which is fine. I guess, yeah. Okay, so let's see, what do we have here? Oh, they're legit now. Ah, that's legit. Okay. Yep. Do we want the Necro? I can bring one. Oh, one. Hey, Guild War Coast, by the way, how are you? BIP Prot Hero. So what's my usual build? I think I just like ripped it from a... I think that's what I normally do. What is this? This is Restoration Magic. I usually do that. No, I usually do this one. That okay? What do they have? BIP Prot. I can do that as well. That's fine. Let's do Elias maybe. I usually do okay, so let's save this guy. I mean, why not? We can try it. So okay, actually what I'm gonna do is just save this as BIP Prot. Save. Yeah, actually, you're right. I'm already doing a lot of damage reduction. Yeah, correct. I'm going Imba. So I already have a lot of damage reduction. Everyone ready? Okay, should be good. Cool. Who do we have? We don't have too much. It's fine. Let's just go. We are ready. All right. Super excited. This mission used to be like one of the hardest ones in the game. Besides, like there is a Kurzik one in Factions that's a little bit, really difficult. But this one is was known for a while for being one of the more difficult ones. All right, so we're gonna see how well we do on this first group. It might go well, it might go poorly. I don't know. We'll see. But yeah, I'm also not arguing that this is the best Imbagon build either. It's just kind of what I run. So what do we have here? We've got the High Priest. Yep. Okay, so we're going to run that. Run this. That should be fine. They are perfect. Oh, what? Where'd my adrenaline go? Okay, that's fine. Oh, are we just failing miserably? I think we might be. That's okay. Olivia is having trouble. That's okay. Yeah, no, we're doing fine. We just weren't attacking the right people. Or I wasn't attacking the right person because, you know, whatever, we'll do fine. I've definitely had worse starts to this mission. So there should be a High Priest up there. And let's go. I'm just going to attack anyone because it doesn't really matter because my main thing is just keeping up a shout. So basically the way this build works is I just have to keep this shout running, which I'm not doing a very good job of right now because I'm just not paying attention. But that's okay. I'm just not hitting my rotations right, which is fine. I'm not used to this build so much. I should have gone with them, but I didn't. I forgot that these people popped up. That's fine. So we're just going to keep going. Right, perfectly fine. Yeah. Shambling Horror. I just completely forgot, like, Butterfly Mirror. I just don't remember this game at all. Shadow of Fear. Right, perfect. Give them a bit of a speed boost. Yeah, it should be easy, I think. We'll see. Titan Abomination. Man, they just ran in. They didn't even care. Holy cow. Like, something bad could have happened. Perfect. Oh, I keep hitting. The thing is, the shout doesn't last on me, so I always forget, like, how long it takes to, refresh and stuff. So I have to think, like, I have to, like, mentally count out, like, 5 seconds in my head just to make sure I remember. Oh, there we are, Madness Titan. Oh, I missed that one, but that's okay. Give everyone some damage reduction. Like, literally all I'm doing is just making it so my enemies take less damage. This one means that my enemies take 33% less damage. And then this one basically gives everyone plus 100 armor, which is 50% damage reduction against most attacks. Let's do it. Oh, hello. I was dumb. That's okay. Ah, the next one's way up there. Should be fine. Are we gonna go? Oh, I should have brought... it's okay. I didn't bring any condition removal. I should have, but I didn't. Nothing to fear is already super strong. Damage reduction. Yeah, like, we're fine. Like, I'm just being a bit... Like, I don't really... Imbagon's, like, one of my least favorite of the Paragon builds. I have made, like, hundreds of builds for Paragons before. Oop, that was a mistake. Oh, I just pressed the wrong buttons. That's okay. Should be fine. Oh, it's fine. But yeah. Anyway, the main reason for super boring, it's not bad. Like, the main question is, like, how you keep the adrenaline up and stuff like that. My favorite builds, actually, I love playing with echoes. Like, Heroic Refrain is good, but it's kind of like, I don't like it so much. Why? Am I just not hitting anybody? Am I just dumb? I might be just dumb. I'm sorry. It's fine. Like, I enjoy it because, like, trying to keep up the shouts for, like, you know, a long time, it's kind of difficult. It's not necessarily easy. Is there a High Priest or anything? No, not that I see. Cruel Spear is fine. I like it. I enjoy it. I'm not really much of a damage dealer. I kind of prefer support in this game. So I've made a whole bunch of, like, really good motivation builds and stuff like that for the Paragon that I really like. Like, honestly, you can do a lot of support as long as you get Finale for Frayne on your allies. Like, you can literally heal them up to full in, like, 2 seconds. It's insane. It's just that you also have to make sure that your build is the right one, right? Like your team build is correct. And so it can be a bit frustrating. Okay, we are all over the place, aren't we? That's okay. Should be fine. Yeah. Pre-nerf para was fun. Oh, but pre-nerf para, like, that was, like, literally the start of, like, the Paragon existed, and then the Paragon was immediately nerfed. Like, there was, like, basically no time in which the Paragon was not, like, was strong. But man, those days were fun. Like, I've played the Paragon since basically Nightfall came out, pretty much exclusively, too. I don't really play other professions very much. Are we actually supposed to go this way? I don't remember this at all. But that's okay, because I barely remember any of this game. Well, any of this particular mission. So, we're fine. So actually, some of my favorite, like, there's one build that I genuinely love that, like, no one else really, like, all I do, like, there's a way basically with the Paragon to, ooh, hello, everyone is dying because I'm being dumb. That's fine. Shoot, I have to, my, chotomate, sumimasen. Sorry, I had some issues there. My screen screwed up. But what was I saying? I was saying something about how, yeah, we should probably kill that group. It's fine, it's fine. Okay, maybe not. But yeah, what I was trying to say was, there's one build that I have that I genuinely love, and it's just such a stupid build. Like, all it is, I just use, oh, Shuriken, gotta love them. I just use, a lot of Paragon skills can do a lot of, dazed, and also can do a lot of fire damage, or like, burning. And so, like, I have one build that I used to use all the time that was super fun, and the entire purpose is just to keep, essentially just dazed and burning on an entire team. That's all it does. But it's fun. Like, I enjoy it. And, oh, I didn't realize there were this many people. I'm just being stupid. And I'm, like, not even trying. Like, maybe I should actually, like, play the game for a bit. You know? But no, I just decided I wouldn't. What do we have here? We got the warrior. We should probably attack the warrior here. Just give them some weakness. Do the same as the assassin. Probably the assassin would have been better. It's fine. But yeah, like the Paraway builds were super fun. Is that with the Mesmer skill? Yeah, so it's the only use I could find for the Mesmer skill. It was the Mesmer Elite skill, which was, there's a Mesmer Elite skill that's just the elite skill of Epidemic. It is, Extend Conditions, right? It was really the only use I could find for Extend Conditions. But hey, it works, and like I got through like a whole bunch of missions with it. In fact, I had to use it just recently one of my vanquishes. Ooh, hello. That Derv is way out in front and not under the effects of any of my shouts. That is okay. Yep, that's okay. We can still do this. I didn't bring a res though, so hopefully we're gonna be okay. Yep, now we have people coming up here. It'll be fine. We'll be fine. It's fine. Okay, we're okay. Livia's blood is power, so she's actually supposed to go down. Ah, the warlock. I always forget. It's fine. We're honestly breezing through this. We're doing fine. Perfect. Okay. Let's just keep going. Should be okay. I think we can just attack the group. I don't think we need to. Yeah, I think we're probably fine. Well, let's get some sort of adrenaline going, because otherwise, yeah, I don't need to use the shout just yet, but I will because I feel like it. And I can kind of I can't because I lost the. It's fine. Okay, looks good. Let's see, there's Warlock. I should probably get the Reaper. I just want to make sure that they have weakness on them. Weakness just makes it so the melee enemies do way less attack. There's a Word of Madness up here, but honestly, we're breezing through this. Like, no issues. I don't think you guys understand. Oh, by the way, Farley the Legend, like 3 minutes ago, thanks for follow. I really appreciate it. But I don't think you guys understand how hard this mission was for me the first time I played it. Like, I remember spending hours on this mission. And it was impossible for me when I was younger. Like, these Abomination Lords or whatever, Armageddon Lords, like, easy peasy. But, like, everyone else is, like, super difficult for me. Okay, let's keep going. Yeah, it should be easy. Like, we're not having any problem with it. But after this mission, I might kind of call it for the day. Yeah, we're doing okay. Oh, another fun build that I really enjoyed. So the thing about that one build I was saying before, that all it does is keep burning and, am I just not gaining adrenaline? So that build that all it does is like, essentially, keep dazed and, oh geez, Livia, you are struggling, aren't you? that keeps dazed and burning on everyone. There's actually another Paragon skill called They're on Fire, which basically means that you take 30% less damage from anyone who's on fire. So it was like a super good support build because it made it so casters couldn't cast anything because that's what Dazed does. And then it means that it meant that we took 30% less damage reduction from pretty much everybody. So it was really good actually. Like I quite enjoyed it. And I had this other build that I called the Echo build, and the whole point was just to use the Mesmer Elite Echo to echo echoes on the rest of my team, so I could, you know, like, just because echoes are like super powerful, so you can use them for a lot of stuff. Oh, should we not be attacking them? Whatever, who cares? Again, I'm not paying really any attention. I probably should be paying way more attention, but I'm not. Oh well, it's fine. Yeah, it should be fine. Yeah, let's go. But yeah, also I'm not super good at playing games on stream. I'm sorry about that. Like I'm trying, but I'm having a lot of trouble like balancing like watching the game or playing the game and like keeping up with chat and everything. So forgive me if I say or do something stupid. Like just all right, should be good. There's an Arm of Insanity coming up that I just aggroed. I just didn't even care. It's fine. It's fine. My issue is I only have one attack, and so if I want to like spam weakness on it, which is, you know, usually what I try to do for the melee characters. Is that it? Was that everyone? Can we just go to the front? I think we can. Yeah, so if I want to spam like weakness on them, which is again what I typically do for the melee characters, yeah, I can't really do that very well. He'll grab Shiro, really? So with this mission, the reason this mission is so difficult is because right now we're actually going to get into a very tough part where we essentially have to fight both bosses from the previous two games. This is Nightfall, so you have to fight the boss from Prophecies and also the boss from Factions at the same time. And I just realized I didn't bring a res. So if we might be, it could be in trouble here. But I think we're probably fine. So Shiro was super hard for me as well, like the first time I played. The Lich is coming up. She's probably fine. But also Shiro in Factions is way harder than Shiro here. I'm just watching just Olivia, just I hate the fact that they get so low so quickly because of Blood's power. And it just gets me. See, Livia, what were you doing? You kidding me? Oh, well. Why did I even... I'm just dumb. That's what I am. I just keep doing... Oh, God, you're... It's just so frustrating. Like, this game is... It's one of those things that, like... Yeah, I do play it because I find it quite... yeah, relaxing in a way. But at the same time, like... Yeah, it's definitely frustrating. Like, when... Okay, you're gonna die. Let's keep you from dying, shall we? Perfect. So we're not gonna attack the Lich, I don't think. I think we're gonna go around him and just ignore him for now. So I'm just gonna do this. Livia, don't die. Where's Livia? Livia died. Okay, it's fine. Just leave her. We are just all over the place. We're not even trying to stay, like, you know... where are we? We want to grab the... Oh, gee, who's dying? Who's dying? They're here. And I can't do anything about that right now because I have no adrenaline because I'm dumb. Dunkuro died as well? Okay, well, we are a little bit in trouble. What are we doing? Why are we just standing here? Look, I realize that Shiro can be killed in less than 10 seconds, but, like, I suck. I don't think you realize the amount of which I suck. So... Man, we are just, like, they're just going. Like, they're not paying any attention. Oh, also, I forgot that this build can't keep focused anger up all the time. So I'm struggling a bit because I completely forgot. Oh, Morganite Rose. Let's grab that. Yeah, that's fine. Oh, I forgot we needed to do the activation bit. Oh, yeah, that's why. Well, while we're here, might as well. Energy +3, Earth Magic +3, drink some alcohol, why not? Should be good to go. Ooh, that's bright. Livia's dead and we just didn't care. Oh, well. I forget why the Lich was so hard. I thought the Lich was hard because in order to beat the Lich at the end of the game, you had to like kill him on a very particular bloodstone or something like that. It was like difficult to do, but I don't remember him actually being a tough fight. Let's grab the cleric first. Sure, I think we're still doing fine. Yeah, fine. Another cleric. Oops. Should have brought, we're probably fine. Do we get it? Ooh. That was some damage. I have nothing. I usually have something to heal with, but I have nothing. No one brought flesh of my flesh or whatever? Like, okay, we're struggling a bit here. That's probably okay. We'll do okay. Oh, warlocks. Warlocks are the worst. That's why. Well of Silence. I hate Well of Silence. Okay, hello there. I can't do much right now. Well, we're struggling with this one a bit. It's probably okay. No, Torres, what are you doing? Tojo, get out. I have nothing. I have nothing to help you with. Oh, gosh. We just got to get the seers, and then we're good to go. Is Tojo with us? Did they make it? Okay, good. I have, like, one very small heal. Like, basically, if you're under 75% health, I can technically heal you. But it's definitely not something you go for. This is... We could be in trouble. Okay, hopefully... Is this the last one that we have to get? I mean, I can do some damage reduction. It's just, we're gonna have to... Is this it for the bonus, by the way? Did we get it? Yes. No, we didn't get it. We have one more... Isn't there one more shrine? Or did we get them? I have a feeling there's one more shrine. But maybe we were fine. I wasn't paying too much attention. Did we get it? Yeah, we got it. Thanks. Our healers died at the end. It was fine. It was fine. Let's go ahead and leave the party. In theory, you can dodge the liches and attacks. Yeah, I think so as well. I mean, we managed. It was fine. Cool. All right. So let's go ahead and turn those in, do some merchanting. And I think that'll be it for now. Let's go ahead and map travel back. But yeah, whatever you guys, I'm interested to hear what you guys think about, maybe doing some more gaming streams. I don't typically do gaming streams. Usually, we're pretty heavily on the science and tech category, but I don't know. I mean, maybe it's nice to hop on a different stream, try something different every now and again. Gate of Madness. For sure. Yeah, so these are actually both like relatively difficult missions today, so they're not usually that bad. So let's go here. I don't know how many I have to craft, but I just crafted them all. And let's just do some merchanting zoom line chest, and we'll kind of wrap up. So we'll see. But yeah, the thing is, I actually really like this game. Like I said before, like I'm kind of miserably addicted to this game. I don't know if it's a good type of addiction or a bad type of addiction, if I'm being honest, but I am really addicted. Like it's one of those things that I just spend a lot of time, like, I don't know, way too much time thinking about the builds and stuff like that. Would it be possible to finish Guild Wars without ever getting hit? I guess, I don't really know. Let's see. So I want to check for Earth Prayers. Earth Prayers is pretty good. Yeah, I should probably, this one, Earth Prayers. So I'm going to salvage that, and then we're going to sell the Earth Prayers one for 1K. Sounds good. What else do we have here? So this one, I think we could actually, I mean, don't think twice isn't perfect, but the health plus 30 is pretty good. Sword pommel and crippling sword hilt. But the thing is, I don't think people actually play sword anymore, so I don't think they'll actually go for too much in Camadon. But don't think twice would if it was 10%. I might just sell it. I might not go for it. So the other thing I'm looking for is Earth Magic. Earth Magic is probably not particularly pricey. No, Fire Magic is what everyone wants. Energy plus 3, again, I don't think, I like that one, but I don't think other people do. Yeah, so I think I can just sell those two. And the Fire Wand. Oop. Maybe for a caster, the plus 30. Yeah, but the plus 30 HP is the sword pommel, right? So I don't think a caster would be using the sword, right? I would imagine. Okay, so I'm just going to go ahead and sell these. Usually use plus armor. Do we have the plus armor? Where's the plus armor? Did I screw up? Yeah, I don't think I have a plus armor one. Shield set. Maybe. Yeah. Right, but that's not on the shield either. This is specifically sword pommel. So, anyway, I'm gonna go ahead and sell it, and people are gonna be mad at me. Who cares? Sell. Yep. Sure. Yep. Yeah, whatever. Okay, good. Then I'm gonna buy a few lockpicks, just so I have them in my inventory. Yeah, I should probably buy them at cheaper. I can technically buy them cheaper at Camadon. But yeah, so that's probably Guild Wars for today. I might consider playing it more often on stream. Obviously, when I switched to Guild Wars, there weren't too many people that were watching. But the thing is, I do genuinely like this game. It's super fun. I think that, you know, if people give it a chance, they'll really enjoy it. Again, the way I see it is an MMO, but I kind of treat it more as like a glorified deck building game. And in that way, it's actually really fun. Like it's a real-time card game, essentially. And that's the thing I really like about it. I just don't think there's other games like it on the market. And, you know, if I can do my part just to get a few more people to enjoy it, maybe that's good enough, you know? Like, I don't know. That's kind of where I'm at with it. Like, I kind of want more people to play because I feel like it is really a genuinely good game that I think a lot of people, like, they used to play a lot, but they kind of stopped. And I just kind of want to say, you know, there's still a good reason to play. Like, there's still a lot of people online, and it's still quite fun, I think. Anyway, I think that'll be it for today. That's been about 6 hours of streaming today, which is quite long for me. So tomorrow we'll get back to, we'll do programming stream for a bit where we're going to do finishing up the fractal generation stuff and all that kind of stuff. And then we'll hopefully maybe play a little bit more Guild Wars at the end. I don't know. We'll see what's up. But that's it for now. Thank you guys so much for coming in. I'm going to go ahead and see who is live and who we want to raid at the end of stream. We can do Tim. Who's live on Guild Wars? Maybe we want to do a Guild Wars raid. Let's see, hanging out. Are they using Paragon? No, I'd raid them if they were doing Underworld. Yeah, maybe. Yeah, okay, maybe we raid. Who is? Okay, Guild Wars Coast. You seem like someone, or I assume your name is Guild Wars Coast. You might have someone that you might want to raid. Feel free to let me know. Otherwise, I might do a science and tech streamer. And so we'll see. Let me get some water. Yeah, so I think, I just don't know these people, so I can't really vet them. So I might just go ahead and raid, Freckled Science, actually, who's doing dead beetles and, entomological art. So Sounds good to me. Let's go and start that raid on Freckled Scientist or Freckled Science. So we'll start the raid. If you don't know her, she's just a really cool person. I don't know. I think she does a really good stream. So let's go to start the raid on Freckled Science. Okay. Thank you guys so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you guys around next time for the next episode of Simuleos. We'll work on the fractal stuff again. Might do a bit of Guild Wars to wrap things up. Don't know. But yeah, we will talk tomorrow. Bye, guys.